Hello and welcome to Simplilearn. Today we have a session on the advanced concepts of machine learning. In today's rapidly evolving technological landscape, machine learning has emerged as a powerful tool that's transforming industries and reshaping our daily lives. Whether you are an aspiring data scientist, a business professional, or simply curious about this fascinating field, you have come to the right place. I am Abhisar. Welcome to the Advanced Machine Learning full course by Simplilearn, and I will be your guide as we embark on this journey to demystify the fundamentals of machine learning. So what exactly is machine learning? How does it work? And why is it so crucial today? Let's find out. Machine learning is a branch of artificial intelligence that focuses on developing algorithms and models capable of learning and making predictions or decisions without being explicitly programmed. It enables computers to automatically analyze and interpret vast amounts of data, uncover patterns, and extract valuable insights. In this session, we'll explore the key concepts that form the foundation of machine learning. We'll start by understanding the types of machine learning and their characteristics. We'll delve into supervised learning, where models learn from labeled data, and unsupervised learning, where models identify patterns in unlabeled data. We'll also touch upon reinforcement learning, which involves training models through interaction with an environment. Furthermore, we'll discuss the crucial steps of machine learning algorithms from linear regression to Naïve Bayes. We'll also address project topics like fake news detection, image classifications using CNN, and object detection, and many more, which will help you build your resume. By the end of this session, you will have a solid understanding of the advanced concepts of machine learning, enabling you to comprehend its application and challenges better. Whether you want to pursue a career in data science, collaborate with machine learning experts, or simply be an informed participant in today's data-driven world, this knowledge will undoubtedly prove invaluable. According to recent studies, AI and machine learning related job postings have increased by 344% in the past 5 years. Companies across the globe are actively seeking professionals who can harness the power of data and build intelligent systems. The average salary is $150,000 in US and 15 lakhs per annum in India. Hey everyone, welcome to Simplilearn's YouTube channel. But before we dive into that, don't forget to like, subscribe and share. There's no better time to train yourself in the exciting field of machine learning. If you're looking for a course that covers everything from the fundamentals to advanced techniques, for that accelerate your career in AI and ML with a comprehensive postgraduate program in AI and machine learning. Gain expertise in machine learning, deep learning, NLP, computer vision, and reinforcement learning. You will receive a prestigious certificate, exclusive alumni membership, and Ask Me Anything sessions by IBM with 3 capstone projects and 25 plus industry projects using real datasets from Twitter, Uber, and more. You will gain practical experience. Masterclasses by Caltech faculty and IBM experts ensure top-notch education. Simplilearn's Job Assist helps you notice by leading companies. This program covers statistics, Python, supervised and unsupervised learning, NLP, neural networks, computer vision, GANs, Keras, TensorFlow, and many more skills. Enroll now and unlock exciting AI and ML opportunities. The course link is mentioned in the description box below. So without any further delay, let's get started.
So why machine learning? Why do we even care about having these computers come up and be able to do all these new things for us? Well, because machines can now drive your car for you. It's still very in the infant stage, but it's just exploding, as we see with Google's Waymo, and then Uber had their program, which unfortunately crashed. They know that this is huge. This is going to be the huge industry to change our whole transportation infrastructure. Machine learning is now used to detect over 50 eye diseases. Do you know how amazing that is, to have a computer that double checks for the doctor for things they might miss? That's just huge in the health industry. Pretty soon they actually do already have that in some areas where maybe not for eyes, but for other diseases, where they're using the camera on your phone to help pre-diagnose before you go in and see the doctor. And because the machine can now unlock your phone with your face. I mean, that's just cool, having it being able to identify your face or your voice and be able to turn stuff on and off for you depending on where you're at and what you need. Talking about an ultimate automation, our world we live in. And as we dig in deeper, we have a nice example of Facebook. As you can see here, they have the Facebook post with Halloween. Comment yes if you want it. Order here. Nobody likes spam posts on Facebook that annoy them into interacting with likes, shares, comments, and other actions. I remember the original ones were all, if you don't click on here, you will have bad luck or some kind of fear factor. Well, this is a huge thing in a social media when people are getting spammed, and so this tactic, known as engagement bait, takes advantage of Facebook's newsfeed algorithm by choosing engagement in order to get the greater reach. To eliminate engagement bait, the company reviewed and categorized hundreds of thousands of posts to train a machine learning model that detects different types of engagement bait. So in this case we're using Facebook, but this is of course across all the different social media. They have different tools they're building. And the Facebook scroll GIF will be replaced. Kind of like a virus coming in there. It notices that there's a certain setup with Facebook and it's able to replace it. And they have like vote baiting, react baiting, share baiting. They have all these are kind of general titles, but there certainly are a lot of ways of baiting you to go in there and click on something. So they fed all this data was fed into the machine, and then they have the new post. The new post comes up that takes over part of the Facebook setup. And that's what you're looking at. You're looking at this new post that's replaced, like a virus has replaced that. So what Facebook did to eliminate this is they start scanning for keywords and phrases like this and checks the click-through rate. So it starts looking for people who are clicking through it without even looking at it, or clicking through it and it's not something that normally would be clicked through. Once Facebook has scanned for these keywords and phrases, it is now able to identify the spam coming in. And this makes your life easier, so you're not getting spammed. It's not like walking through an airport, and in a lot of countries you have like hundreds of people trying to sell you timeshare. Come join us, sign up for this. It eliminates that annoyingness, so now you can just enjoy your Facebook and your cat pictures, or maybe it's your family pictures. Mine is family. Certainly people like their cat pictures too. Another good example is Google's DeepMind project AlphaGo. A computer program that plays a board game Go has defeated the world's #1 Go player, and I hope I say his name right, Kiji. The Ultimate Go Challenge game of 3 of 3 was on May 27th, 2017, so it was just last year that this happened. And what makes this so important is that, Go is a game, so it's not like you're driving a car or something in our real world, but they are using games to learn how to get the machine learning program to learn. They want it to learn how to learn. And that is a huge step. A lot of this is still in its infant stage as far as development, as we saw what happened with the, as I referred to earlier, the Uber cars. They lost their whole division because they jumped ahead too fast. So it's still an infant stage, but boy, is this like the beginning of just an amazing world that is automated in ways we can't even imagine what tomorrow's going to look like. We've looked at a lot of examples of machine learning, so let's see if we can give a little bit more of a concrete definition. What is machine learning? Machine learning is the science of making computers learn and act like humans by feeding data and information without being explicitly programmed. And we see here we have a nice little diagram where we have our ordinary system. Your computer, nowadays you can even run a lot of this stuff on a cell phone because cell phones have advanced so much. And then with artificial intelligence and machine learning, it now takes the data and it learns from what happened before. And then it predicts what's going to come next. And then really the biggest part right now in machine learning that's going on is it improves on that. How do we find a new solution? So we go from descriptive, where it's learning about stuff and understanding how it fits together, to predicting what it's going to do, to post-scripting, coming up with a new solution. And when we're working on machine learning, there's a number of different diagrams that people have posted for what steps to go through. A lot of it might be very domain specific. So if you're working on photo identification versus language versus medical or physics, some of these are switched around a little bit or new things are put in. They're very specific to the domain. This is kind of a very general diagram. First, you want to define your objective. Very important to know what it is you're wanting to predict. Then you're going to be collecting the data. So once you've defined an objective, you need to collect the data that matches. You spend a lot of time in data science collecting data, and the next step, preparing the data. You got to make sure that your data is clean going in. There's the old saying, bad data in, bad answer out, or bad data out. And then once you've gone through and we've cleaned all this stuff coming in, then you're going to select the algorithm. Which algorithm are you going to use? You're going to train that algorithm. In this case, I think we're going to be working with SVM, the support vector machine. Then you have to test the model. Does this model work? Is this a valid model for what we're doing? And then once you've tested it, you want to run your prediction. You want to run your prediction or your choice or whatever output it's going to come up with. And then once everything is set and you've done lots of testing, then you want to go ahead and deploy the model. And remember I said domain specific. This is very general as far as the scope of doing something. A lot of models, you get halfway through and you realize that your data is missing something and you have to go collect new data because you've run a test in here someplace along the line. You're saying, hey, I'm not really getting the answers I need. So there's a lot of things that are domain specific that become part of this model. This is a very general model, but it's a very good model to start with. And we do have some basic divisions of what machine learning does that's important to know. For instance, do you want to predict a category? Well, if you're categorizing things, that's classification. For instance, whether the stock price will increase or decrease. So in other words, I'm looking for a yes-no answer. Is it going up or is it going down? And in that case, we'd actually say, is it going up? True. If it's not going up, it's false, meaning it's going down. This way, it's a yes-no, 0, 1. Do you want to predict a quantity? That's regression. So remember, we just did classification. Now we're looking at regression. These are the two major divisions in what data is doing. For instance, predicting the age of a person based on the height, weight, health, and other factors. So based on these different factors, you might guess how old a person is. And then there are a lot of domain-specific things, like do you want to detect an anomaly? That's anomaly detection. And this is actually very popular right now. For instance, you want to detect money withdrawal anomalies. You want to know when someone's making a withdrawal that might not be their own account. We've actually brought this up because this is really big right now. If you're predicting the stock, whether to buy stock or not, you want to be able to know if what's going on in the stock market is an anomaly. Use a different prediction model because something else is going on. You got to pull out new information in there. Or is this just the norm? I'm going to get my normal return on my money invested. So being able to detect anomalies is very big in data science these days. Another question that comes up, which is on what we call untrained data, is do you want to discover structure in unexplored data? And that's called clustering. For instance, finding groups of customers with similar behavior given a large database of customer data containing their demographics and past buying records. And in this case, we might notice that anybody who's wearing a certain set of shoes goes shopping at certain stores, or whatever it is, they're going to make certain purchases. By having that information, it helps us to market or group people together so that we can now explore that group and find out what it is we want to market to them if you're in the marketing world. And that might also work in just about any arena. You might want to group people together, whether they're based on their different areas and investments and financial background, whether you're going to give them a loan or not. Before you even start looking at whether they're a valid customer for the bank, you might want to look at all these different areas and group them together based on unknown data. So you don't know what the data is going to tell you, but you want to cluster people together that come together. Let's take a quick detour for quiz time. Oh, my favorite. So we're going to have a couple questions here under our quiz time. And we'll be posting the answers in the part 2 of this tutorial. So let's go ahead and take a look at these quiz times questions, and hopefully you'll get them all right, and it'll get you thinking about how to process data and what's going on. Can you tell what's happening in the following cases? Of course, you're sitting there with your cup of coffee, and you have your checkbox and your pen trying to figure out what's your next step in your data science analysis. So the first one is grouping documents into different categories based on the topic and content of each document. Very big these days. You have legal documents, you have maybe it's a sports group documents, maybe you're analyzing newspaper postings. But certainly having that automated is a huge thing in today's world. B, identifying handwritten digits in images correctly. So we want to know whether they're writing an A or capital A, B, C. What are they writing out in their handwriting? C, behavior of a website indicating that the site is not working as designed. D, predicting salary of an individual based on his or her years of experience. Boy, HR hiring set up there. So stay tuned for part 2. We'll go ahead and answer these questions when we get to the part 2 of this tutorial. Or you can just simply write at the bottom and send a note to Simplilearn, and they'll follow up with you on it. Back to our regular content. And these last few bring us into the next topic, which is another way of dividing our types of machine learning, and that is with supervised, unsupervised, and reinforcement learning. Supervised learning is a method used to enable machines to classify, predict objects, problems, or situations based on labeled data fed to the machine. And in here you see we have a jumble of data with circles, triangles, and squares, and we label them. We have what's a circle, what's a triangle, what's a square, and we have our model training, and it trains it so we know the answer. Very important, when you're doing supervised learning, you already know the answer to a lot of your information coming in. So you have a huge group of data coming in, and then you have new data coming in. So we've trained our model. The model now knows the difference between a circle, a square, a triangle, And now that we've trained it, we can send in this case, a square and a circle goes in, and it predicts that the top one's a square and the next one's a circle. And you can see that this is being able to predict whether someone's going to default on a loan, because I was talking about banks earlier. Supervised learning on stock market, whether you're going to make money or not. That's always important. And if you are looking to make a fortune in the stock market, keep in mind it is very difficult to get all the data correct on the stock market. It is it fluctuates in ways really hard to predict. So it's quite a roller coaster ride. If you're running machine learning on the stock market, you start realizing you really have to dig for new data. So we have supervised learning. And if you have supervised, we should need unsupervised learning. In unsupervised learning, machine learning model finds the hidden pattern in an unlabeled data. So in this case, instead of telling it what the circle is and what a triangle is and what a square is, it goes in there and looks at them and says, for whatever reason, it groups them together. Maybe it'll group it by the number of corners. And it notices that a number of them all have 3 corners, a number of them all have 4 corners, and a number of them all have no corners. And it's able to filter those through and group them together. We talked about that earlier with looking at a group of people who are out shopping. We want to group them together to find out what they have in common. And of course, once you understand what people have in common, maybe you have one of them who's a customer at your store, or you have 5 of them are customer at your store, and they have a lot in common with 5 others who are not customers at your store. How do you market to those 5 who aren't customers at your store yet? They fit the demographics of who's going to shop there, and you'd like them to shop at your store, not the one next door. Of course, this is a simplified version. You can see very easily the difference between a triangle and a circle, which might not be so easy in marketing. Reinforcement learning. Reinforcement learning is an important type of machine learning where an agent learns how to behave in an environment by performing actions and seeing the result. And we have here where in this case, a baby. It's actually great that they used an infant for this slide because the reinforcement learning is very much in its infant stages. But it's also probably the biggest machine learning demand out there right now, or in the future, it's going to be coming up over the next few years, is reinforcement learning and how to make that work for us. And you can see here where we have our action. In the action in this one, it goes into the fire. Hopefully the baby it was just a little candle, not a giant fire pit like it looks like here. When the baby comes out, and the new state is the baby is sad and crying because they got burned on the fire. And then maybe they take another action. The baby's called the agent because it's the one taking the actions. And in this case, they didn't go into the fire. They went a different direction, and now the baby's happy and laughing and playing. Reinforcement learning is very easy to understand because that's how, as humans, that's one of the ways we learn. We learn whether it is, you burn yourself on the stove, don't do that anymore. Don't touch the stove. In the big picture, being able to have a machine learning program or an AI be able to do this is huge because now it's starting to learn how to learn. That's a big jump in the world of computer and machine learning. And we're going to go back and just kind of go back over supervised versus unsupervised learning. Understanding this is huge because this is going to come up in any project you're working on. We have in supervised learning, we have labeled data, we have direct feedback. So someone's already gone in there and said, yes, that's a triangle. No, that's not a triangle. And then you predict an outcome. So you have a nice prediction. This new set of data is coming in and we know what it's going to be. And then with unsupervised training, it's not labeled. So we really don't know what it is. There's no feedback. So we're not telling it whether it's right or wrong. We're not telling it whether it's a triangle or a square. We're not telling it to go left or right. All we do is we're finding hidden structure in the data, grouping the data together to find out what connects to each other. And then you can use these together. So imagine you have an image and you're not sure what you're looking for. So you go in and you have the unstructured data, find all these things that are connected together. And then somebody looks at those and labels them. Now you can take that labeled data and program something to predict what's in the picture. So you can see how they go back and forth and you can start connecting all these different tools together to make a bigger picture.
Everyone knows the algorithm is a step-by-step process to approach a particular problem. There are numerous examples of algorithms, from figuring out sets of numbers to finding routes through maps to showing data on a screen. Let's understand this by using an example. Every algorithm is built on inputs and outputs. Google search algorithm is no different. The input is the search field and the output is the page of result that appears when you enter a particular phrase or keyword, also known as SERP or search engine result page. Google has a search algorithm so it can sort results from various websites and provides the user the best result. When you start a search, you will see the search box. Will attempt to guess what you are looking for. In order to better understand what the user is looking for, the algorithm is trying to gather as many as suggestions from them as possible. The results from the search field that best matches the query will be ranked. The choose with website will rank and in what position using more than 200 ranking variables. Now let's take an example of coding program and see how the algorithm works. Here, we will use a case of computer program wherein we want to print the multiplication table of any number. Let's take 2. The algorithm start here and then it assign a value to a variable. The variable I is having an initial value of 1. The system will read the number. The number in case is 2. Now, the system has a condition. A condition can now either be true or false. If the value of I reaches 11, then the loop will end. Otherwise, value of I will multiply by the number. The initial value of I is 1. So, for the first time, the system output will be 2. Now, value of I will be increased by 1. According to the loop condition, the system will then move back and check for the condition again. The new value of I is 2, which is still less than 11. The system will again print 2 into I, which is 2 into 2 on the screen. The new output result will be 4. The system will keep following the same procedure repeatedly until the value of I becomes 11. Once the value of I becomes 11, then only the algorithm will terminate. After discussing how an algorithm works, let's move forward and see some popular machine learning algorithms. Some popular machine learning algorithms are: first one is linear regression algorithm, second one is logistic regression algorithm, and the third one is decision tree, and the fourth one is support vector machine algorithm SVM, and the fifth one is KNN, K nearest neighbor algorithm, and the sixth one is K means clustering algorithms. And the seventh one is random forest algorithms. And the last but not the least algorithm is a priori algorithms. Let's go through them in detail one by one. Linear regression is one of the most famous and straightforward machine learning algorithms utilized for predictive analysis. Linear regression shows the linear connection between the dependent and the independent factors. The equation of line is y equals to mx plus b. Here, y stand for the response variable or a dependent variable, whereas x is for the predator variable or an independent variable. It attempts best to fit line between the dependent and the independent variables, and this best fit line is known as line of regression or regression line. Let's take a real application example. In predicting consumer behavior, businesses use linear regression to forecast things like how much a client is likely to spend. Things like targeted marketing and product development may benefit from this. Walmart, for instance, used linear regression to forecast which good would be in high demand across the nation. Moving forward, let's see types of linear regression. There are two types of linear regression algorithm. The first one is simple linear regression and the second one is multiple linear regression. In simple linear regression, if an independent variable is utilized to forecast the worth of a mathematical dependent variable, then at that point, such a linear regression algorithm is called simple linear regression. The equation of line will be y equals to a0 plus a1x. And the second one is multiple linear regression. If the dependent variable declines on the y and the independent variable on the x, then such a relationship is known as negative linear relationship. The line of equation will be minus of a0 plus a1x. Moving forward, let's see logistic linear regression. Logistic regression is the supervised machine learning algorithm utilized to anticipate all the categorical factors or discrete values. It could be very well used for the grouping issues in machine learning. And the result of the logistic regression can be either yes or no, 0 or 1, man or woman, and so on. It gives the values which lies between 0 and 1. For example, a credit card business is interested in knowing whether the transaction amount and the credit score have an impact on the probability that a particular transaction would be fraudulent. The business can use logistic regression to determine how these two predictor values can relate the probability that a transaction is fraudulent. The response variable in the model has two possible outcomes. First one is the transaction is fraudulent, and the second one is the transaction is not fraudulent. In logistic regression, rather than fitting a regression line, we fit an S-form logistic capability, which predicts two greatest values, 0 or 1. The logistic regression equation can be calculated from linear regression equation. The steps to get logistic regression equations are: the equation of a straight line can be written as y equals to b0 plus b1 x1 plus b2 x2 till bn xn. In logistic regression, y can be between 0 and 1 only. So for that, let's divide the above equation by 1 minus y. Then the equation will be y upon 1 minus y, that is 0 for y0 and infinity for y equals to 1. But range between minus infinity to plus infinity, then we have to take the logarithm of equation, and now it will become log of y upon 1 minus y equals to b0 plus b1 x1 plus b2 x2 so on till bn xn. Let's move forward and see types of logistic regression. There are three types of logistic regression that can be classified. First one is binomial. In binomial logistic regression, there can be only two possible types of dependent variables like yes or no, pass or fail, man woman, and many more. And the second one is multinomial. In multinomial logistic regression, there can be three or more possible unordered ways of dependent variable such as horse, cow, and sheep. And the last one is ordinal. In ordinal logistic regression, there can be three or more possible ordered ways of dependent variable, such as small, medium, or large. Moving forward, let's see decision trees in detail. A decision tree is a tree structured classifier that could be used for classification and regression. A decision tree is a tree in which each non-leaf node is assigned to an attribute. Additionally, each arc contains one of the available values for its parent node, which is associated with each leaf node, that is, the node from where the arc is directed. Let's see some decision tree terminology. First one is root, that contains the entire data set. The next one is node, a test for the data of a certain attribute. And the third one is branch, which connect the node to internal node or the internal node to leaf node. And the fourth one is leaf node, the terminal node that predicts the outcome. Let's move forward and see decision tree algorithms. The first one is select the best attribute to use the current node in the tree. The second one is for each possible values, select the attributes. The third one is partition the examples using the possible values of this attribute and assign these disjoint subset of the example to the appropriate child node. Recursively generate each child node until ideally all examples for a node have the same label, like class. Moving forward, let's understand the decision tree. For building a decision tree, step 1 is select an attribute. Then split the data into its children in a tree. Continue splitting with available attributes and keep splitting until leaf nodes are pure, like only one class remains, a maximum depth is reached, a performance metric is achieved. Let's move forward and see SVM algorithm, support vector machine algorithms. A support vector machine is a well-known supervised machine learning model. It is utilized for both information, classification, and regression. It is regularly utilized for the grouping issues. We can involve it in different life care systems, and we can involve it in typically happy or sad look arrangements. We can involve it in filters. If we make specific looks, it would add the particular filter according to the expression. The scope of articulation lies between happy and sad. Support vector machine helps in to recognize handwritten characters used widely, like checks continue to be a significant part of the majority of non-cash transactions and are frequently written by the pupil. The current check processing system in many developing nations involves a bank employee to read and manually enter the information in a check, while also verifying the data like signature and date. A handwritten text recognition system can reduce expenses and labor hours because a bank must handle several checks each day. Moving forward, let's see the algorithm of SVM. The objective of support vector machine is to make the best line or choice limit that can isolate n-dimensional space into classes. So we can undoubtedly put the new data of interest in the right category. Later on, this best decision boundary is known as a hyperplane. Let's move forward and see types of support vector machine. Support vector machine can be of two types. First one is linear SVM, second one is non-linear SVM. Let's move forward and see linear SVM. Linear SVM is utilized for linearly detachable information, which implies if a dataset can be ordered into two classes by utilizing a straight line, then such information are named linearly separable information. And a classifier is utilized called linear SVM classifier. Moving forward, let's see nonlinear SVM. Nonlinear SVM is utilized for non-directly isolated information, and that implies in the event that a dataset can't be categorized by utilizing a straight line. Such information is named non-directed information, and the classifier utilized is called a nonlinear SVM classifier. Moving forward, let's see KNN algorithm in detail. KNN is a supervised learning technique. KNN classifies new data into a targeted classes depending on the features of its neighboring points and also be used for the regression problems. It is an instance-based learning algorithm and a bit lazy learning algorithm. KNN calculation stores every one of its accessible information and orders another information point based on the likeliness. This means that when new data information appears, it usually tends to be successfully categorized into a good suit classes using the KNN algorithm. Let's imagine we have an image of animal that resembles a cow or ox. However, here we are not sure if it is a cow or ox. As KNN method is based on a likeness matrix, it will identify the properties of new data that are related to the image of cow or ox. And based on those quality, it will classify the data as belonging to either cow or ox group. Moving forward, let's see how does KNN work. The steps to implement KNN algorithms are: Step 1. Decide on the neighbors' k numbers. Step 2. Calculate the Euclidean distance between k neighbors in step 2. Third one is, based on the determined Euclidean distance, select the k closest neighbors. Step 4 is, count the numbers of data points in each category between these k neighbors. Step 5. Assign the fresh data points in the category where the highest neighbors count. And then KNN model is ready. Let's say we need to add a new data point to the vital category. At first, we will decide on the numbers of neighbors. Therefore, we will pick k equals to 5. Then, the Euclidean distance between the data points and then can be determined. The distance between two points known as the Euclidean distance can be determined by under root of x2 minus x1 ka whole square plus y2 minus y1 whole square. Then we determine the closest neighbors by calculating the Euclidean distance. There are three closest neighbors in category A and two closest neighbor in category B. This new data point must fall with category A because as we can see, its three closest neighbors are also from group A. After understanding KNN algorithm, let's move forward and see k-means algorithms in detail. The k-means is a cluster false. Under that is an unsupervised learning algorithm. It is used to address machine learning clustering problems and utilized to tackle the grouping issues in machine learning. It permits us to bunch the information into various gatherings. It is a helpful method for finding the classification of groups in the unlabeled dataset without the requirement of any training. This k-means algorithm groups the data into similar classes. Let's see some application of k-means clustering. Let's see some applications of k-means clustering. Diagnostic system. The medical profession uses k-means clustering in creating smarter medical decision support system, especially in the treatment of liver alignments. The second one is search engines. Clustering forms a backbone of search engine. When a search engine is performed, the search result need to be grouped, and the search engines very often use clustering to do this. Moving forward, let's see how k-means algorithm works. The steps to implement k-means algorithms are: Step 1. Select the number k to set the number of clusters. Step 2. Select a random k points or centroid. Step 3. Assign each data point the closest centroid that forms to predefined k cluster. Step 4. Determine the variance and set a new gravity points for each cluster. Step 5. Repeat the third step. This means reallocating each data point to the new closest centroid cluster. Step 6. If a reassignment occurs, go to step 4, otherwise go to exit. Step 7. The model is ready to use. So now we have a clear understanding of how k-means algorithm work. Let's move forward to see the graphical representation of k-means algorithm. Consider that there are two variables m1 and m2. This is a scatter plot of these two variables along the x and y axis. We should accept the number of k of bunches, that is k equals to 2, to recognize the dataset and to place them into various groups. It implies here we will attempt to bunch these datasets into two unique groups. We will really want to pick an irregular k point or centroid to frame this group. These centroids can be either the focus of the dataset or some of other points. Thus, here we are choosing under 2 points as k points, which are not the piece of our dataset. We will assign every data of interest in the scatter plot to the nearest k point or centroid. We will register it by applying some math that we consider to find the distance between 2 points, that is Euclidean distance. Thus, we will draw a median between both the centroids. From the graph, the left half of the line are close points to the right and the k1 centroid. Green is near the orange centroid. We should variety them as green and orange for clear representation. As the need might arise to track down the nearest group, we will repeat the cycle by picking another centroid. To pick the new centroid, we will figure out the center point of gravity of these centroids and will track down new centroids. Then we will reassign every piece of information to highlight new centroid. For this, we will repeat a similar course of tracking down a middle line. The middle will be like as seen in the picture. One orange point is on the left half of the line and two green points are on the right. Thus, these 3 points will be appointed to the new centroids. As reassignment has occurred, we will again go to step 4, tracking down new centroids or k points. We will repeat the cycle by tracking down the center point of gravity of centroids. So the new centroids will be displayed as like this. We now have new centroids, so once more define the middle boundary and reassign the data of interest. By this graph, there are no unique pieces of information on one or the other side of the line, implying our model is shaped. By the previous graph, there are no unique pieces of information on one or the other line, implying our model is shaped. As our k-means model is ready, and the two last groups will be displayed as like these. Now we have a clear understanding of how k-means clustering algorithm works. Now let's move forward to understand random forest algorithm. Random forest is an adaptable, simple to utilize machine learning algorithm that produces, even without the hyperboundary tuning, an extraordinary outcome more often than not. It is likewise quite possibly the most utilized algorithm because of its effortlessness and variety. Like it tend to be utilized for both grouping and classification tasks. Random forest is a classifier that contains various choice trees on different subsets of the given dataset and takes the normal to work on the present exactness of the dataset. Instead of depending on the choice tree, the random forest takes the forecast from each tree and in light of the larger part of votes of expectation, it predicts the final result. Now let's move forward and see how does random forest work. We should see the random forest in order since the arrangement is now and again thought to be the structured block of machine learning. This is what a random forest would look like with two trees. The random forest has a similar hypermeter to the decision tree or a Bayesian classifier. Luckily, there is a compelling reason need to consolidate a decision tree with a Bayesian classifier, since you can undoubtedly utilize the classifier classes of random forest. With random forest, you can likewise manage tasks using the algorithm regression. Random forests add extra arbitrariness to the model while developing the trees. Rather than looking for the main element while parting a node, it looks to the best component among an irregular subset of highlights. These outcomes in a wide variety often result in a superior model. Subsequently, in a random forest, just a random subset of the element is thought about the algorithm. You might make trees more random by involving random edges for each component instead of looking for the most ideal limits like a typical choice tree does. Let's move forward and see some application of random forest algorithms. Random forest is involved at work by researchers in numerous ventures, including banking, stock exchanging, medication, and many more. It is utilized to predict things which assist these businesses with running productively, like client activity, patient history, and safety. In banking, random forest is used to identify clients who are more likely to pay back their debts on schedule. Additionally, it is utilized to forecast who will make more frequent use of bank services. Even fraud detection uses it. The Robin Hood of algorithms, indeed. Random forest is a tool used by stock traders to forecast future stock behavior. Retail businesses utilize it to make product recommendation and forecast client satisfaction. Random forests can be used in healthcare industry to examine a patient medical history and detect disorders. Random forest is a tool used by pharmaceutical experts to determine the ideal mix of ingredients in treatment or to forecast drug sensitivity. By seeing application of random forest algorithm, let's move forward and see some difference between decision trees and random forest. Let's see the difference between random forest and decision tree. The first one is while building a random forest, the number of rows is selected randomly. In decision trees, it builds several decision trees and find out the output. The second one is it combines two or more decision trees together. In decision trees, whereas the decision is a collection of variables or datasets or attributes. The third one is it gives accurate results, whereas it gives less accurate results. The fourth one is by using random forest, it reduces the chance of overlifting, whereas decision trees it has the possibility of overlifting. The fifth one is random forest is more complicated to interpret, whereas the decision tree is simple, it is easy to read and understand. After seeing what is random forest, how it works, let's move forward to see a priori algorithms in detail. The a priori algorithm utilizes standard item sets to create affiliation rules and is intended to chip away the information bases containing exchanges. With the assistance of these affiliation rules, it decides how firmly or feebly two objects are associated. This algorithm utilizes a breadth first search and hash tree to work out the item set association effectively. It is the iterative interaction for finding out the successive item set from the huge dataset. Let's move forward and see steps for a priori algorithms. The steps for a priori algorithms are step 1 is establish minimal support and confidence for item set in the transactional database. The second one is take all transaction supports with a greater support value, the minimum or chosen support value in step 2. The third one is track down all the rules in these subsets with confidence value greater than the threshold value. The fourth one is arrange the rules to lower the lift. At last, we will see some advantages and disadvantages of a priori algorithm. The advantages of a priori algorithms are easy to understand an algorithm, and the second one is the join and prune steps of the algorithms can be easily implemented on the large dataset. The disadvantages of a priori algorithms are the a priori algorithms work slowly as compared to the other algorithm. And the second one is the a priori algorithms times and space complexity are O of 2D, which is very low compared to the other ones. Let's move forward and see some hands-on lab demo. So we will see a hands-on lab demo on linear regression. As we know, linear regression is a way to find or to predict the relationship between two variables. Generally, we use x and y. So first we will open command prompt to write command to open Jupyter Notebook. So we will here write Jupyter Notebook and then press enter. So this is the landing page of Jupyter Notebook and select open. new Python file. So this is how Jupyter Notebook UI looks like. So at first we will import some major libraries of Python, which will help us in mathematical functioning. So the first one is NumPy. NumPy is a Python library used for working with arrays. It also has functions for working in domains like linear algebra and matrices. It is an open source project and you can use it freely. NumPy stands for numerical Python. So we will write like import NumPy as NP. Here NP is used for denoting NumPy. So we will import the next library is Pandas. Pandas is a software library written for Python programming for like data manipulation and analysis. In particular, it offers data structures and operation for manipulating numerical labels and time series. So we will write import pandas as PD. Here, PD is used for denoting pandas. So our next library is matplotlib. Matplotlib is a graph plotting library in Python that serves as a visualization utility. Matplotlib is open source, so we can use it freely. And it is most written in Python, a few segments in C and JavaScript for platform compatibility. For importing matplotlib, you have to write import matplotlib dot pyplot as plt. So after importing the libraries, we will move ahead and import dataset. So for importing dataset, we have to write dataset equals to pd dot read underscore csv, and here we have to give the path of the file dataset dot csv. Here pd is for pandas library and read is used for reading the dataset from the machine, and csv is used for the type of file which you want to read. So after reading, let's see our data. So we will write dataset dot head and press enter. Here head is used for retrieving the first 5 lines from the data, so our data is coming properly. So moving ahead, now let's first define x and y axis. For x, we have to write x equals to dataset dot ilog bracket colon comma colon again -1 dot values for x axis, and for y axis we have to write y equals to dataset dot ilog bracket colon comma 1 dot values. So if we will use dataset dot ilog for -1 values for x axis, it will select till the second last column of the data frame instead of the last column. And I know this is as the second last column value and the last column value for the row is different. Whereas if we will use for the y-axis, values return a series vector. A vector does not have a column size. So moving ahead, let's see the value for x and y-axis. First, we will see the value for x, like just you have to write x and press enter. So these are the arrays value for x, and for y-axis you have to type y and then enter. So these are arrays value for y-axis. So after this, now let's split the dataset into training and testing. Separating data into training and testing set is an important part for evaluating data mining models. Typically, when you separate a dataset into a training set and a testing set, most of the dataset is used for training and a similar portion of dataset is used for testing. So we will split it into 70 and 30 ratio. So for splitting, we need to import some more libraries for this process. So we will write from sklearn dot model underscore selection import train underscore test underscore split. Scikit-learn, like sklearn, is most useful and robust library for machine learning in Python. It provides a selection of efficient tools for machine learning and statistical modeling, including classification, regression, and clustering. So after importing, let's write code for the splitting data. So we will write here x underscore train comma x underscore test, comma y underscore train, comma y underscore test equals to train underscore test underscore split. In brackets we have to write x comma y comma test underscore size equals to 0.3 comma random underscore state equals to 0. Random is with random state equals to 0, we get the same train and test sets across different execution. So after this, let's see the values together. So we will write x underscore train comma x underscore test comma y underscore train comma y underscore test. So these are the values of array x and array y together. Moving ahead, now let's work with regression. First, we need to import the library for regression. So we will use from sklearn dot linear underscore model import linear regression. We already discussed sklearn is used for machine learning and linear regression is a major part of machine learning. So after this, let's make a function for regression as reg for easy use. So we will write reg equals to linear regression and brackets. First we try to train and then test and compare. So we will write here reg dot fit bracket x underscore train comma y underscore train. Now let's predict values, but prediction values are always different. So we will predict values for y first. So we will write y underscore predict equals to reg dot predict or x underscore test. So like y underscore predict, then enter. This is when the predict functions come into the picture. Python predict function enables us to predict the labels of the data values on the basis of training model. The predict function accepts only a single argument, which is x underscore test here, usually the data to be tested. So when you will check the value for y test, you will see the different values like y underscore test. So you can see there are totally different values from x-axis. Now let's display on graph for training dataset. So we have to write plt dot scatter x underscore train comma y underscore train comma color equals to, you can choose by yourself, I will choose red, and then plt dot plot x underscore train comma regression point for predicting values for x underscore train comma color equals to blue. So this color is for the regression line, and the plt dot title linear regression salary versus experience, and I will prefer the size would be 18. So let's set the labels for x and y axis. So x label year of employee, comma size will be, I will prefer size will be 50. Then for y axis we will write here like salaries of employee. And I will prefer the same size 15. Let's show the plot by writing plt.show. Then hopefully we are fortunate, everything is going to be fine. Perfect. So you can see we have linear regression line fitting through our data set. So this is how the linear regression work for training data set. Let's see how it will work for testing data set. Now let's predict for test data set. You can copy for the same and like you can change it. So we can copy here. So we can paste here. So we have to just change here train to test data set. Test here, then again test here, then again test here. Everything we will reduce some size to 16. Let's see, then it will reduce 12 and it will be 12 and so perfect. So you can see we have linear regression line fitting through our data set. So this is how the linear regression works for testing data set.
What is the sci-ket-learn? It's simple and efficient tool for data mining and data analysis. It's built on NumPy, SciPy, and Matplot library, so it interfaces very well with these other modules. And it's an open source, commercially usable BSD license. BSD originally stood for Berkeley Software Distribution License, but it means it's open source with very few restrictions as far as what you can do with it. Another reason to really like the sci-ket-learn setup, so you don't have to pay for it as a commercial license versus many other copyrighted platforms out there. What we can achieve using the sci-ket-learn, we use the two main things are classification and regression models. Classification, identifying which category an object belongs to. For one application very commonly used is spam detection. So is it a spam or is it not a spam? Yes, no. In banking, it might be, is this a good loan, bad loan? Today we'll be looking at wine. Is it going to be a good wine or a bad wine? And regression is predicting an attribute associated with an object. One example is stock prices prediction. What is going to be the next value? If the stock today sold for $23.05 a share, what do you think it's going to sell for tomorrow and the next day and the next day? So that'd be a regression model. Same thing with weather forecasting. Any of these are regression models where we're looking at one specific prediction on one attribute. Today we will be doing classification. Like I said, we're going to be looking at whether a wine's good or bad. But certainly the regression model, which is in many cases more useful because you're looking for an actual value, is also a little harder to follow sometimes. So classification is a really good place to start. We can also do clustering and model selection. Clustering is taking an automatic grouping of similar objects into sets. Customer segmentation is an example. So we have these customers like this, they'll probably also like this. Or if you like this particular kind of features on your objects, maybe you like these other objects. So it's a referral is a good one, especially on Amazon.com or any of your shopping networks. Model selection, comparing, validating, and choosing parameters and models. Now, this is actually a little bit deeper as far as a sci-ket-learn. We're looking at different models for predicting the right course or the best course or what's the best solution. Today, like I said, we're looking at wines. So it's going to be, well, how do you get the best wine out of this? So we can compare different models, and we'll look a little bit at that, and improve the model's accuracy via different parameters and fine-tuning. Now, this is only part one, so we're not going to do too much tuning on the models we're looking at, but I'll point them out as we go. Two other features, dimensionality reduction and pre-processing. Dimensionality reduction is we're reducing the number of random variables to consider. better. This increases the model efficiency. We won't touch that in today's tutorial, but be aware if you have, thousands of columns of data coming in, thousands of features, some of those are going to be duplicated, or some of them you can combine to form a new column. And by reducing all those different features into a smaller amount, you can increase the efficiency of your model. It can process faster, and in some cases you'll be less biased, because if you're weighing it on the same feature over and over again, it's going to be biased to that feature. And pre-processing. These are both pre-processing, but pre-processing is feature extraction and normalization. So we're going to be transforming input data such as text for use with machine learning algorithms. We'll be doing a simple scaling in this one for our pre-processing, and I'll point that out when we get to that, and we can discuss pre-processing at that point. With that, let's go ahead and roll up our sleeves and dive in and see what we got here. Now, I like to use the Jupyter Notebook, and I use it out of the Anaconda Navigator. So if you install the Anaconda Navigator, by default it will come with the Jupyter Notebook, or you can install the Jupyter Notebook by itself. This code will work in any of your Python setups. I believe I'm running an environment of 3.7 setup on there. I'd have to go in here into environments and look it up for the Python setup. But it's one of the 3X's. And we go ahead and launch this, and this will open it up in a web browser. So it's kind of nice. It keeps everything separate. And in this Anaconda, you can actually have different environments, different versions of Python, different modules installed in each environment. So it's a very powerful tool if you're doing a lot of development. And the Jupyter Notebook is just a wonderful visual display. Certainly you can use, I know Spider is another one which is installed with the Anaconda. I actually use a simple Notepad++ when I'm doing some of my Python script. Any of your IDEs will work fine. Jupyter Notebook is Iron Python because it's designed for the interface, but it's good to be aware of these different tools. And when I launch the Jupyter Notebook, it'll open up, like I said, a web page in here. And we'll go over here to New and create a new Python setup. And like I said, I believe this is Python 3.7, but any of the three, the sci-ket learn works with any of the 3X's. There's even 2.7 versions. So it's been around a long time. So it's very big on the development side. And then the guys in the back, guys and gals, they went ahead and put this together for me. And let's go ahead and import our different packages. Now, if you've been reading some of our other tutorials, you'll recognize pandas as PD. Pandas library is pretty widely used. It's a data frame setup, so it's just like columns and rows in a spreadsheet with a lot of different features for looking stuff up. Seaborn sits on top of matplot libraries. This is for our graphing, and we'll see that how quick it is to throw a graph out there to view in the Jupyter Notebook for demos and showing people what's going on. And then we're going to use the random forest, the SVC or support vector classifier, and also the neural network. So we're going to look at this. We're actually going to go through and look at 3 different classifiers that are most common, some of the most common classifiers, and let's show how those work in the sci-ket learn setup and how they're different. And then if you're going to do your setup on here, you'll want to go ahead and import some metrics. So the sklearn.metrics on here, and we're going to use the confusion metrics and the classification report out of that. And then we're going to use from the sklearn pre-processing the standard scalar and label encoder. Standard scalar is probably the most commonly used pre-processing. There's a lot of different pre-processing packages in the sklearn. And then model selection for splitting our data up. It's one of the many ways we can split data into different sections. And the last line here is our percentage matplot library inline. Some of the Seaborn and matplot library will go ahead and display perfectly inline without this, and some won't. It's good to always include this when you're in the Jupyter Notebook. This is Jupyter Notebook, so if you're in an IDE, when you run this, it will actually open up a new window and display the graphics that way. So you only need this if you're running it in a editor like this one, with specifically Jupyter Notebook. I'm not even familiar with other editors that are like this, but I'm sure they're out there. I'm sure there's a Firefox version or something. Jupyter Notebook just happens to be the most widely used out there. And we can go ahead and hit the run button, and this now has saved all this underneath the packages. So my packages are now all loaded. I've run them, whether you run it on top or you run it to the left, and all the packages are up there, so we now have them all available to us for our project we're working on. And I'm just going to make a little side note on that. When you're playing with these and you delete something out and add something in, even if I went back and deleted this cell and just hit the scissors up here, these are still loaded in this kernel. So until I go under kernel and restart and clear or restart and run all, I'll still have access to pandas. Important to know, because I've done that before. I've loaded up, maybe not a module here, but I've loaded up my own code and then changed my mind and wondering, why does it keep putting out the wrong output? And then I realized it's still loaded in the kernel and you have to restart the kernel. Just a quick side note for working with a Jupyter Notebook and one of the troubleshooting things that comes up. And we're going to go ahead and load up our data set. We're using the pandas, so if you haven't yet, go look at our pandas tutorial. A simple read the CSV with the separation on here. And so let me go ahead and run that. And that's now loaded into the variable wine. And let's take a quick look at the actual file. I always like to look at the actual data I'm working with. In this case, we have wine quality-red. I'll just open that up. I have it in my open office setup. It's separated by semicolons. That's important to notice. And when we open that up, you'll see we have, go all the way down here. It looks like 1,600 lines of data minus the first one, so 1,599 lines. And we have a number of features going across. The last one is quality. And right off the bat, we see the quality is has different numbers in it, 5, 6, 7. It's not really, I'm not sure how high of a level it goes, but I don't see anything over a 7. So it's kind of 5 through 7 is what I see here. 5, 6, and 7. 4, 5, 6, and 7, looking to see if there's any other values in there. Looking through the demo to begin with, I didn't realize the setup on this. So you can see there's the different quality values in there: alcohol, sulfates, pH, density, total sulfur dioxide, and so on. Those are all the features we're going to be looking at. And since this is a pandas, we'll just do wine head, and that prints the first 5 rows of data. That's of course a pandas command. And we can see that looks very similar to what we were looking at before. We have everything across here. It's automatically assigned an index on the left. That's what pandas does if you don't give it an index. And for the column names, it has assigned the first row. So we have our first row of data pulled off our comma separated variable file, in this case semicolon separated. And it shows the different features going across. And we have, what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 features. 12 including quality, but that's the one we want to work on and understand. And then because we're in pandas data frame, we can also do wine.info. And let's go ahead and run that. This tells us a lot about our variables we're working with. You'll see here that there is 1,599. That's what I said from the spreadsheet, so that looks correct. Non-null float 64. This is very important information, especially the non-null. So there's no null values in here. That can really trip us up in pre-processing. And there's a number of ways to process non-null values. One is just to delete that data out of there. So if you have enough data in there, you might just delete your non-null values. Another one is to fill that information in with like the average or the most common values or other such means. But we're not going to have to worry about that. But we'll look at another way, because we can also do wine is null and sum it up. And this will give us a similar, it won't tell us that these are float values, but it will give us a summation. Oops, there we go, let me run that. It'll give us a summation on here, how many null values in each one. So if you wanted to, from here you would be able to say, okay, this is a null value, but it doesn't tell you how many are null values. This one would clearly tell you that you have maybe 5 null values here, 2 null values here. And you might just, if you had only 7 null values and all that different data, you'd probably just delete them out. Where if 90% of the data was null values, you might rethink either a different data collection setup or find a different way to deal with the null values. And we'll talk about that just a little bit in the models too, because the models themselves have some built-in features, especially the forest model, which we're going to look at. At this point, we need to make a choice. And to keep it simple, we're going to do a little pre-processing of the data, and we're going to create some bins. And bins we're going to do is 2, 6.5, 8. What this means is that we're going to take those values. If you remember up here, let me just scroll back up here. We had our quality. The quality comes out between 2 and 8 basically, or 1 and 8. But we have 5, 5, 5, 6. You can see just in the first 5 lines of variation in quality. We're going to separate that into just 2 bins of quality. And so we've decided to create 2 bins. We have bad and good. It's going to be the labels on those 2 bins. We have a spread of 6.5 and an exact index of 8. The exact index is because we're doing 0 to 8 on there. The 6.5 we can change. We could actually make this smaller or greater, but we're only looking for the really good wine. We're not looking for the 0, 1, 2, 3, 4, 5, 6. We're looking for wines with 7 or 8 on them. So high quality. This is what I want to put on my dinner table at night. I want to taste the good wine, not the semi-good wine or mediocre wine. And then this is a pandas. So PD, remember, stands for pandas. Pandas cut means we're cutting out the wine quality and we're replacing it. And then we have our bins equals bins. That's the command. Bins is the actual command. And then our variable bins, 2, 6.58. So 2 different bins. And our labels, bad and good. And we can also do, let me just do it this way. Wine quality, since that's what we're working on. And let's look at unique. Another pandas command, and we'll run this. And I get this lovely error. Why did I get an error? Well, because I replaced wine quality and I did this cut here, which changes things on here. So I literally altered one of the variables that is saved in the memory. So we'll go up here to the kernel, restart and run all. That starts it from the very beginning. And we can see here that that fixes the error because I'm not cutting something that's already been cut. We have our wine quality unique, and the wine quality unique is a bad or good. So we have 2 qualities objects. Bad is less than good, meaning bad's going to be 0 and good's going to be 1. And to make that happen, we need to actually encode it. So we'll use the label quality equals label encoder. And the label encoder, let me just go back there since this is part of Simplilearn. That was one of the things we imported, was a label encoder. You can see that right here from the Simplilearn.processing import standard scalar, which we're going to use in a minute, and label encoder. And that's what tells it to use bad equals 0 and good equals 1. And we'll go ahead and run that, and then we need to apply it to the data. And when we do that, we take our wine quality that we had before, and we're going to set that equal to label quality, which is our encoder. And let's look at this line right here. We have dot fit transform. And you'll see this in the pre-processing. These are the most common used is fit, transform, and fit transform. Because they're so often that you're also transforming the data when you fit it, they just combine them into one command. And we're just going to take the wine quality, feed it back into there, and put that back in our wine quality setup, and run that. And now when we do the wine and the head of the first 5 values, and we go ahead and run this, you can see right here underneath quality 0, 0, 0. Have to go down a little further to look at the better wines. Let's see if we have some that are 1s. Yeah, there we go. There's some 1s down here. So when we look at 10 of them, you can see all the way down to 0 or 1. That's our quality. And again, we're looking at high quality. We're looking at the 7 and the 8s, or 6.5 and up. And let's go ahead and grab our, where was it? Here we go, wine quality. And let's take another look at what else, more information about the wine quality itself. And we can do a simple pandas thing, value counts. Hopefully I typed that in there correctly. And we can see that we only have 217 of our wines which are going to be the higher quality. So 217, and the rest of them fall into the bad bucket, the 0, which is 1,382. So again, we're just looking for the top percentage of these. The top, what is that? It's probably about a little under 20% on there. So we're looking for our top wines, our 7 and 8s. And let's use our, let's plot this on a graph so we can take a look at this. And the SNS, if you remember correctly, that is, let me just go back to the top, that's our seaborn. Seaborn sits on top of Matplot library. It has a lot of added features, plus all the features of the Matplot library. And it also makes it quick and easy to put out a graph. And we'll do a simple bar graph. And they actually call it count plot. And then we want to just do count plot the wine quality. So let's put our wine quality in there. And let's go ahead and run this and see what that looks like. And nice inline. Remember, this is why we did the inline, so make sure it appears in here. And you can see the blue space, or the first space, represents low quality wine, and our second bar is a high quality line. And you can see that we're just looking at the top quality wine here. Most of the wine, we want to just give it away to the neighbors. No, maybe if you don't like your neighbors. Maybe give them the good quality wine, and I don't know what you do with the bad quality wine. I guess use it for cooking. There we go. But you can see here it forms a nice little graph for us with the seaborn on there, and you can see our setup on that. So now we've done some pre-processing. We've described our data a little bit. We have a picture of how much of the wine, what we expect it to be, high quality, low quality. Checked out the fact that there's none, we don't have any null values to contend with or any odd values. Some of the other things you sometimes look at these is if you have like some values that are just way off the chart. So the measurement might be off, or miscalibrated equipment if you're in the scientific field. So the next step we want to go ahead and do is we want to go ahead and separate our data set, or reformat our data set. And we usually use capital X, and that denotes the features we're working with. And we usually use a lowercase y. That denotes what, in this case, quality, what we're looking for. And we can take this and we can go wine, It's going to be our full thing of wine. Dropping, what are we dropping? We're dropping the quality. So these are all the features minus quality. And we'll make sure we have our axes equals 1. If you left it out, it would still come out correctly just because of the way it processes on the defaults. And then our y, if we're going to remove quality for our x, that's just going to be wine, and it is just the quality that we're looking at for y. So we put that in there. And we'll go ahead and run this. So now we've separated the features that we want to use to predict the quality of the wine and the quality itself. The next step is if you're going to create a data set and a model, we got to know how good our model is. So we're going to split the data, train and test splitting data. And this is one of the packages we imported from Sklearn. And the actual package was train, test, split. And we're going to do x, y, test size 0.2, random state 42. And this returns 4 variables. And most common you'll see is capital X train, that's what we're going to train our set with. Capital X test, that's the data we're going to keep on the side to test it with. Y train, Y remember stands for the quality or the answer we're looking for. So when we train it, we're going to use X train and Y train, and then Y test to see how good our X test does. And the train test split, let me just go back up to the top. That was part of the Sklearn model selection, import, train, test, split. There is a lot of ways to split data up. This is, when you're first starting, you do your first model, you probably start with the basics on here. You have one test for training, one for test. Our test size is 0.2 or 20%. And random state just means we just start with it's like a random seed number, so it's not too important back there. We're randomly selecting which ones we're going to use. Since this is the most common way, this is what we're going to use today, there is, and it's not even an Sklearn package yet, so someone's still putting it in there. One of the new things they do is they split the data into thirds, and then they'll run the model on they combine each of those thirds into 2 thirds for training and 1 for testing. And so you actually go through all the data and you come up with 3 different test results from it, which is pretty cool. That's a pretty cool way of doing it. You could actually do that with this by just splitting this into thirds, and then, or have a one test set third, and then split the training set also into thirds, and also do that and get 3 different data sets. This works fine for most projects, especially when you're starting out. It works great. So we have our X train, our X test, our Y train, and our Y test. And then we need to go ahead and do the scalar. And let's talk about this because this is really important. Some models do not need to have scaling going on. Most models do. And so we create our scalar variable. We'll call it SC, standard scalar. And if you remember correctly, we imported that here, along with the label encoder, the standard scalar setup. So there's our scalar, and this is going to convert the values. Instead of having some values that go from 0, if you remember up here we had some values are 54, 60, 40, 59, 102. So our total sulfur dioxide would have these huge values coming into our model. And some models would look at that and they'd become very biased to sulfur dioxide. It'd have the hugest impact. And then a value that had 0.076, 0.098, or chlorides would have very little impact because it's such a small number. So when we take the scalar, we kind of level the playing field. And depending on our scalar, it sets it up between 0 and 1 a lot of times is what it does. Let's go ahead and take a look at that. And we'll go ahead and start with our X train. And our X train equals SC fit transform. We talked about that earlier. That's an Sklearn setup. It's going to both fit and transform our X train into our X train variable. And if we have an X train, we also need to do that to our test. And this is important because you need to note that you don't want to refit the data. We want to use the same fit we used on the training as on the testing. Otherwise, you get different results. And so we'll do just, not fit, transform. We're only going to transform the test side of the data. So here's our X test that we want to transform. And let's go ahead and run that. And just so we have an idea, let's go ahead and take and just print out our X train. Let's do first 10 variables, very similar to the way you do the head on a data frame. You can see here our variables are now much more uniform, and they've scaled them to the same scale, so they're between certain numbers. And with the basic scalar, you can fine-tune it. I just let it do its defaults on this, and that's fine for what we're doing. In most cases, you don't really need to mess with it too much. It does look like it goes between like probably -2 to 2 or something like that. That's just looking at the train variable. We'll go ahead and cut that one out of there. So before we actually build the models and start discussing the sklearn models we're going to use, we covered a lot of ground here. Most of when you're working with these models, you put a lot of work into prepping the data. So we looked at the data, noticed that it's separated, loaded it up. We went in there, we found out there's no null values. That's hard to say, no null values. We have, there's none null value. I can't say it. And of course we sum it up. If you had a lot of null values, this would be really important coming in here. So is there a null summary? We looked at pre-processing the data as far as the quality. And we're looking at the bins. So this would be something you might start playing with. Maybe you don't want super fine wine. You don't want the 7 and 8s. Maybe you want to split this differently. So certainly you can play with the bins and get different values and make the bins smaller or lean more towards the lower quality. So you then have like medium to high quality. And we went ahead and gave it labels. Again, this is all pandas we're doing in here. Setting it up with unique labels and group names. Bad, good. Bad is less than good. That can be so important. You don't know how many times people go through these models and they have them reversed or something. And then they go back and they're like, why is this data not looking correct? So it's important to remember what you're doing up here and double check it. And we used our label encoder. So that was to set that up as quality 0, 1. Good, in this case we have bad, good, 0, 1. And we just double check that to make sure that's what came up in the quality there. And then we threw it into a graph because people like to see graphs. I don't know about you, but you start looking at all these numbers and all this text and you get down here and you say, oh, yes, you know, here, this is how much of the wine we're going to label as subpar, not good. And this is how much we're going to label as good. And then we got down here to finally separating out our data so it's ready to go into the models. And the models take X and a Y. In this case, X is all of our features minus the one we're looking for, and then Y is the features we're looking for. So in this case, we dropped quality, and in the Y case, we added quality. And then because we need to have a training set and a test set so we can see how good our models do, we went ahead and split the models up: X train, X test, Y train, Y test. And that's using the train test split, which is part of the sklearn package. And we did, as far as our testing size, 0.2 or 20%. The default is 25%, so if you leave that out, it'll do default setup. And we did a random state equals 42. If you leave that out, it'll use a random state. I believe it's default 1. I'd have to look that back up. And then finally, we scaled the data. This is so important to scale the data. Going back up to here, if you have something that's coming out as 100, it's going to really outweigh something that's 0.071. That's not in all the models. Different models handle it differently. And as we look at the different models, I'll talk a little bit about that. We're going to only look at 3 models today, 3 of the top models used for this, and see how they compare and how the numbers come out between them. So we're going to look at 3 different setups. Oh, let me change my cell here to markdown. There we go. And we're going to start with the random forest classifier. So the 3 setups we're looking at is the random forest classifier, support vector classifier, and then a neural network. Now we start with the random forest classifier because it has the least amount of parts, moving parts to fine tune. And let's go ahead and put this in here. So we're going to call it RFC for random forest classifier. And if you remember, we imported that. So let me go back up here to the top real quick. And we did an import of the random forest classifier from sklearn ensemble. And then we also, let me just point this out. Here's our SVM where we imported our support vector classifier. So SVM is support vector model, support vector classifier. And then we also have our neural network. And we're going to, from there, the multi-layered perceptron classifier. Kind of a mouthful for the P, perceptron. Don't worry too much about that name. It's a neural network. There's a lot of different options on there in setups, which is where they came up with the perceptron. So we have our 3 different models we're going to go through on here. And then we're going to weigh them. Here's our metrics. So we're going to use a confusion metrics, also from the sklearn package, to see how good our model does with our split. So let's go back down there and take a look at that. And we have our RFS equals random forest classifier. And we have n estimators equals 200. This is the only value you play with a random forest classifier. How many forests do you need? Or how many trees in the forest? So how many models are in here? That makes it pretty good as a startup model because we're only playing with one number and it's pretty clear what it is, and you can lower this number or raise it. Usually start up with a higher number and then bring it down to see if it keeps the same value. So you have less, the smaller the model, the better the fit, and it's easier to send out to somebody else if you're going to distribute it. Now the random forest classifier, everything I read says it's used for kind of a medium-sized data set. So you can run it on big data, you can run it on smaller data obviously, but it tends to work best in the mid-range. And we'll go ahead and take our RFC, and I just copied this from the other side, dot fit x train, comma, y train. So we're sending it our features and then the quality in the y train, what we want to predict in there. And we just do a simple fit. Now remember, this is sklearn, so everything is fit or transform. Another one is predict, which we'll do in just a second here. In fact, let's do that now. Predict RFC equals, and it's our RFC model, predict. And what are we predicting on? Well, we trained it with our train values, so now we need our test, our X test. So this has done it. This is the 3 lines of code we need to create our random forest variable, fit our training data to it. So we're programming it to fit. In this case, it's got 200 different trees it's going to build, and then we're going to predict on here. And let me go ahead and just run that. And we can actually do something like, let's do predict RFC. Just real quick, we'll look at the first 20 variables of it. Let's go ahead and run that. And in our first 20 variables, we have 3 wines that make the cut, and the other 17 don't. So the other 17 are bad quality, and 3 of them are good quality in our predicted values. And if you can remember correctly, we'll go ahead and take this out of here. This is based on our test. So these are the first 20 values in our test, and this has, as you can see, all the different features listed in there, and they've been scaled. So when you look at these, they're a little bit confusing to look at and hard to read, but there's a -0.01, so this is 0.36, -0.01, so 0.164, -0.09, or no, it's still -1, so -0.9, all between 0 and 1 on here. I think I was confused earlier and I said 0 between 2, -2, but it's between -1 and 1, which is what it should be in the scale. And we'll go ahead and just cut that out of there. Run this. We have our setup on here. So now that we've run the prediction and we have predicted values, well, one, you could publish them, but what do we do with them? Well, what we want to do with them is we want to see how well our model performed. That's the whole reason for splitting it between a training and testing model. And for that, if you remember, we imported the classification report. That was again from the sklearn. There's our confusion matrix and classification report. And the classification report actually sits on the confusion matrix, so it uses that information. And our classification report, we want to know how good our y test, that's the actual values, versus our predicted RFC. So we'll go ahead and print this report out, and let's take a look. And we can see here we have a precision out of the 0. We had about 0.92 that were labeled as bad, that were actually bad. And out of precision for the quality wines, we're running about 78%. So you kind of give us an overall 90%. And you can see our F1 score, our support set up on there, our recall. You could also do the confusion matrix on here, which gives you a little bit more information. But for this is going to be good enough for right now. We're just going to look at how good this model was, because we want to compare the random forest classifier with the other 2 models. And you know what, let's go ahead and put in the confusion matrix, just so you can see that on there, with y-test and prediction RFC. So in the confusion matrix, we can see here that we had 266 correct and 7 wrong. These are the mislabels for bad wine, and we had a lot of mislabels for good wine. So our quality labels aren't that good. We're good at predicting bad wine, not so good at predicting whether it's a good quality wine. Important to note on there. So that is our basic random forest classifier. And let me go ahead, change cell type to markdown and run that so we have a nice label. Let's look at our SVM classifier, our support vector model. And this should look familiar. We have our CLF we're going to create. We'll call it, just like we call this an RFC. And then we'll have our CLF.fit. And this should be identical to up above. X train, comma, Y train. And just like we did before, let's go ahead and do the prediction. And here is our CLF predict. And it's going to equal the CLF.predict. And we want to go ahead and use X underscore test. And right about now you can realize that you can create these different models and actually just create a loop to go through your different models and put the data in. And that's how they designed it. They designed it to have that ability. Let's go ahead and run this, and then let's go ahead and do our classification report. And I'm just going to copy this right off of here. They say you shouldn't copy and paste your code, and the reason is when you go in here and edit it, you invariably will miss something. We only have 2 lines, so I think I'm safe to do it today. And let's go ahead and run this. And let's take a look how the SVM classifier came out. So up here we had a 90%. And down here we're running about an 86%. So it's not doing as good. Now remember, we randomly split the data. So if I run this a bunch of times, you'll see some changes down here. So these numbers, this size of data, if I ran it 100 times, it would probably be within plus or minus 3 or 4 on here. In fact, if I ran this 100 times, you'd probably see these come out almost the same as far as how well they do in classification. And then on the confusion matrix, let's take a look at this one. This had 22 by 25. This one has 35 by 12. So it's doing not quite as good. That shows up here 71% versus 78%. And then if we're going to do a SVM classifier, we also want to show you one more. And before I do that, kind of tease you a little bit here, before we jump into neural networks, the big save all deep learning, because everything else must be shallow learning, that's a joke. Let's just talk a little bit about the SVM versus the random forest classifier. The SVM tends to work better on smaller numbers. It also works really good on, because a lot of times you convert things into numbers and bins and things like that. The random forest tends to do better with those. At least that's my brief experience with it. Where if you have just a lot of raw data coming in, the SVM is usually the fastest and easiest to apply model on there. So they each have their own benefits. You'll find though again that when you run these like 100 times, the difference between these two on a data set like this is going to just go away. There's randomness involved depending on which data we took and how they classify them. The big one is the neural networks, and this is what makes the neural networks nice is they can look into huge amounts of data. So for a project like this, you probably don't need a neural network on this, but it's important to see how they work differently and how they come up differently. So you can work with huge amounts of data. You can also, in many respects, they work really good with text analysis, especially if it's time sensitive. More and more you have an order of text, and they've just come out with different ways of feeding that data in, where the series and the order of the words is really important. Same thing with starting to predict in the stock market. If you have tons of data coming in from different sources, the neural network can really process that in a powerful way to pull up things that aren't seen before. And when I say lots of data coming in, I'm not talking about just the high lows that you can run an SVM on real easily. I'm talking about the data that comes in where you have, maybe you pulled off the Twitter feeds and have word counts going on, and you've pulled off the different news feeds that business are looking at, and the different releases when they release the different reports. So you have all this different data coming in, and the neural network does really good with that. Pictures. Picture processing now is really moving heavily into the neural network. If you have a Pixel 2 or Pixel 3 phone put out by Google, it has a neural network for doing, it's kind of goofy, but you can put little Star Wars androids dancing around your pictures and things like that. That's all done with the neural network. So it has a lot of different uses, but it's also requires a lot of data and is a little heavy-handed for something like this. And this should now look familiar because we've done it twice before. We have our multi-layered perceptron classifier. We'll call it an MLPC, and it's just as what we imported, MLPC classifier. There's a lot of settings in here. The first one is the hidden layers. You have to have the hidden layers in there. We're going to do 3 layers of 11 each. So that's how many nodes are in each layer as it comes in. And that was based on the fact we have 11 features coming in. Then I went ahead and just did 3 layers. Probably get by with a lot less on this. But I didn't want to sit and play with it all afternoon. Again, this is one of those things you play with a lot because the more hidden layers you have, the more resources you're using. You can also run into problems with overfitting, with too many layers, and you also have to run higher iterations. The max iteration we have is set to 500. The default's 200. Because I use 3 layers of 11 each, which is, by the way, kind of a default I use. I realized that usually you have about 3 layers going down and the number of features going across. You'll see that's pretty common for the first classifier when you're working in neural networks. But it also means you have to do higher iterations. So we up the iterations to 500. So that means it's going through the data 500 times to program those different layers and carefully adjust them. And we do have a full tutorials you can go look up on neural networks and understand the neural network settings a lot more. And of course we have, you're looking over here where we had our previous model where we fit it. Same thing here, MLPC, fit, X train, Y train. And then we're going to create our prediction. So let's do our predict and MLPC, and it's going to equal the MLPC. And we'll just take the same thing here, predict x test. Let's just put that down here, dot predict x test. And if I run that, we've now programmed it. We now have our prediction here, same as before. And we'll go ahead and do the copy print again. Always be careful with the copy paste, because you always run the chance of missing one of these variables. So if you're doing a lot of coding, you might want to skip that copy and paste and just type it in. And let's go ahead and run this and see what that looks like. And we came up with an 88%. We're going to compare that with the 86 from our tree, our SVM classifier, and our 90 from the random forest classifier. And keep in mind, random forest classifiers, they do good on mid-sized data. The SVM on smaller amounts of data, although to be honest, I don't think that's necessarily the split between the two. And these things will actually come together if you ran them a number of times. And we can see down here the amount of good wines mislabeled with setup on there. It's on par with our random forest. So it had 22, 25. Shouldn't be a surprise, it's identical. It just didn't do as good with the bad wines labeling, what's a bad wine and what's not. Let's see, yeah, because they had 266 and 7. We had down here 260 and 13. So it mislabeled a couple of the bad wines as good wines. So we've explored 3 of these basic classifiers. These are probably the 3 most widely used right now. I might even throw in the random tree. If we open up their website and we go under supervised learning, there's a linear model. We didn't do that. Most of the data usually just start with a linear model because it's going to process the quickest and use the least amount of resources. But you can see they have linear quadratic, they have kernel ridge. There's our support vector, stochastic gradient, nearest neighbors. Nearest neighbors is another common one that's used a lot. Very similar to the SVM. Gaussian process, cross decomposition, Naïve Bayes. This is more of an intellectual one that I don't see used a lot, but it's like the basis of a lot of other things. Decision tree, there's another one that's used a lot. Ensemble methods, not as much. Multi-class and multi-label algorithms, feature selection, neural networks, that's the other one we use down here, and of course the forest. So you can see there's in sklearn there are so many different options, and they've just developed them over the years. We covered 3 of the most commonly used ones in here and went over a little bit over why they're different. Neural network, just because it's fun to work in deep learning and not in shallow learning, as I told you. That doesn't mean that the SVM is actually shallow. It covers a lot of things, and same thing with the decision tree, the random forest classifier. And we notice that there's a number of other different classifier options in there. These are just the 3 most common ones, and I'd probably throw the nearest neighbor in there and the decision tree, which is usually part of the decision forest depending on what the backend you're using. And since, as human beings, if I was in the shareholder's office, I wouldn't want to leave them with a confusion matrix. They need that information for making decisions, but we want to give them just one particular score. And so I would go ahead and we have our sklearn metrics. We're going to import the accuracy score. And I'm just going to do this on the random forest, since that was our best model. And we have our CM accuracy score, and I forgot to print it. If you remember in Jupyter Notebook, we can just do the last variable we leave out there, it'll print. And so our CM accuracy score we get is 90%. And that matches up here. We should already see that up here in precision. So you can either quote that, but a lot of times people like to see it highlighted at the very end. This is our precision on this model. And then the final stage is we would like to use this for future. So let's go ahead and take our wine. If you remember correctly, we'll do wine head of 10. We'll run that. Remember our original data set? We've gone through so many steps. Now we're going to go back to the original data. And we can see here we have our top 10 on the list. Only 2 of them make it as having high enough quality wine for us to be interested in them. And then let's go ahead and create some data here. We'll call it x new equals, and this is important. This data has to be, we just kind of randomly selected some data. It looks an awful lot like some of the other numbers on here, which is what it should look like. And so we have our x new equals 7.3, 0.58, and so on. And then it is so important. This is where people forget this step. X new equals sc. Remember sc? That was our standard scalar variable we created. If we go right back up here, before we did anything else, we created an sc, we fit it, and we transformed it, and then we need to do what? Transform the data we're going to feed in. So we're going to go back down here, and we're going to transform our x new, and then we were going to go ahead and use the, where are we at? Here we go. Our random forest, and if you remember, all it is our RFC predict model right there. Let's go ahead and just grab that down here. And so our y new equals, here's our RFC predict. We're going to do our x new in, and then it's kind of nice to know what it actually puts out. So according to this, it should print out what our prediction is for this wine. And, oh, it's a bad wine. Okay, so we didn't pick out a good wine for our X new. And that should be expected. Most of the wine, if you remember correctly, only a small percentage of the wine met our quality requirements. So we can look at this and say, oh, we'll have to try another wine out, which is fine by me because I like to try out new wines, and I certainly have a collection of old wine bottles, and very few of them match. But you can see here we've gone through the whole process. Just a quick rehash. We had our imports. We touched a lot on the Simplilearn, our random forest, our SVM, and our MLP classifier. So we had our support vector classifier, we had our random forest, and we have our neural network, three of the top used classifiers in the sklearn system. And we also have our confusion matrix and our classification report, which we used, our standard scaler for scaling it, and our label encoder. And of course, we needed to go ahead and split our data up in our mplot line train. And we explored the data in here for null values. We set up our quality into bins. We took a look at the data and what we actually have and put a nice little plot to show our quality, what we're looking at. And then we went through our three different models. And it's always interesting because you spend so much time getting to these models, and then you kind of go through the models and play with them until you get the best training on there without becoming biased. That's always a challenge, is to not overtrain your data to the point where you're training it to fit the test value. And finally, we went ahead and actually used it and applied it to a new wine, which unfortunately didn't make the cut. It's going to be the one that we drink a glass out of and save the rest for cooking. Of course, that's according to the random forest on there because we used the best model that it came up with.
There's no better time to train yourself in the exciting field of machine learning. If you're looking for a course that covers everything from the fundamentals to advanced techniques, for that, accelerate your career in AI and ML with a comprehensive postgraduate program in AI and machine learning. Gain expertise in machine learning, deep learning, NLP, computer vision, and reinforcement learning. You will receive a prestigious certificate, exclusive alumni membership, and Ask Me Anything sessions by IBM, with 3 capstone projects and 25 plus industry projects using real datasets from Twitter, Uber, and more. You will gain practical experience. Masterclasses by Caltech faculty and IBM experts ensure top-notch education. Simplilearn's Job Assist helps you notice by leading companies. This program covers statistics, Python, supervised and unsupervised learning, NLP, neural networks, computer vision, GANs, Keras, TensorFlow, and many more skills. Enroll now and unlock exciting AI and ML opportunities. The course link is mentioned in the description box below.
Bayes classifier. Have you ever wondered how your mail provider implements spam filtering, or how online news channels perform news text classification, or how companies perform sentimental analysis of their audience on social media? All of this and more is done through a machine learning algorithm called Naïve Bayes classifier. Welcome to Naïve Bayes tutorial. My name is Richard Kirshner. I'm with the Simplilearn team. That's www.simplilearn.com. Get certified. Get ahead. What's in it for you? We'll start with what is Naïve Bayes, a basic overview of how it works. We'll get into Naïve Bayes and machine learning, where it fits in with our other machine learning tools. Why do we need Naïve Bayes? And understanding Naïve Bayes classifier, a much more in-depth of how the math works in the background. Finally, we'll get into the advantages of the Naïve Bayes classifier in the machine learning setup. And then we'll roll up our sleeves and do my favorite part. We'll actually do some Python coding and do some text classification using the Naïve Bayes. What is Naïve Bayes? Let's start with a basic introduction to the Bayes theorem, named after Thomas Bayes from the 1700s, who first coined this in the Western literature. Naïve Bayes classifier works on the principle of conditional probability as given by the Bayes theorem. Before we move ahead, let us go through some of the simple concepts in the probability that we will be using. Let us consider the following example of tossing 2 coins. Here we have 2 quarters, and if we look at all the different possibilities of what they can come up as, we get that they can come up as heads, they can come up as head-tail, tail-head, and tail-tail. When doing the math on probability, we usually denote probability as a P, a capital P. So the probability of getting 2 heads equals 1/4. You can see on our data set we have 2 heads, and this occurs once out of the 4 possibilities. And then the probability of at least 1 tail occurs 3/4 of the time. You'll see on 3 of the coin tosses we have tails in them, and out of 4 that's 3/4. And then the probability of the second coin being head given the first coin is tail is 1/2, and the probability of getting 2 heads given the first coin is ahead is 1/2. We'll demonstrate that in just a minute and show you how that math works. Now, when we're doing it with 2 coins, it's easy to see, but when you have something more complex, you can see where these formulas really come in and work. So the Bayes theorem gives us the conditional probability of an event A given another event B has occurred. In this case, the first coin toss will be B, and the second coin toss A. This could be confusing because we've actually reversed the order of them and go from B to A instead of A to B. You'll see this a lot when you work in probabilities. The reason is we're looking for event A. We want to know what that is, so we're going to label that A since that's our focus. And then given another event B has occurred. In the Bayes theorem, as you can see on the left, the probability of A occurring given B has occurred equals the probability of B occurring given A has occurred times the probability of A over the probability of B. This simple formula can be moved around just like any algebra formula. And we could do the probability of A after a given B times probability of B equals the probability of B given A times probability of A. You can easily move that around and multiply it and divide it out. Let us apply Bayes' theorem to our example. Here we have our 2 quarters, and we'll notice that the first 2 probabilities of getting 2 heads and at least 1 tail we compute directly off the data. So you can easily see that we have one example, HH, out of 4, 1/4, and we have 3 with tails in them, giving us 3/4, or 3/4, 75%. The second condition, the second set, 3 and 4, we're going to explore a little bit more in detail. Now, we stick to a simple example with 2 coins because you can easily understand the math. The probability of throwing a tail doesn't matter what comes before it, and the same with the heads. So it's still going to be 50% or 1/2. But when that probability gets more complicated, let's say you have a D6 dice or some other instance, then this formula really comes in handy. But let's stick to the simple example for now. In this sample space, let A be the event that the second coin is head, and B be the event that the first coin is tails. Again, we reversed it because we want to know what the second event's going to be, so we're going to be focusing on A. And we write that out as the probability of A given B. And we know this from our formula that equals the probability of B given A times the probability of A over the probability of B. And when we plug that in, we plug in the probability of the first coin being tails given the second coin is heads, and the probability of the second coin being heads given the first coin being over the probability of the first coin being tails. When we plug that data in, and we have the probability of the first coin being tails given the second coin is heads times the probability of the second coin being heads over the probability of the first coin being tails. You can see it's a simple formula to calculate. We have 1/2 times 1/2 over 1/2, or 1/2 equals 0.5, or 1/4. So the Bayes theorem basically calculates the conditional probability of the occurrence of an event based on prior knowledge of conditions that might be related to the event. We will explore this in detail when we take up an example of online shopping further in this tutorial. Understanding naive Bayes and machine learning. Like with any of our other machine learning tools, it's important to understand where the naive Bayes fits in the hierarchy. So under the machine learning, we have supervised learning, and there is other things like unsupervised learning. There's also a reward system. This falls under the supervised learning. And then under the supervised learning, there's classification. There's also regression, but we're going to be in the classification side. And then under classification is your naive Bayes. Let's go ahead and glance into where is naive Bayes used. Let's look at some of the use scenarios for it. As a classifier, we use it in face recognition. Is this Cindy or is it not Cindy or whoever? Or it might be used to identify parts of the face that they then feed into another part of the face recognition program. This is the eye, this is the nose, this is the mouth. Weather prediction, is it going to be rainy or sunny? Medical recognition, news prediction. It's also used in medical diagnosis. We might diagnose somebody as either as high risk or not as high risk for cancer or heart disease or other ailments. And news classification. When you look at the Google News and it says, well, is this political or is this world news? Or a lot of that's all done with the naive Bayes. Understanding naive Bayes classifier. Now, we already went through a basic understanding with the coins and the 2 heads and 2 tails and head tail, tail heads, etc. We're going to do just a quick review on that and remind you that the naive Bayes classifier is based on the Bayes theorem, which gives a conditional probability of event A given event B. And that's where the probability of A given B equals the probability of B given A times probability of A over probability of B. Remember, this is an algebraic function, so we can move these different entities around. We can multiply by the probability of B, so it goes to the left-hand side, and then we could divide by the probability of A given B. and just as easily come up with a new formula for the probability of B. To me, staring at these algebraic functions kind of gives me a slight headache. It's a lot better to see if we can actually understand how this data fits together in a table. And let's go ahead and start applying it to some actual data so you can see what that looks like. So we're going to start with the shopping demo problem statement. And remember, we're going to solve this first in table form so you can see what the math looks like, and then we're going to solve it in Python. And in here we want to predict whether the person will purchase a product. Are they going to buy or don't buy? Very important if you're running a business, you want to know how to maximize your profits, or at least maximize the purchase of the people coming into your store. And we're going to look at a specific combination of different variables. In this case, we're going to look at the day, the discount, and the free delivery. And you can see here under the day, we want to know whether it's on the weekday. You know, somebody's working, they come in after work, or maybe they don't work. Weekend, you can see the bright colors coming down there, celebrating not being in work, or holiday. And did we offer a discount that day? Yes or no? Did we offer free delivery that day? Yes or no? And from this, we want to know whether the person's going to buy based on these traits so we can maximize them and find out the best system for getting somebody to come in and purchase our goods and products from our store. Now, having a nice visual is great, but we do need to dig into the data. So let's go ahead and take a look at the data set. We have a small sample data set of 30 rows. We're showing you the first 15 of those rows for this demo. Now, the actual data file you can request. Just type in below under the comments on the YouTube video, and we'll send you some more information and send you that file. As you can see here, the file is very simple, columns and rows. We have the day, the discount, the free delivery, and did the person purchase or not. And then we have under the day whether it was a weekday, a holiday, was it the weekend. This is a pretty simple set of data, and long before computers, people used to look at this data and calculate this all by hand. So let's go ahead and walk through this and see what that looks like when we put that into tables. Also note, in today's world, we're not usually looking at 3 different variables in 30 rows. Nowadays, because we're able to collect data so much, we're usually looking at 27, 30 variables across hundreds of rows. The first thing we want to do is we're going to take this data and based on the data set containing our 3 inputs, day, discount, and free delivery, we're going to go ahead and populate that to frequency tables for each attribute. So we want to know if they had a discount, how many people buy and did not buy. Did they have a discount, yes or no? Did we have a free delivery, yes or no? On those days, how many people made a purchase and how many people didn't? And the same with the 3 days of the week. Was it a weekday, a weekend, a holiday? And did they buy, yes or no? As we dig in deeper to this table for our Bayes theorem, let the event buy be A. Now remember, when we looked at the coins, I said we really want to know what the outcome is. Did the person buy or not? And that's usually event A is what you're looking for. And the independent variables, discount, free delivery, and day, be B. So we'll call that probability of B. Now let us calculate the likelihood table for one of the variables. Let's start with day, which includes weekday, weekend, and holiday. And let us start by summing all of our rows. So we have the weekday row, and out of the weekdays there's 9 plus 2, so it's 11 weekdays. There's 8 weekend days and 11 holidays. Wow, that's a lot of holidays. And then we want to sum up the total number of days. So we're looking at a total of 30 days. Let's start pulling some information from our chart and see where that takes us. And when we fill in the chart on the right, you can see that 9 out of 24 purchases are made on the weekday, 7 out of 24 purchases on the weekend, and 8 out of 24 purchases on a holiday. And out of all the people who come in, 24 out of 30 purchase. You can also see how many people do not purchase. On the weekday, it's 2 out of 6 didn't purchase, and so on and so on. We can also look at the totals, and you'll see on the right we put together some of the formulas. The probability of making a purchase on the weekend comes out at 11 out of 30. So out of the 30 people who came into the store throughout the weekend, weekday, and holiday, 11 of those purchases were made on the weekday. And then you can also see the probability of them not making a purchase. And this is done for, doesn't matter which day of the week. So we call that probability of no buy. It would be 6 over 30 or 0.2. So there's a 20% chance that they're not going to make a purchase no matter what day of the week it is. And finally, we look at the probability of B if A. In this case, we're going to look at the probability of the weekday and not buying. 2 of the no buys were done out of the weekend out of the 6 people who did not make purchases. So when we look at that, probability of the weekday without a purchase is going to be 0.33 or 33%. Let's take a look at this at different probabilities, and based on this likelihood table, let's go ahead and calculate conditional probabilities as below. The first three we just did. The probability of making a purchase on the weekday is 11 out of 30, or roughly 36 or 37%, 0.367. The probability of not making a purchase at all, doesn't matter what day of the week, is roughly 0.2 or 20%. And the probability of a weekday no purchase is roughly 2 out of 6. So 2 out of 6 of our no purchases were made on the weekday. And then finally we take our P of AB. If you look, we've kept the symbols up there. We got P of probability of B, probability of A, probability of B if A. We should remember that the probability of A if B is equal to the first one times the probability of no buys over the probability of the weekday. So we could calculate it both off the table we created. We can also calculate this by the formula, and we get the 0.367, which equals, or 0.33 times 0.2 over 0.367, which equals 0.179, or roughly 17 to 18%. And that'd be the probability of no purchase done on the weekday. And this is important because we can look at this and say, as the probability of buying on the weekday is more than the probability of not buying on the weekday, we can conclude that customers will most likely buy the product on a weekday. Now, we've kept our chart simple and we're only looking at one aspect. So you should be able to look at the table and come up with the same information or the same conclusion. That should be kind of intuitive at this point. Next, we can take the same setup. We have the frequency tables of all three independent variables. Now we can construct the likelihood tables for all three of the variables we're working with. We can take our day like we did before. We have weekday, weekend, and holiday. We filled in this table. And then we can come in and also do that for the discount, yes or no. Did they buy, yes or no? And we fill in that full table. So now we have our probabilities for a discount and whether the discount leads to a purchase or not, and the probability for free delivery. Does that lead to a purchase or not? And this is where it starts getting really exciting. Let us use these three likelihood tables to calculate whether a customer will purchase a product on a specific combination of day, discount, and free delivery, or not purchase. Here, let us take a combination of these factors. Day equals holiday, discount equals yes, free delivery equals yes. Let's dig deeper into the math and actually see what this looks like. And we're going to start with looking for the probability of them not purchasing on the following combinations of days. We're actually looking for the probability of A equal no buy, no purchase. And our probability of B we're going to set equal to, is it a holiday? Did they get a discount? Yes. And was it a free delivery? Yes. Before we go further, let's look at the original equation. The probability of A if B equals the probability of B given the condition A and the probability times the probability of A over the probability of B occurring. Now this is basic algebra, so we can multiply this information together. So when you see the probability of A given B, in this case the condition is B, C, and D, or the three different variables we're looking at. And when you see the probability of B, that would be the conditions. We're actually going to multiply those three separate conditions out. Probability of, you'll see that in just a second in the formula, times the full probability of A over the full probability of B. So here we are back to this, and we're going to have let A equal no purchase, and we're looking for the probability of B on the condition A, where A sets for three different things. Remember that equals the probability of A given the condition B. And in this case, we just multiply those three different variables together. So we have the probability of the discount times the probability of free delivery times the probability is the day equal a holiday. Those are our three variables of the probability of A if B. And then that is going to be multiplied by the probability of them not making a purchase. And then we want to divide that by the total probabilities, and they're multiplied together. So we have the probability of a discount, the probability of a free delivery, and the probability of it being on a holiday. When we plug those numbers in, we see that 1 out of 6 were no purchase on a discounted day, 2 out of 6 were a no purchase on a free delivery day, and 3 out of 6 were a no purchase on a holiday. Those are our three probabilities of A if B multiplied out. And then that has to be multiplied by the probability of a no purchase. And remember, the probability of a no buy is across all the data. So that's where we get the 6 out of 30. We divide that out by the probability of each category over the total number. So we get the 20 out of 30 had a discount, 23 out of 30 had a yes for free delivery, and 11 out of 30 were on a holiday. We plug all those numbers in, we get 0.178. So in our probability math, we have a 0.178 if it's a no buy for a holiday, a discount, and a free delivery. Let's turn that around and see what that looks like if we have a purchase. I promise this is the last page of math before we dig into the Python script. So here we're calculating the probability of the purchase using the same math we did to find out if they didn't buy. Now we want to know if they did buy. And again, we're going to go by the day equals a holiday, discount equals yes, free delivery equals yes, and let A equal buy. Now right about now you might be asking, why are we doing both calculations? Why would we want to know the no buys and buys for the same data going in? Well, we're going to show you that in just a moment, but we have to have both of those pieces of information so that we can figure it out as a percentage as opposed to a probability equation. And we'll get to that normalization here in just a moment. Let's go ahead and walk through this calculation. And as you can see here, the probability of A on the condition of B being all three categories. Did we have a discount with a purchase? Did we have a free delivery with a purchase? And is a day equal to holiday? And when we plug this all into that formula and multiply it all out, we get our probability of a discount, probability of a free delivery, probability of the day being a holiday, times the overall probability of it being a purchase, divided by, again multiplying the three variables out, the full probability of there being a discount, the full probability of being a free delivery, and the full probability of there being a day equal holiday. And that's where we get this 19 over 24 times 21 over 24 times 8 over 24 times the P of A, 24 over 30, divided by the probability of the discount, the free delivery times the day, or 20 over 30, 23 over 30 times 11 over 30, and that gives us our 0.986. So, what are we going to do with these two pieces of data we just generated? Well, let's go ahead and go over them. We have a probability of purchase equals 0.986. We have a probability of no purchase equals 0.178. So, finally, we have a conditional probabilities of purchase on this day. Let us take that, we're going to normalize it, and we're going to take these probabilities and turn them into percentages. This is simply done by taking the sum of probabilities, which equals 0.986 plus 0.178, and that equals the 1.164. If we divide each probability by the sum, we get the percentage. And so the likelihood of a purchase is 84.71%, and the likelihood of no purchase is 15.29%, given these three different variables. So if it's on a holiday, if it's with a discount and has free delivery, then there's an 84.71% chance that the customer is going to come in and make a purchase. Hooray! They purchased our stuff. We're making money. If you're owning a shop, that's is the bottom line, is you want to make some money so that you can keep your shop open and have a living. Now, I promised you that we were going to be finishing up the math here with a few pages. So we're going to move on and we're going to do two steps. The first step is I want you to understand why you want to use the Naïve Bayes. What are the advantages of Naïve Bayes? And then once we understand those advantages, we'll just look at that briefly, then we're going to dive in and do some Python coding. Advantages of Naïve Bayes classifier. So let's take a look at the 6 advantages of the Naïve Bayes classifier, and we're going to walk around this lovely wheel. It looks like an origami folded paper. The first one is very simple and easy to implement. Certainly you could walk through the tables and do this by hand. You got to be a little careful because the notations can get confusing. You have all these different probabilities, and I certainly mess those up as I put them on, is it on the top or the bottom? You got to really pay close attention to that. When you put it into Python, it's really nice because you don't have to worry about any of that. You let the Python handle that, the Python module. But understanding it, you can put it on a table and you can easily see how it works, and it's a simple algebraic function. It needs less training data, so if you have smaller amounts of data, this is a great, powerful tool for that. Handles both continuous and discrete data. It's highly scalable with number of predictors and data points. So as you can see, you can just keep multiplying different probabilities in there, and you can cover not just 3 different variables or sets. You can now expand this to even more categories. Number 5, it's fast. It can be used in real-time predictions. This is so important. This is why it's used in a lot of our predictions on online shopping carts, referrals, spam filters, is because there's no time delay as it has to go through and figure out a neural network, or one of the other many setups where you're doing classification. And certainly there's a lot of other tools out there in the machine learning that can handle these but most of them are not as fast as the Naïve Bayes. And then finally, it's not sensitive to irrelevant features. So it picks up on your different probabilities, and if you're short on data on one probability, you can it automatically adjust for that. Those formulas are very automatic, and so you can still get a very solid predictability even if you're missing data or you have overlapping data for two completely different areas. We see that a lot in doing census and studying of people and habits, where they might have one study that covers one aspect and another one that overlaps, and because the two overlap, they can then predict the unknowns for the group that they haven't done the second study on, or vice versa. So it's very powerful in that it is not sensitive to the irrelevant features, and in fact you can use it to help predict features that aren't even in there. So now we're down to my favorite part. We're going to roll up our sleeves and do some actual programming. We're going to do the use case text classification. Now, I would challenge you to go back and send us a note on the notes below underneath the video and request the data for the shopping cart. So you can plug that into Python code and do that on your own time so you can walk through it, since we walk through all the information on it. But we're going to do a Python code doing text classification, very popular for doing the Naïve Bayes. So we're going to use our new tool to perform a text classification of news headlines and classify news into different topics for a news website. As you can see here, we have a nice image of the Google News, and then related on the right, subgroups. I'm not sure where they actually pulled the actual data we're going to use from. It's one of the standard sets. But certainly this can be used on any of our news headlines and classification. So let's see how it can be done using the Naïve Bayes classifier. Now we're at my favorite part. We're actually going to write some Python script. Roll up our sleeves. And we're going to start by doing our imports. These are very basic imports, including our news group. And we'll take a quick glance at the target names. Then we're going to go ahead and start training our data set and putting it together. We'll put together a nice graph, because it's always good to have a graph to show what's going on. And once we've trained it and we've shown you a graph of what's going on, then we're going to explore how to use it and see what that looks like. Now, I'm going to open up my favorite editor, inline editor for Python. You don't have to use this. You can use whatever your editor that you like, whatever interface IDE you want. This just happens to be the Anaconda Jupyter Notebook. And I'm going to paste that first piece of code in here so we can walk through it. Let's make it a little bigger on the screen so you have a nice view of what's going on. And we're using Python 3, in this case 3.5. So this would work in any of your 3x. If you have it set up correctly, it should also work in a lot of the 2x. You just have to make sure all of the versions of the modules match your Python version. And in here, you'll notice the first line is your percentage matplot library in line. Now, 3 of these lines of code are all about plotting the graph. This one lets the notebook know, since it's an inline setup, that we want the graphs to show up on this page. Without it in a notebook like this, which is an Explorer interface, it won't show up. Now, a lot of IDEs don't require that. A lot of them, like if I'm working on one of my other setups, it just has a pop-up and the graph pops up on there. So you have that setup also. But for this, we want the matplot library inline. And then we're going to import numpy as np. That's NumberPython, which has a lot of different formulas in it that we use for both of our sklearn module. And we also use it for any of the upper math functions in Python. And it's very common to see that as np, numpy as np. The next 2 lines are all about our graphing. Remember I said 3 of these were about graphing? Well, we need our matplotlibary.pyplot as PLT, and you'll see that PLT is a very common setup, as is the SNS, and just like the NP. And we're going to import Seaborn as SNS, and we're going to do the SNS.set. Now, Seaborn sits on top of pyplot, and it just makes a really nice heat map. It's really good for heat maps. And if you're not familiar with heat maps, that just means we give it a color scale. The term comes from the brighter red it is, the hotter it is in some form of data, and you can set it to whatever you want. And we'll see that later on. So you'll see that those 3 lines of code here are just importing the graph function so we can graph it. And as a data scientist, you always want to graph your data and have some kind of visual. It's really hard just to shove numbers in front of people and they look at it and it doesn't mean anything. And then from the sklearn.datasets, we're going to import the fetch 20 news groups. Very common one for analyzing, tokenizing words and setting them up and exploring how the words work and how do you categorize different things when you're dealing with documents. And then we set our data equal to fetch 20 news groups. So our data variable will have the data in it. And we're going to go ahead and just print the target names, data.target names. And let's see what that looks like. And you'll see here we have alt atheism, comp graphics, comp os ms windows.miscellaneous, and it goes all the way down to talk politics.miscellaneous, talk religion.miscellaneous. These are the categories they've already assigned to this news group. And it's called Fetch 20 because you'll see I believe there's 20 different topics in here, or 20 different categories as we scroll down. Now, we've gone through the 20 different categories, and we're going to go ahead and start defining all the categories and set up our data. So we're actually going to go ahead and get the data all set up and take a look at our data. And let's move this over to our Jupyter notebook, and let's see what this code does. First, we're going to set our categories. Now, if you noticed up here, I could have just as easily set this equal to data.target_names, because it's the same thing. But we want to kind of spell it out for you so you can see the different categories. It kind of makes it more visual so you can see what your data is looking like in the background. Once we've created the categories, we're going to open up a train set. So this training set of data is going to go into Fetch 20 news groups, and it's a subset in there called train, and categories equals categories. So we're pulling out those categories that match. And then if you have a train set, you should also have the testing set. We have test equals Fetch 20 news groups, subset equals test, and categories equals categories. And let's go down one size so it all fits on my screen. There we go. And just so we can really see what's going on, let's see what happens when we print out one part of that data. So it creates train, and under train it creates train.data, and we're just going to look at data piece number 5. And let's go ahead and run that and see what that looks like. And you can see when I print train.data number 5 under train, it prints out one of the articles. This is article number 5. You can go through and read it on there. And we can also go in here and change this to test, which should look identical because it's splitting the data up into different groups, train and test. And we'll see test number 5 is a different article, but it's another article in here. And maybe you're curious and you want to see just how many articles are in here. We could do length of train.data. And if we run that, you'll see that the training data has 11,314 articles. So we're not going to go through all those articles. That's a lot of articles. But we can look at one of them just so you can see what kind of information is coming out of it and what we're looking at. And we'll just look at number 5 for today. And here we have it. Rewording the Second Amendment IDs, VTT, lines 58, in article, etc. And you can scroll all the way down and see all the different parts to there. Now, we've looked at it, and that's pretty complicated when you look at one of these articles to try to figure out how do you weight this. If you look down here, we have different words, and maybe the word from. Well, from is probably in all the articles, so it's not going to have a lot of meaning as far as trying to figure out whether this article fits one of the categories or not. So trying to figure out which category it fits in based on these words is where the challenge comes in. Now that we've viewed our data, we're going to dive in and do the actual predictions. This is the actual Naïve Bayes. And we're going to throw another model at you, or another module at you here in just a second. We can't go into too much detail, but it deals specifically working with words and text and what they call tokenizing those words. So let's take this code and let's skip on over to our Jupyter notebook and walk through it. And here we are in our Jupyter notebook. Let's paste that in there. And I can run this code right off the bat. It's not actually going to display anything yet, but it has a lot going on in here. So at the top, we had the print module from the earlier one. I didn't know why that was in there. So we're going to start by importing our necessary packages. And from the sklearn features extraction.txt, we're going to import tf-idf vectorizer. I told you we're going to throw a module at you. We can't go too much into the math behind this or how it works. You can look it up. The notation for the math is usually tf.idf. And that's just a way of weighing the words. And it weighs the words based on how many times they're used in a document, how many times or how many documents they're used in. And it's a well-used formula. It's been around for a while. It's a little confusing to put this in here, but let's let it know that it just goes in there and weights the different words in the document for us. That way we don't have to wait. And if you put a weight on it, if you remember I was talking about that up here earlier, if these are all emails, they probably all have the word from in them. From probably has a very low weight. It has very little value in telling you what this document's about. Same with words like in article, in articles, in, cost of, un, maybe cost might, or where words like criminal, weapons, destruction, these might have a heavier weight because they describe a little bit more what the article's doing. Well, how do you figure out all those weights in the different articles? That's what this module does. That's what the tf-idf vectorizer is going to do for us. And then we're going to import our sklearn.naïve Bayes and that's our multinomial NB. Multinomial Naïve Bayes, pretty easy to understand that, where that comes from. And then finally we have the Simplilearn pipeline, import make pipeline. Now, the make pipeline is just a cool piece of code because we're going to take the information we get from the TF-IDF vectorizer and we're going to pump that into the multinomial NB. So a pipeline is just a way of organizing how things flow. It's used commonly. You probably already guessed what it is if you've done any businesses. They talk about the sales pipeline. If you're on a work crew or a project manager, you have your pipeline of information that's going through, or your projects and what has to be done in what order. That's all this pipeline is. We're going to take the TF-ID vectorizer and then we're going to push that into the multinomial NB. Now, we've designated that as the variable model. We have our pipeline model. And we're going to take that model, and this is just so elegant. This is done in just a couple lines of code. Model.fit. And we're going to fit the data, and first the train data, and then the train target. Now, the train data has the different articles in it. You can see the one we were just looking at. And the train.target is what category they already categorized that particular article as. And what's happening here is the train data is going into the TF-ID vectorizer. So when you have one of these articles, it goes in there, it weights all the words in there. So there's thousands of words with different weights on them. I remember once running a model on this and I literally had 2.4 million tokens go into this. So when you're dealing like large document bases, you can have a huge number of different words. It then takes those words, gives them a weight, and then based on that weight, based on the words and the weights, and then puts that into the multinomial NB. And once we go into our Naïve Bayes, we want to put the train target in there. So the train data that's been mapped to the TF-ID vectorizer is now going through the multinomial NB, and then we're telling it, well, these are the answers. These are the answers to the different documents. So this document that has all these words with these different weights from the first part is going to be whatever category it comes out of. Maybe it's the talk show or the article on religion, miscellaneous. Once we fit that model, we can then take labels and we're going to set that equal to model.predict. Most of the sklearn use the term .predict to let us know that we've now trained the model and now we want to get some answers. And we're going to put our test data in there because our test data is the stuff we held off to the side. We didn't train it on there and we don't know what's going to come up out of it, and we just want to find out how good our labels are. Do they match what they should be? Now, I've already run this through. There's no actual output to it to show. This is just setting it all up. This is just training our model, creating the labels so we can see how good it is, and then we move on to the next step to find out what happened. To do this, we're going to go ahead and create a confusion matrix and a heat map. So the confusion matrix, which is confusing just by its very name, is basically going to ask how confused is our answer. Did it get it correct, or did it miss some things in there or have some missed labels? And then we're going to put that on a heat map so we'll have some nice colors to look at to see how that plots out. Let's go ahead and take this code and see how that, take a walk through it and see what that looks like. So back to our Jupyter notebook, I'm going to put the code in there, and let's go ahead and run that code. Take it just a moment. And remember, we had the inline, that way my graph shows up on the inline here. And let's walk through the code and then we'll look at this and see what that means. So, make it a little bit bigger. There we go. No reason not to use the whole screen. Too big. So we have here, from sklearn metrics, import confusion matrix. And that's just going to generate a set of data that says the prediction was such, the actual truth was either agreed with it or is something different. And it's going to add up those numbers so we can take a look and just see how well it worked. And we're going to set a variable mat equal to confusion matrix. And we have our test target, our test data that was not part of the training. Very important in data science, we always keep our test data separate. Otherwise, it's not a valid model if we can't properly test it with new data. And this is the labels we created from that test data. These are the ones that we predict it's going to be. So we go in and we create our SN heat map. The SNS is our seaborne, which sits on top of the pie plot. So when we create a SNS.heatmap, we take our confusion matrix, and it's going to be mat.t. And do we have other variables that go into the SNS.heatmap? We're not going to go into detail what all the variables mean. The annotation equals true. That's what tells it to put the numbers here. So you have the 166, the 1, the 0001. Format D and C bar equals false have to do with the format. If you take those out, you'll see that some things disappear. And then the X tick labels and the Y tick labels, those are our target names. And you can see right here, that's the alt atheism, comp graphics, comp OS, MS, Windows, miscellaneous. And then finally, we have our plt.x label. Remember the SNS or the Seaborn sits on top of our matplot library, our PLT. And so we want to just tell it X label equals a true is true. The labels are true. And then the Y label is prediction label. So when we say a true, this is what it actually is. And the prediction is what we predicted. And let's look at this graph, because that's probably a little confusing the way I rattled through it. And what I'm going to do is I'm going to go ahead and flip back to the slides, because they have a black background they put in there that helps it shine a little bit better so you can see the graph a little bit easier. So in reading this graph, what we want to look at is how the color scheme has come out. And you'll see a line right down the middle, diagonally, from upper left to bottom right. What that is if you look at the labels, we have our predicted label on the left and our true label on the right. Those are the numbers where the prediction and the true come together. And this is what we want to see, is we want to see those lit up. That's what that heat map does. As you can see that it did a good job of finding those data. And you'll notice that there's a couple of red spots on there where it missed. You know, it's a little confused when we talk about talk religion miscellaneous versus talk politics miscellaneous, social religion Christian versus alt atheism. It mislabeled some of those. And those are very similar topics, so you could understand why it might mislabel them. But overall, it did a pretty good job. If we're going to create these models, we want to go ahead and be able to use them. So let's see what that looks like. To do this, let's go ahead and create a definition, a function to run. And we're going to call this function, let me just expand that just a notch here. There we go. I like mine in big letters. Predict categories. We want to predict the category. We're going to send it S, a string. And then we're sending it train equals train. We have our training model. And then we had our pipeline, model equals model. This way we don't have to resend these variables each time. The definition knows that because I said train equals train, and I put the equal for model. And then we're going to set the prediction equal to the model.predict s. So it's going to send whatever string we send to it. It's going to push that string through the pipeline, the model pipeline. It's going to go through and tokenize it and put it through the TF, IDF, convert that into numbers and weights for all the different documents and words, and then it'll put that through our Naïve Bayes. And from it, we'll go ahead and get our prediction. We're going to predict what value it is. And so we're going to return train.targetNamesPredict of 0. And remember that the train.targetNames, that's just categories. I could have just as easily put categories in there .predict of 0. So we're taking the prediction, which is a number, and we're converting it to an actual category. We're converting it from, I don't know what the actual numbers are, but let's say 0 equals alt atheism. So we're going to convert that 0 to the word, or 1, maybe it equals comp graphics. So we're going to convert number 1 into comp graphics. That's all that is. And then we got to go ahead and then we need to go ahead and run this. So I load that up. And then once I run that, we can start doing some predictions. I'm going to go ahead and type in predict category. And let's just do predict category Jesus Christ. And it comes back and says it's social, religion, Christian. That's pretty good. Now, note I didn't put print on this. One of the nice things about the Jupyter Notebook Editor and a lot of inline editors is if you just put the name of the variable out as returning the variable train.target_names, it'll automatically print that for you. In your own IDE, you might have to put in print. Let's see where else we can take this. And maybe you're a space science buff. So how about sending load to International Space Station? And if we run that, we get science space. Or maybe you're a automobile buff. And let's do, they were going to tell me Audi is better than BMW, but I'm going to do BMW is better than an Audi. So maybe you're a car buff. And we run that, and you'll see it says recreational. I'm assuming that's what REC stands for. Autos. So I did a pretty good job labeling that one. How about if we have something like a caption running through there? President of India. And if we run that, it comes up and says talk, politics, miscellaneous.
we're going to drill down to what is classification. I touched upon all those different aspects that classification is the yes, no. You're classifying it as something. And the reason they spend a lot of time on classification is because it's one of the easier ones to understand. It's a little easier to track. It's a little easier to figure out the errors on it. And when we're talking about a confusion matrix, we're usually talking about classification. And I'll show you why here in a little bit. Classification is a process of classifying data into different categories based on some of their common characteristics. Example, a system classifying spam email. And you can see here we have our email coming in. Some of them are spam, some of them are not. And the classifier has to only say yes or no. It's spam or it's not spam. Need for confusion matrices. Classification models have multiple output categories. Most error measures will tell us the total error in our model, but we cannot use it to find out individual instances of errors in our models. So you have your input coming in, you have your classifier. It measures the error and it says, 53 of these are correct. But we don't know which 53% are correct. Is it 53% correct on guessing on the spam? Is it 23% guessing on spam and 27% guessing on what's not spam? This is where the confusion matrix comes in. So during the classification, we also have to overcome the limitations of accuracy. Accuracy can be misleading for classification problems. If there is a significant class imbalance, a model might predict the majority class for all cases and have a high accuracy score. And so you can see here we have our email coming in and there's 2 spams. The classifier comes in and goes, hey, it only catches one of those spams and it misclassifies one that's not spam. So our model predicted 8 out of 10 instances and will have an accuracy of 80%. But is it classifying correctly? A confusion matrix represents a table layout of the different outcomes of prediction and results of a classification problem and helps visualize its outcomes. And so you see here we have our simple chart, predicted and actual. The confusion matrix helps us identify the correct predictions of a model for different individual classes as well as the errors. So you'll see here that the values predicted by our classifier are along the rows. This is what we're going to guess it is, or our model is guessing what this is based on its training. So we've already trained the model to guess whether it's spam or not spam or whatever it is you're working on. And then the actual values of our data set are along the columns. So this is the actual value that's supposed to be. People who can speak English will be classified as positives. So, because they have remember 0 or 1. Do you speak English? Yes, no. And you could extend this that they might have, do you speak French? Do you speak whatever languages? And so you might have a whole lot of classifiers that you would look at each one of these. People who cannot speak English will be classified as negatives. So there'll be a 0. So, 0 ones. The number of times our actual positive values are equal to predicted positive values gives us true positive, TP. The number of times our actual negative values are equal to predictive negative values gives us true negative, TN. The number of times our model wrongly predicts negative values as positives gives us a false positive, FP. And you'll see when you're working with these a lot, memorizing that it's false positive, you can easily figure out what that is, and pretty soon you're just looking at the FP or the TP, depending on what you're working on. And the number of times our model wrongly predicts positive values as negatives gives us a false negative, FP. Now, I'm going to do a quick step out here. Let's say you're working in the medical and we're talking about cancer. Do you really want a bunch of false negatives? You want 0 under false negative. So when we look at this confusion matrix, if you have 5% false positives and 5% false negatives, it'd be much better to even have 20% false positives because they go in and test it and 0 false negatives. The same might be true if you're working on, say, a car driving. Is this a safe place for the car to go? Well, you really don't want any false positives. Yes, this is safe right over the cliff. So again, when you're working on the project or whatever it is you're working on, this chart suddenly has huge value. We were talking about spam email. how many important emails, say from your banking overdraft charge coming in, that you want to be a false negative. You don't want it to go in the spam folder. Likewise, you want to get as much of the spam out of there, but you don't want to miss anything really important. Confusion matrix metrics are performance measures which help us find the accuracy of our classifier. There are 4 main metrics: accuracy, precision, recall, and F1 score. The F1 score is the one I usually hear the most, and accuracy is usually what you put on your chart when you're sending in front of the shareholders. How accurate is it? People understand accuracy. F1 score is a little bit more on the math side, and so you got to be a little careful when you're quoting F1 scores in the when you're sitting there with all the shareholders, because a lot of them will just glaze over. So confusion matrix metrics are performance measures which help us find the accuracy of our classifier. There are 4 main metrics. Accuracy. The accuracy is used to find the portion of the correctly classified values. It tells us how often our classifier is right. It is the sum of all true values divided by the total values. And this makes sense. Again, it's one of those things. I don't want to, it depends on what you're looking for. Are you looking for not to miss any spam mails? Are you looking to drive down the road and not run anybody over? Precision is used to calculate the model's ability to classify positive values correctly. It answers the question, when the model predicts a positive value, how often is it right? It is the true positive divided by the total number of predicted positive values. Again, this one depends on what project you're working on, whether this is what you're going to be focusing on. So recall, it is used to calculate the model's ability to predict positive values. How often does the model actually predict the correct positive values? It is the true positives divided by the total number of actual positive values. And then your F1 score. It is the harmonic mean of recall and precision. It is useful when you need to take both precision and recall into account. Consider the following 2 confusion matrices, derived from 2 different classifiers. To figure out which one performs better, we can find the confusion matrix for both of them. And you can see we're back to, does it classify whether they can speak English or non-speaker? They don't know the English language. And so we put these 2 confusion matrices out here. We can go ahead and do the math behind that. We can look up the accuracy. That's the TPN plus TN over the TF plus TN plus FP plus FN. And so we get an accuracy of 0.8125. And we have a precision. If you do the precision, which is your TP, truth positive, over TP plus FP, we get 0.891. And if we do the recall, we'll end up with the 0.825. That's your TP over TP plus FN. And then, of course, your F1 score, which is 2 times precision times recall over precision plus recall. And we get the 0.857. And if we do that with another model, let's say we had 2 different models and we're trying to see which one we want to use for whatever reason, we might go ahead and compute the same things. We have our accuracy, our precision, and our recall, and our F1 score. And as we're looking at this, we might look at the accuracy, because that's really what we're interested in, is how many people are we able to classify as being able to speak English. I really don't want to know I really don't want to know if they're non-speakers. I'd rather miss 10 people speaking English instead of 15. And so you can see from these charts, we probably go with the first model because it does a better job guessing who speaks English and has a higher accuracy, because in this case, that is what we're looking for. So with that, we'll go ahead and pull up a demo so you can see what this looks like in the Python setup in the actual coding. For this, we'll go into Anaconda Navigator. If you're not familiar with Anaconda, it's a really good tool to use as far as doing display and demos. And for quick development. As a data scientist, I just love the package. Now, if you're going to do something heavier lifting, there's some limitations with Anaconda and with the setup. But in general, you can do just about anything in here with your Python. And for this, we'll go with Jupyter Notebook. Jupyter Lab is the same as Jupyter Notebook. You'll see they now have integration with PyCharm if you work in PyCharm. Certainly there's a lot of other integrations that Anaconda has. And we've opened up my Simplilearn files I work on and create a new file called Confusion Matrix Demo. And the first thing we want to note is the data we're working with. Here I've opened it up in a WordPad or Notepad or whatever. You can see it's got a row of headers, comma separated, and then all the data going down below. And then I save this in the same file so I don't have to remember what path I'm working on. Of course, if you have your data separated and you're working with a lot of data, you probably want to put it into a different folder or file depending on what you're doing. And the first thing we want to do is go ahead and import our tools. We're going to use the pandas. That's our data frame. If you haven't had a chance to work with the data frame, please review pandas data frame and go into Simplilearn. You can pull up the pandas data frame tutorial on there. And then we're going to use the sci-ket framework, which is all denoted as sklearn. And I can just pull this in. You can see here's the sci-ket-learn.org with a stable version that you can import into your Python. And from here, we're going to use the train test split for splitting our data. We're going to do some pre-processing. We're going to use the logistic regression model. That's our actual machine learning model we're using. And then what this particular setup is about is we're going to do the accuracy score, the confusion matrix, and the classifier report. So let me go ahead and run that and bring all that information in. And just like we opened the file, we need to go ahead and load our data in here. So we're going to go ahead and do our pandas read CSV. And then just because we're in Jupyter Notebook, we can just put data to read the data in here. A lot of times we'll actually, let me just do this. I prefer to do just the head of the data, or the top part. And you can see we have age, sex, I'm not sure what CP stands for, test BPS, cholesterol. So a lot of different measurements. If you were in this domain, you'd want to know what all these different measurements mean. I don't want to focus on that too much because when we're talking about data science, a lot of times you have no idea what the data means. If you've ever looked up the breast cancer measurement, it's just a bunch of measurements and numbers. Unless you're a doctor, you're going to have no idea what those measurements mean. But if it's your specialty in your domain, you better know them. So we're going to go ahead and create y, and we're going to set it equal to the target. So here's our target value here. And it's either 1 or 0. So we have a classifier. If you're dealing with 1, 0, true, false, what do you have? You have a classifier. And then our x is going to be everything except for the target. So we're going to go ahead and drop the target. Axis equals 1. Remember, that's columns versus the index or rows. Axis equals 0 would give you an error, but you would drop like row 2. And then we'll go ahead and just print that out so you can see what we're looking at. And here we have y data, x data. And you can see from the x data we have the x head. And we can go ahead and just do print the y head data and run that. So this is all loading the data that we've done so far. If there's a confusion in there, go back and rewind the tape and review it. And then we need to go ahead and split our data into our X-train, X-test, Y-train, Y-test. And then keep in mind you always want to split the data before we do the scalar. And the reason is that you want the scalar on the training data to be set on the training data or fit to it, but not on the test data. Think of this as being out in the field. It could actually alter your results. So it's always important to make sure whatever you do to the training data or whatever fit you're doing is always done on the training, not on the test. And then we want to go ahead and scale the data. Now, we are working with linear regression model. And I'll mention this here in a minute when we get to the actual model. So sometimes you don't need to scale it when you're working with linear regression models. It's not going to change your result as much as, say, a neural network where it has a huge impact. But we're going to go ahead and here's our x train, x test, y train, y test. We create our scalar. We go ahead and scale. The scale is going to fit the x train. And then we're going to go ahead and take our x train and transform it. And then we also need to take our x test and transform it based on the scale on here, so that our x is now between that nice -1 to 1. And so this is all our pre-data setup. And hopefully all of that looks fairly familiar to you if you've done a number of our other classes and you're up to the setup on here. And then what we want to go ahead and do is create our model. And we're going to use a logistic regression model. And from the logistic regression model, we're going to go ahead and fit our x train and y train. And then we'll run our predicted value on here. And so let's go ahead and run that. And so now we actually have like our x test and our prediction. So if you remember from our matrix, we're looking for the actual versus the prediction and how those compare. And if I take us back up here, you're going to notice that we imported the accuracy score, the confusion matrix, and the classification report. And there's, of course, our logistic regression, the model we're using for this. And I did mention I was going to talk a little bit about scalar and the regression model. The scalar, on a lot of your regression models, your basic math standard regression models, and I'd have to look it up for the logistic regression model. When you're using a standard regression model, you don't need to scale the data. It's already just built in by the way the model works, in most cases. But if you're in a neural network and there's a lot of other different setups, then you really want to take this and fit that on there. And so we can go in and do the accuracy. And this is, if you remember correctly, we were looking at the accuracy with the English speaking. So this is saying our accuracy as to whether this person is, I believe this is the heart data set. It's going to be accurate about 85% of the time as far as whether it's going to predict the person's going to have a heart condition, or the 1 as it comes up with the 0, 1 on there. Which would mean at this point that you have an 85% being correct on telling someone they're extremely high risk for a heart attack kind of thing. And so we want to go ahead and create our confusion matrix. And let me just do that. Of course, the software does everything for us. So we'll go ahead and run this. And you can see right here, here's our 25 correct predictions right here. And if you remember from our slide, I'll just bring this over so it's a nice visual. We have our true positive, false positive. So we had 25 which were true, that it said, hey, this person's going to be high risk at heart. And we had 4 that were still high risk that it said were false. So out of these 25 people, or out of these 29 people, and that makes sense because you have 0.85, out of 29 people, it was correct on 25 of them. And so here's our accuracy score. We were just looking at that. Our accuracy is your true positive and your true negative over all of them. So how true is it? And there was our accuracy coming up here, 0.85. And then we have our nice matrix generated from that. And you can see right here is a similar matrix we had going for from the slide. And this should start asking questions at this point. So if you're in a board meeting or you're working with this, you really want to start looking at this data here and saying, well, is this good enough? Is this number of people, and hopefully you'd have a much larger data set, is my confusion matrix showing for the true positive and false positive, is that acceptable for what we're doing? And of course, if you're going to put together whatever data you're putting out, you might want to separate the true negative, false positive, false negative, true positive. And you can simply do that by doing the confusion matrix. And then, of course, the ravel part lets you set that up. So you can just split that right up into a nice tuple. And the final thing we want to show you here in the coding on this part is the confusion matrix metrics. And so we can come in here and just use the matrix equals classification report, the y-test and the predict. And then we're going to take that classification report and go ahead and print that out. And you can see here it does a nice job giving you your accuracy, your micro average, your weighted average, you have your precision, your recall, your F1 score, and your support all in one window, so you can start looking at this data and saying, oh, okay, our precision's at 0.83, 0.87 for getting a positive, and 0.83 for the negative side for a zero. And we start talking about whether this is a valid information or not to use.
There's no better time to train yourself in the exciting field of machine learning. If you're looking for a course that covers everything from the fundamentals to advanced techniques, for that, accelerate your career in AI and ML with a comprehensive postgraduate program in AI and machine learning. Gain expertise in machine learning, deep learning, NLP, computer vision, and reinforcement learning. You will receive a prestigious certificate, exclusive alumni membership, and Ask Me Anything sessions by IBM with 3 capstone projects and 25 plus industry projects using real datasets from Twitter, Uber, and more. You will gain practical experience. Masterclasses by Caltech faculty and IBM experts ensure top-notch education. Simplilearn's Job Assist helps you notice by leading companies. This program covers statistics, Python, supervised and unsupervised learning, NLP, neural networks, computer vision, GANs, Keras, TensorFlow, and many more skills. Enroll now and unlock exciting AI and ML opportunities. The course link is mentioned in the description box below.
Machine learning has improved our lives in a number of wonderful ways. Today, let's talk about some of these. I'm Rahul from Simplilearn, and these are the top 10 applications of machine learning. First, let's talk about virtual personal assistants. Google Assistant, Alexa, Cortana, and Siri. Now, we've all used one of these at least at some point in our lives. Now, these help improve our lives in a great number of ways. For example, you could tell them to call someone. You could tell them to play some music. You could tell them to even schedule an appointment. So how do these things actually work? First, they record whatever you're saying, send it over to a server, which is usually in a cloud, decode it with the help of machine learning and neural networks, and then provide you with an output. So if you've ever noticed that these systems don't work very well without the internet, that's because the server couldn't be contacted. Next, let's talk about traffic predictions. Now say I wanted to travel from Buckingham Palace to Lord's Cricket Ground. The first thing I would probably do is to get on Google Maps. So, search it. And let's put it here. So here we have the path you should take to get to Lord's Cricket Ground. Now here the map is a combination of red, yellow, and blue. Now the blue regions signify a clear road, that is, you won't encounter traffic there. The yellow indicate that they are slightly congested, and red means they're heavily congested. So let's look at the map, a different version of the same map. And here, as I told you before, red means heavily congested, yellow means slow moving, and blue means clear. So how exactly is Google able to tell you that the traffic is clear, slow moving, or heavily congested? So this is with the help of machine learning and with the help of 2 important measures. First is the average time that's taken on specific days at specific times on that route. The second one is the real-time location data of vehicles from Google Maps and with the help of sensors. Some of the other popular map services are Bing Maps, Maps.me, and here we go. Next up, we have social media personalization. So say I want to buy a drone, and I'm on Amazon, and I want to buy a DJI Mavic Pro. The thing is, it's close to 1 lakh, so I don't want to buy it right now. But the next time I'm on Facebook, I'll see an advertisement for the product. Next time I'm on YouTube, I'll see an advertisement. Even on Instagram, I'll see an advertisement. So here, with the help of machine learning, Google has understood that I'm interested in this particular product. Hence, it's targeting me with these advertisements. This is also with the help of machine learning. Let's talk about email spam filtering. Now, this is the spam that's in my inbox. Now, how does Gmail know what's spam and what's not spam? So Gmail has an entire collection of emails which have already been labeled as spam or not spam. So after analyzing this data, Gmail is able to find some characteristics like the word lottery or winner. From then on, any new email that comes to your inbox goes through a few spam filters to decide whether it's spam or not. Now, some of the popular spam filters that Gmail uses is content filters, header filters, general blacklist filters, and so on. Next, we have online fraud detection. Now, there are several ways that online fraud can take place. For example, there's identity theft, where they steal your identity, fake accounts, where these accounts only last for how long the transaction takes place and stop existing after that, and man-in-the-middle attacks, where they steal your money while the transaction is taking place. The feed-forward neural network helps determine whether a transaction is genuine or fraudulent. So what happens with feed-forward neural networks are that the outputs are converted into hash values, and these values become the inputs for the next round. So for every real transaction that takes place, there's a specific pattern. A fraudulent transaction would stand out because of the significant changes that it would cause with the hash values. Stock market trading. Machine learning is used extensively when it comes to stock market trading. Now you have stock market indices like Nikkei. They use long short-term memory neural networks. Now these are used to classify, process and predict data when there are time lags of unknown size and duration. Now this is used to predict stock market trends. Assistive medical technology. Now, medical technology has been innovated. With the help of machine learning, diagnosing diseases has been easier, from which we can create 3D models that can predict where exactly there are lesions in the brain. It works just as well for brain tumors and ischemic stroke lesions. They can also be used in fetal imaging and cardiac analysis. Now, some of the medical fields that machine learning will help assist in is disease identification, personalized treatment, drug discovery, clinical research, and radiology. And finally, we have automatic translation. Now, say you're in a foreign country and you see billboards and signs that you don't understand. That's where automatic translation comes of help. Now, how does automatic translation actually work? The technology behind it is the same as the sequence-to-sequence learning, which is the same thing that's used with chatbots. Here, the image recognition happens using convolutional neural networks, and the text is identified using optical character recognition. Furthermore, the sequence-to-sequence algorithm is also used to translate the text from one language to the other.
So the need for feature selection. To train a model, we collect huge quantities of data to help the machine learn better. Consider a table which contains information on old cars. The model decides which cars must be crushed for spare parts. And when we talk about huge quantities of data, they save everything from people's favorite cat pictures to, and you can imagine there's so much data out there. Even in a company, they'll save all these little pieces of information about people and companies and corporations. You need some way to sort through, because if you try to run your models on all of it, you'll end up with these very clunky models, and they might have issues, which we'll talk about later. But in this case, we're talking about cars and crushing. But not all this data will be useful to us. Some classes or part of the data may not contribute much to our model and can be dropped. And you can see right here we have who was the owner of the car. In our data, a car will not be crushed based on its previous owner. So that's kind of a clear cut. You can see that. Why would I care who owned the car before? Once it's in the junkyard and we're crushing the cars, we're not going to really care about that. So here we have dropped the owner column, as it does not contribute to the model. Having too much unnecessary data can cause the model to be slow. The model may also learn from this irrelevant data and be inaccurate. So feature selection is a process of reducing the input variable to your model by using only relevant data and getting rid of the noise in the data. Consider the database given below. A library wants to donate some old books to make place in their shelves for new books. We want to train a model to automate this task. In this case, the color of the book does not matter, and keeping it can cause a model to learn to donate books based on color. We can remove this as a feature. Using feature selection, we can optimize our model in several ways. And so the number one is to prevent learning from noise and overfitting. That's actually the huge one, because we don't want it to give us the wrong prediction. And that means also improved accuracy. So instead of giving us a wrong prediction, we also want it to be as close to the right answer as we can get. And we want to reduce the training time. It's an exponential growth in some of these models, so that each feature you add in increases that much more training time. We talk about feature selection methods. We put together a nice little flow chart that shows the various methods used for feature selection. And you have your basic feature selection, and then there is supervised and unsupervised. Under supervised, there's intrinsic, wrapper method, filter method. So when we talk about unsupervised feature selection, refers to the method which does not need the output label class for feature selection. And that was, you can see here under unsupervised, we don't have, that's really a growing market right now, unsupervised learning. And so feature selection is the same thing. Supervised feature selection refers to the method which uses the output label class for the feature selection. And if you remember, we looked at we have intrinsic, wrapper, and filter method. So we're going to start with the filter method on this. Now remember, we know what the output is. So we're going to be looking at that output to see how well it's doing versus the features. In this method, features are dropped based on their relation to the output, or how they are correlating to the output. And you can see here we have a set of features, selecting best feature, learning algorithm, and then performance. And so we want to find out which feature correlates to the performance on the output. Consider the example of book classifier. Here we drop the color column based on simple deduction. And that kind of sums it up in a nutshell, is we want to filter out things that clearly do not go with what we're looking for. We look at the wrapper method. In the wrapper method, we split our data into subsets and train a model using this. Based on the output of the model, we add and subtract features and train the model again. And you can see here in the wrapper method we have a set of features, we generate a subset, we run it through the algorithm, and we see how each one of those subset of features performs. Consider the book data set. By using the wrapper method, we would use a subset of different features to train the machine and adjust the subset according to the output. And so you can see here, let's say we take name and number of times read, and we run just those, and we look at the output. And if we looked at them with all 4 inputs and look at the output, we'd see quite a different variation in there, and we might say, you know what, condition of the book and color really doesn't affect what we're looking for. And you can see here we've run it on condition of the book and color. Depending on the output of the model, we will choose our final set of features. These features will give us the best result for our model. And it might come up that the name, number of times read, is probably pretty important. The intrinsic method, this method combines the qualities of both filter and wrapper method to create the best subset. The model will train and check the accuracy of different subsets and select the best among them. We kind of looked at a little overview of some of the stuff. Some of the common feature selection algorithms based on which method they belong to are given below. And you'll see it's primarily under supervised. There's not, like I said, a lot of unsupervised methods, and the ones that are usually use these methods and finds a way to create a supervised connection between the data. When we talk about supervised methods, we have our filter method, which we talked about, and it uses like the Pearson's coefficient, chi-squared, ANOVA coefficient. Those are all under the filter method. And in the wrapper method, recursive feature elimination. So remember, we're choosing a subset, and we want to go through there and look at each one. So you're just doing a lot of loops or recursive calculations to see which one works best and which ones don't have an impact on the output. And there's a lot of genetic algorithms to go with this too on the wrapper method and how they evaluate it. And with the intrinsic method, there's the 2 main ones we're looking at is the lasso regularization. The lasso algorithms are basically your standard regression model. So it's finding out how these different methods fit together and which ones have the best add together to have the least amount of error. The other one used in the intrinsic method is the decision tree. It says, hey, if this one is this one produces this result, this one produces this result, yes, no, which way do we go? Based on the input and the output variables, we can choose our feature selection model. So you have your numeric input coming in, you have your numeric output. If you use the Pearson's correlation coefficient or Spearman's rank coefficient, you can then select what features you're going to feed into that specific model. And you maybe have a numerical input and a categorical input, so we're going to be looking more at ANOVA correlation coefficient or Kendall's rank coefficient. And if you have a categorical input and a numerical output, we might be looking at ANOVA correlation coefficient and Kendall's rank coefficient. So based on the input and the output variables, we can choose our feature selection model. And you can see we have categorical to categorical. We might be looking at the chi-squared test, contingency tables, and mutual information. Let's go ahead and take a look and see in the Python code what we're talking about here. And I'm going to go ahead and use for my IDE the Jupyter notebook, and I always launch it out of Anaconda on here. And we'll go ahead and go up here and create a new Python 3 module. And we'll call it feature select. And since we're in Python, we're going to be working mainly with your NumPy, your pandas, your matplotlib library. So we have our number array, our data frame setup, which goes with the number array, the NumPy, the pandas data frame, and then we want to go ahead and graph everything. So we're going to import these 3 modules. And then we put together some data. We're going to read this in. It's Kobe Bryant. I guess he's a basketball player. Our guys in the back, we have a number of them. Guys, it's both, we have a lot of men and women, so it's probably a misnomer. Our team in the back They have some of them have a liking for basketball, and they know who Kobe Bryant is, and they want to learn a little bit more about Kobe Bryant and what's going in for whatever's going on with his game in basketball. So we're going to take a look at him. And once we import the data, we can see what columns are available, original features count, so we can see how many features there are, the length of it, and we'll actually have a list of them, and then print just the data head, the top 5 rows. And so when we do this, we can see from this CSV file, we have 25 original features. Our original features are your action type, combined shot type, game event ID, and so forth. There's a lot of features in here that they're recorded on all of his shots. This is what we talk about, like a massive amount of data. I mean, people are sitting there and they record all this stuff and they import this stuff for different reasons. But depending on what we want to look at, do we really want all those features? Maybe the question we're going to ask is, what's the chance of him making any one specific shot? Right from the beginning, we can look at some of these things and say team name. Team name probably, I don't know, maybe it does matter because the other team might be really good at defense. Game date, maybe we don't really want to look at the game date. Team ID, definitely not of importance in any of this. So when we look at this, we have 25 features, and some of these features just really don't matter to us. We also have location X, location Y, latitude and longitude. I'm guessing that's the same data. We've actually imported the very similar data. Maybe they're slightly zoned differently. But as far as our program, we don't want to repeat data. Some of the models, when you repeat data into them, and this is true for most models, create a huge bias. They weigh that data over other data. So just at a glance, these are the things we're looking at. We want to find out, well, how do we get these features down and get rid of this bias and all these extraneous features that we don't really want to spend time running our models on and programming on. And as I pointed out, there's a location X, a location Y, latitude and longitude. Let's just take a look at that and see what we're looking at here. We'll go ahead and create a plot of these. And we'll just plot, we'll do a scatter plot of location X and location Y. And then we'll do a scatter plot of data lon, data lat, which is probably longitude and latitude. And the scatter plot, let's go ahead and actually put a little title here, location and scatter on there. And we'll just go ahead and plot these. And when you look at this coming in, these two graphs are pretty identical except they're flipped. And so when we look at the location from which they're shooting from, they're probably the same. And at this point we can say, okay, we can get rid of one of these sets of data. So we don't need both X and Y and latitude and longitude because it's the same data coming in. And as we look at this particular data, the latitude, longitude, we might also ask, does it really make a difference which side of the court you're on, whether you're on the left side or the right side? And so we might go ahead and explore, instead of looking at this as XY, we might look at it as a distance and an angle. And we can easily compute that. And you can see we can create our data distance equals the location X plus the location Y squared, standard Euclidean geometry or triangular geometry. Hypotenuse squared equals each side squared. And then once we've done that, we can also compute the angle. So the data angle is based on the arctangent and so forth on here. So this is all this is we're just going to compute the angle here and then set that up, pi over 2 to get our angle. And we'll go ahead and run that. And you'll see some errors come up, and that's because when we took slices over here, we took a slice of a slice. There's ways to fix that, but it's really not important for this example. So if you do see that, you want to start looking up here for, instead of data location X of not location X0, this would be like, I believe the term is .iLocation. If this was, yeah, this is in pandas. So there's different things in there, but for this, it doesn't really matter. These are just warnings. That's all they are. And then let's combine our remaining minutes and seconds column into one. There's another one. So if you remember up here, we're trying to get rid of these columns do we really need, let me see if I can find it on here. There we go. There's our minutes remaining. And then they had, what was it? It was minutes remaining and seconds column. So there's also a seconds column on here. Let me see if I can find that one. This is where it really gets kind of crazy, because here's our seconds remaining. So you can see that, and here's our minutes remaining. This gets crazy when you're looking at hundreds of these features. And you can see that if I'm going to, say, write a model that's going to predict a lot of this, and I want it to run, in this case it's a basketball and how good his shots are as the data comes in. Let's say I want to have it run on your phone. If I'm running it across hundreds of features, it's going to just hang up on your phone, where if I can get it down to just a handful, we'll actually be able to come in here and run it on a smaller device and not use up as much memory or processing power. So we'll go ahead and take data remaining time here, and data minutes remaining times 60 plus data seconds remaining. So we're just going to combine those, and we'll go ahead and reprint our data so we can see what we got coming across. We have our action type combined, and this is, we do this a lot. We want to take a look at, oops, I got it so zoomed in. Let me see if I can zoom out just a little bit. There we go. Boom. Alright, so when we come up here, you can see that we now have our distance, our angle, remaining time, which is now just a number that computes both the minutes and seconds together. And we still have, we've been adding columns. I thought you said we're supposed to subtract columns, right? We're going to delete the obsolete columns when we get to them. So we're just filtering out, and this is a filter method. We're just filtering through the things that we really don't need. And next, let's go ahead and explore team ID and team name. Let me just go ahead and run that. And if you look at this, we have Los Angeles Lakers, and then they have the team ID here, and they're unique. That's not really anything that's going to come up, because that's this particular athlete's works for that team. So it's the same on every line. So there's another thing we can filter out on there. Team ID and team name is just useless. The whole column contains only one value each, and it's pretty much useless. Let's go ahead and take a look at matchup and opponent. That's an interesting one. And we see here that we have the LAL versus POR, and the opponent is POR and IND. Again, here's a lot of duplicate information. So this basically contains the same information on here. Again, we're filtering all this stuff out, and this is because we're only looking at one athlete. This might change if you're looking at multiple athletes, that kind of thing. Now, these are easy to see, but we might have something that looks more like this. We might have something where we're looking at the distance, which we computed, and the shot distance. Are they the same thing? And what we can do is we can plot that and plot them against each other on here, and we see it just draws a nice straight line. And so, again, we're looking at the same information. So again, we're repeating stuff, and we really don't want to be running our model on repeat information on here. So again, it contains the same information. So now let's look at the shot zone area, shot zone basic, shot zone range. So now we're looking at the zones, and what does that mean? And we'll go ahead and do this also in a scatter plot. In this case, we're going to just create 3 of these side by side. So we're going to create our plot figure side 20 by 10. And then we're going to define our scatter plot by category feature. And we're going to do each one, set up on here, give it a slightly different color. And so our shot zone area is going to be plot, subplot 131, scatter 131 is how that's read, by the way. Meaning that it's number 1, we have 3 across, and this is the first one down, so 1, 1, 1. Our scatter plot by category is going to be the shot zone area. We're going to plot that, and then we're going to do the shot zone basic, and then the shot zone range, and each just push them through our definition. So each of those areas go through, and you'll see 131, 132, 133. Again, it's a 1 by 3 setup, and then it's just a place on each one. And so when we look at this, we can see that these shots, they map out the same. So it's very, again, redundant information. That should be intuitive. When we're looking at this in these color graphs, it kind of helps, and you start looking at something that's very intuitive like this is, and you start to realize that some of this stuff you'll be looking for in data you might not understand. And you'll see these circular patterns where they match, or they mostly match, and you start to realize when you're looking at these that they're repetitive data, and then you want to explore them more closely depending on what domain you're working in. So we look at these, and we look at them, and they look just like the regions of the court, but we already have stored this information in angle and distance columns. So we've seen this image before. We go back up here, and here's the similar image. And repeating that image is down here, and so let's go ahead and drop some of this stuff. So now let's drop all the useless columns. And we can drop the shot ID, team name, shot zone area, shot zone range, shot zone basic, the matchup, the longitude and latitude, because we're putting that into distance, seconds remaining, minutes remaining, because we combine that into one column, shot distance, because we have just distance on there, location X, location Y, the game event ID, game ID, all of this stuff is just being dropped on here. And we'll just go ahead and loop through our drops. And this is a nice way of doing this, because as you're playing with this, this kind of data, putting your list into one setup helps, because then you're just running it through an iteration, and you can come back and change it. You might be playing with different models and do this with models. You might be looking at all kinds of different things that you can drop and add in as you test these out. And again, we're working in the filter method. So this is a lot of human interaction with the data. And it takes a lot of critical thinking to look at this stuff and say what matches and what doesn't. And so when we look at the remaining features, let me go ahead and just run this. The original to the new count, we had 25 features. Now we have 11 features. You can see that right there. We just circle that. There's our 25, and there's old, new. Now we're down to 11. So we've cut it down to less than half. And you can just see the actual different information on here and the remaining time. At this point, we filtered it through, and then we'd move into the next process, which would be to run our model on this, and maybe we would drop some of the features and see if it runs better or worse and what happens. That's kind of would be the next step on there versus this is the filter setup, and that would be one of the other setups depending on which algorithm you use. Cross-validation in machine learning. My name is Richard Kirshner with the Simplilearn team. That's www.simplilearn.com. Get certified, get ahead. What is in it for you? We're going to cover the need for cross-validation, what is cross-validation, steps in cross-validation, and types of cross-validation. And then, of course, we'll do a nice hands-on demo so you can see what it looks like in Python code. Let's start by exploring the need for cross-validation. While choosing machine learning models, we need to compare models to see how different models perform on our data set. This goes beyond just comparing different models, but also in explaining this to the shareholders or whoever you're working with. You really need to know how valid is your data set or your models that you're working with on the data set. So the need for cross-validation comes up when the data is usually limited, and training and testing on the same portion of data does not give us an accurate view of how our model performs. And this just makes sense. If I'm going to program a model to outguess something, I don't want to use the same data I trained it with. I want to see how it performs on the next data. Otherwise, I'm just kind of like giving myself my own juice saying, hey, my model did really good because this is what it's based on. Self-fulfilling prophecy. And that is still important to do because you still need to run it on your own data to see how well your set fits your data versus how well it fits new data coming in. So training a model on the same data means that the model will eventually learn well for only that data and fail on new data. This is called overfitting. So you might write a wonderful script. It works great for predicting the failure on loans for a bank, but it only works for the data you already have, not the new data coming in. And that, again, is overfitting. So it's not going to give you you're not going to get a good value as to how good your model is going to fit the new data coming in. So what is cross-validation? Cross-validation is a technique which is used to train and evaluate our model on a portion of our database before reportioning our data set and eventually using it on the new portions. Consider the block shown to be our complete data set. And you can see we've already taken the data set and divided it into 4 sections. And here we've cut out one section highlighted in yellow. We partition the data set into training and testing data. And you'll see that in this particular example, we've taken 75% of the data, or 3/4 of it. And we said, okay, we're going to use that to train our model. And the testing data set will be used by our model to predict on unseen data. It is used to evaluate our model's performance. And this is what we were talking about, is you want to be able to train it on one set of data, come back and say, hey, this is how well it performs on data it's never seen before. Now, there's an interesting relationship between these, and it's important to also see how well it performs on the trained data. We're not going to talk about too much on that one. It's usually used in higher end neural networks, and it's one of the ways they know when the training data is done and the testing data and the predictions kind of match. That's when they start looking at, okay, you've trained it enough. And you can see here, we take the first partition and we go ahead and we map how good it did. And we partition the data set into training and testing data. We then choose a different portion of the data for training and testing and reevaluate the model performance to get more accurate results. And you can see here we've colored it in a nice pretty yellow for you. And so we've tested on the first section and now we're testing it on the second section. So we're still using 3/4 of the data to train our model and 1/4 to test it. And we just loop through all the different quarters to test it. That's what we're talking about when we talk about cross-validation, is we want to be able to get a picture of how it works on the data it hasn't seen. And we look at the steps in cross-validation. The steps involved in cross-validation begin with step 1, split the data into train and test sets and evaluate model's performance. And so we measure 1, we measure 2, we measure 3, and we measure 4. And each one of these generates its own performance rate based on the other 75% being used to validate that data. How well does it perform on the unseen data? And so we have actually created 4 separate models. And then we just take those measurements, 1, 2, 3, 4, we add them together, divide by 4, or however many divisions you use, and you get a total model performance. For myself, when I first start doing a new data set, I'll start with just partitioning it into 3, because it runs faster, it's quick. You only have to run 3 models, that kind of setup. A lot of this depends on how much data you have. If you have a lot of data, 3 works just fine. If you're very limited on how much data is coming in, you might want to divide it into more validation sets when you're first testing out your models and your data sets. And there's other steps in here we'll look at in just a moment. Types of cross-validation. Now this is important because we looked at one type. This actually we're going to put down as the number 2 type. One of the ways we can do this is what they call leave one out cross-validation. This is where the entire data set is used for training and one singular data point is kept as the testing data. Consider a data set with n points. n-1 will be training set and 1 point will be testing set. Leave one out cross-validation is then we go to another point and it'll be chosen as the testing data and the rest of the points will be the training. This will repeat for the rest of the data set n times. And yes, we're creating, if your data is n, well they used n-1 n, so we'll do it n-1 times, and you create n-1 models that you're testing across your data set to see how good your model does. The final performance measure will be the average of the measures for all n iterations. And so you add up all those different measures and divide by n-1. Now keep in mind, at the end, you just run it across all the data and that's your final model that you're going to actually push out. This is to validate it. This gives it an n-1 validation. You can imagine if you're dealing with big data and you have terabytes of data, doing it this way would probably be a very bad idea. You might have to wait a month before you get an answer. Where dividing it into smaller portion works. So again, we're dealing with smaller amounts of data usually when you do this level of cross-validation. K-fold cross-validation. This is what our example initially was, and this is what most people look at is you divide it into, in this case, 4 sections. So the data is divided into k number of different sections. And like I said, I like to use 3 if I'm just initially looking at the data. It gives a decent training model versus a faster run, so at least I know I'm using 66.66% of the data. One section is for testing and the rest for training. The number of sections k is selected depending on size of data set. Again, if you have a very small data set, you want your k to be much larger because you really can't divide out most of your data. You lose so much in the training. And so if you divide it out enough, you end up with leave one out cross-validation. We divide it all the way to each data point gets its own run. And this will generate, if we do k equals 5, it will generate 5 different models for you to evaluate on. And so of course we're generating each one. The final performance measure will be the average of the output measures of the k iterations. So we add them all together and we divide by k. So we're going to have 5 models, there's going to be 5 measurements, and we'll divide that by 5, and that gives us a good guess, good estimate of what the measure is on this particular cross-validation going on and how good our model is. And then you train the model with all the data in the end because you don't want to leave one section out. Now, one of the things, and I'm going to point that out on this page before we get into the next validation, what happens if your measurements are all over the board? You've divided into 5 sections. One measurement is really bad, one is really good. That means there's something going on with the way you divided your data and how the data is set up. And we want to start looking at stratified k-fold cross-validation. The data is split so that each portion has the same percentage of all the different classes that exist in the data set. Consider a data set which has 2 classes of data as shown. In normal cross-validation, the data is divided without keeping in mind the distribution of individual classes. The model thus cannot properly predict for minority classes. And you could think of this in that if you were, let's say, you had a data set that was looking at drivers. How good do drivers do when driving their car? And one of the features is the color of the car. Now, my guess, it probably wouldn't have a huge impact as far as the data, but let's face it, there's the most common car out there is probably white, there's probably brown, and you get into like fire engine red. It only has a few red cars. At that point, if you train your data on only cars that aren't red, you're going to run into a problem when the red car comes up because it might have one model that says red cars are bad drivers or one model that says red cars are good drivers. And at that point, it's going to weigh the data and create a bias. So you need to divide up all those different features. This comes out extremely heavily in doing population statistics, where we might pull an area out, run the statistics, but because we're basing our statistics just on that area and the people that live in there, that area might be predominantly one group of people. And then you have a minority that is part of that group, but there's a bias as far as how they fit into the data and how it weighs their particular choices. And then you start running into problems with the bias on there. That's why using stratified k-fold cross-validation is a very important thing to add into your toolkit when you start looking at the different data structures and validating your models. Stratified k-folds overcomes this by maintaining the same percentage of data classes in all the folds. Models can be trained even on minority classes. And you can see here where even though we have 5 separate splits in the data, we used k equals 5, each one has a representation of all the different features in there so that we help get rid of that bias and help each one train equally across the data.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
So with that, let's roll up our sleeves. We're going to do a demo where we use adult census data to predict whether a person is making above $500,000 a year. I'm going to go out on a limb and guess that that is not U.S. money, because that's $500,000 in the U.S. But it's still good money. Then we use cross-validation on our model to see which one is performing better. Who is earning less than $500K? That is the question we're going to ask here. For our demo, we're going to be using Python 3, which you can use in whatever IDE you want. I myself am going to be using Anaconda Notebook, which opens up a nice web page. And from here, we'll just go ahead and create ourselves a new data set, or a new Python scripting page. And we'll start by bringing in our different modules in here. And you'll see in here, let me go ahead and change this to, red's fine. No, we'll go with black. We'll see up here at the top, we have our pandas and numpy. This is your numpy array and your pandas data frame, which we always like to use because they look so nice and easy to use and view. And of course down here, here's our data frame here where we're going to load up our data and take a look at it in just a minute. And then from our sklearn module, which you can see on the next set of lines here, we have our logistic regression model, k-neighbors classifier, and then our cross-val score, stratified fold, k-fold, train test split, and k-fold. And so this is really what we're looking at right here. We're looking at how to validate our different models. And it looks like we're going to be doing this in logistic regression and k-neighbors classifier, so we can have something to compare on there. And then of course, once we have done this, we need to go ahead and have some data. So we'll go ahead and run this. Here's our data set. And this is actually, let's see, we're using pandas, so this is a data frame. And then the first thing we're going to look to see if we have any null values. Always check your data and see what you have coming in. You just never know. And so we can see here with our quick dataset.is null and summit that we have 0 null values in our data set. So we've read our data set in, and the first step in any data is always to take a look at it. So we'll take our data set and we'll go ahead and do .head. Now remember, in Jupyter Notebook, if this was not the only line or the last line of my code on this particular grouping of cells, I'd have to add print around it. Otherwise, it just automatically prints it for us. And we can see here, here's our actual data. And so we have, of course, a nice, the titles up here, age, work class, different information, education, I guess what level of education, marital status, relationship, not in family, race, sex, capital gain, capital loss. And if you remember correctly, I talked a little bit about social minorities. Imagine if you were someplace where the predominant area is all in India, someplace where everybody's is Indian, and there's a small group of people who are what they call expatriates, who came from America and happen to be white. Well, you're going to run into a problem when we did that cross-validation, because if we're looking at this, we might notice that, or in this case, just looking at the first 4 things, we see 3 people who are white, 1 person who's black. This might be a huge discrepancy in our data, and we want to make sure we split that out or take a look at that. We probably won't get into that too much today, but just be aware that this is the kind of thing that you want to start flagging yourself on. And it might be, here we have work class private. I'm not sure what that means. There's a lot of question marks here. That's kind of important to note also. And these are just some of the things I start to look at when I look at this data on here. Native country, United States. So these are people coming from the United States. And here's our 50,000. Now remember, we're looking for 500,000. So the average person here is probably around 50,000. Maybe we'll take a look at that and see what kind of spread we have on our data. But it's a good place to start. And we'll go ahead and do this as a print head 10. The reason I wanted to do that is so we can take just a little closer look at some of the data we're looking at. And if we go up here, let's put a drawing on there. Let's take a note here under sex. We're talking about that. Probably convert that to 0 and 1. And we're going to drop a lot of these columns on here. Maybe we'll also just look at marital status. We might want to convert this to 0 and 1 on here. Some other things that we're not looking at is, of course, race. And this kind of gets interesting because when you look at race, they only show, right now I only show the 2 variations, and we look at how many variations there are. Same thing with male and female. If we label one of these 0 and 1, 1 is not greater than 0. And 0 is not greater than 1. What that means is that this is a yes-no, but as we get more variety, you can't do that. You can't do a yes-no. You have to start splitting that up into multiple columns. And again, it depends on your data and what you find out. You might come in here like we have marital status. We'll actually look a little deeper at marital status. A couple different options in here. One is just to convert this to married or not married. That's a 0, 1. We might split this into columns where widow would be 0, 1, divorce would be 0, 1, separated 0, 1, and so forth. Again, it depends on what kind of data we're looking at and how deep we want to get into it. So let's go ahead and clean up our data a little bit here. Let's start by cleaning up a few columns. And again, we're going to drop a bunch of these because we don't want to spend too much time cooking our data and getting it all set up correctly. We want to have a little bit more time to focus on cross-validation. And you'll see here on this, we have here I was talking about the sex. We're going to convert that to male 0, female 1. And then we'll do the same thing with marriage status. At this point, we're going to create married status. Widow is going to, if you're never married, divorced, separated, widow, it's going to be 0 for single. And then we're going to put this as 1 if you're married. And let's go ahead and convert this into a type integer. So this works really nicely. We'll have 0 and 1 for single or married. And then there's going to be an integer. That way our different models can recognize it. Most models don't recognize text unless you encode it somehow. Just real quick before we start looping through the different models, we got to remember to create our y, which is going to be our income. That's our answer. And then, of course, from the data set, drop the y, because we don't want to use that as part of the processing. And the other thing we want to look at, this is the code for creating our X train, Y train, X test, Y test. So normally, a lot of times you'll see this where we just split the data and we think, okay, good, I've got my test side, I got my Y side, but we're going to go ahead and create a loop so that we can go through this and then take a look at that as far as coming up with the results on there with a cross-validation score. So let's go ahead and run this. Shoop. And whoops, I must have mistyped something. All I need to do is rerun the threads because I'd run it twice, and so it didn't like changing things up when I'd already run it once, and I've already made too many changes on here. So we go ahead and run this, and now we have an X train and a Y train. We're not actually going to do anything with this X train and Y train here. This is just a reminder for what that looks like. But we do need our data set and our Y part of the data set on here. So the next step, and this is the kind of thing I love working with, is we create our models. And you can see where you can start creating really robust packages to compare different models. Again, remember, we're dealing with small data. If you did this across big data, you can run into some major problems. And so we're going to import the two different data models, logistic regression and k-neighbors classifier. And we go ahead and pin these both to models on here. And if we do something like print models, we'll go ahead and run that. You can see that we have a title, which is a string, and then a function, and we can run each of these functions going through our different setup. And then what we really want to do is we want to create a loop for the different models and go through the cross-validation score on the different models. And we'll go ahead and do, I'm going to create a results dictionary. One of my favorite things to do is put everything in dictionaries. And we're going to go for name and model in models. So for each row we have the name LR and then the model is a logistic regression model. And then we'll go ahead and do our k-fold. Right here, this k-fold is the heart of the setup on this. I think the random state is being changed because it threw a warning on there and how that's being done. We'll take a look at that in just a second, the warning. And then we have our splits. We're doing 10 splits on here with our k-fold. And then we have our results. And once we have our results, which is going to be we're going to have a row of 10 pieces of data from each different fold. And so we want to go ahead and do the mean on that. Oops, there we go. Go the arrow the wrong way. And the standard deviation. So how much do they deviate from each other? How low is our error on here? The lower the better. So let's go ahead and run that. And then of course I have on mine, there we go. We see down here is our future warning. It says something about random states. I'm not going to worry too much about that. Warnings come up so often when you're running these different configurations because they're always making changes on here. And so I've got in here my results. Here's my results with the name, and it's going to be the means and the standard deviation on here. Oops, there we go. That way. There's our means and standard deviation. And then I always like to do key value, just because this reminds me very much of doing mapping in larger data. You usually have a key value for your setup. And we'll print the key value, which in this case is the name of the model and the results on here. And we can see down here, here's the two models we ran. Clearly I could add like a ton of these different models, long as they are part of the sklearn setup and they use the same input. There are some models that work slightly differently, so you don't want to use if you're doing classification and then you switch to regression, you run into problems. And of course we're doing regression here, and we can see our results. The KNN did slightly better. It had lower errors, and look at the standard deviation. The standard deviation is also lower. So if I was running this model, I'd be looking at the KNN as my primary model. I would then go rerun this model on all the data to send out for future predictions of stuff we don't know. And you can see right here, it does a nice job at 0.77 versus 0.79, and we'd pick this. You could run this across, like I said, a lot of times there's like about 6-7 different models in there. Some of the models have different settings, so you might go in there and mess with the settings. There's all kinds of ways to go through this. And then you can take your, in this case, cross-validation with, in this case, what we had, 10 folds, and you can get a good idea of what kind of setup or which model is going to work the best, and then compare it, and then you go back through your feedback loop of how to build it and send it out. And of course, from this model, you have somebody new come in, and you find out what their marriage status is, their education, this different information that we put in here. You might find out what their predicted income is. Yeah, it worked pretty good. I definitely wouldn't make it the primary goal with a 0.79 over here error on there, or with this kind of setup on the means, but it would give you a good idea what you're looking at for people coming in if that's what you're trying to evaluate.
PyTorch is a machine learning framework used for image classification and neural network processing. PyTorch is a Python-based open-source machine learning implementation based on the Torch library. It is one of the most popular AI library among industry and academic researchers worldwide. Hey everyone, you're already watching Simplilearn, and in today's video, we're going to be learning all about what is PyTorch. If you love watching videos like this, do hit the subscribe button to never miss any updates from Simplilearn. If you want to become a deep learning expert, consider deep learning with Keras and TensorFlow by Simplilearn and master those necessary skills. Check out the link in the description for more details. Before we get started further, I have one simple question for you guys. Which is an open source machine learning library for Python that is entirely based on Torch? And the options are Tensor, PyTorch, NumPy, or Python. If you know the answer, please leave them in the comment box below. And now, let's get started with the agenda for today's session. First, let's start with what is PyTorch. Following to that, how does PyTorch work? Then, PyTorch features. Moving ahead, let us know PyTorch benefits, and finally, the use cases of PyTorch. So now, let's start with what is PyTorch. PyTorch is a free and open source Python and Torch machine learning implementation. Deep learning models based on neural networks are currently being developed and trained in a variety of deep learning projects using PyTorch. Because of its ease of use, PyTorch is increasingly being used to create artificial neural network models. PyTorch is used by data scientists for artificial intelligence research and applications. Next, we have how does PyTorch work. To write readable code, PyTorch adheres to Python's distinct and unique coding features. It allows developers to run and test the relevant portions of code immediately rather than waiting for the entire program to finish. Furthermore, it eliminates the need for neural network debuggers, machine learning programmers, and deep learning researchers to run the code in real time without having to wait to see if it works or not. Now we know what PyTorch is and it's working. So, moving ahead, let's understand the features of PyTorch. Few mentioned Python features are simple interference, tools and libraries, tensor computation, dynamic graph computation, variables, parameters, modules, and functions. So, let's understand each in detail. So, like Python, PyTorch has a straightforward user interface. It offers a simple way to use the application programming interface API. The PyTorch framework is very simple to use and run. Next, we have tools and libraries. It is possible to expand PyTorch and support development in fields like computer vision and reinforcement learning by using a wide range of tools and libraries. Next, tensor computation. Tensor computation with a robust GPU, graphical processing unit, acceleration support equivalent to NumPy. Next, dynamic graph computation. Dynamic graphs are adaptable and let us examine and change the internals of the graph at any time. The dynamic graph in PyTorch is used. It follows from our declaration of variables that the computational graph is constructed dynamically. So, following each training iterations, the graph is rebuilt. Next, we have variables. For the purpose of holding the gradient, the variables is enclosed outside the tensor. A computational graph's node is represented by it. Next, we have parameters. Parameters encircle variables. They are used when using a parameter as a tensor, which isn't possible when using a variable is required. And next comes module. Stateful computation module serves as their building blocks. In order to simplify and facilitate the creation of complex, multi-layer neural network, PyTorch offers a large library of modules. Next, we have functions. The connections between the two variables are as follows. Functions don't have their memory and don't have any memory to store the state or a buffer. Moving ahead, we have PyTorch benefits. Because its syntax and usage are similar to Python, it makes development simple for Python developers to learn and understand. It has an easy-to-use interface and straightforward Python coding. It includes a large number of libraries and well-known tools that make debugging easier. Then, scalability, strong support on well-known cloud platform, and a small open-source focused communities are all available. Next, let's have a look at the use cases of PyTorch. The PyTorch framework is well known for being convenient and adaptable, with examples of its more typical use cases including reinforcement learning, image classification, and neural language processing. So let's learn each in detail. The development of robotics for automation and using PyTorch in business strategy plan to benefit from reinforcement learning's quick and flexible experimentation capabilities. With powerful GPU acceleration, PyTorch makes tensors and dynamic neural networks available. RL machines are designed to learn from experience to make wise decisions and obtain the best results. Next, we have image classification. PyTorch employs an image classification algorithm that requires developers to categorize an image based on its visual content. A computer vision application, for example, can use an algorithm to determine whether a given image contains an object, such as a car or bicycle. Object detection is simple for the human eye, but difficult for computer vision application. Next is natural language processing. NLP is a technology. The main component of NLP are speech recognition, optical character recognition, machine translation, and information retrieval. Computers can comprehend spoken and written languages with the help of NLP technology.
In this video, we will learn about overfitting and underfitting in machine learning. We have our experienced instructor Richard, who will take us through this video and help us understand the basics of overfitting and underfitting, the reasons why it occurs, and finally we'll look at a demo in Python. Over to Richard now.
What is overfitting? What is underfitting? And those are like the biggest things right now in data science, is overfitting and underfitting. What does that mean? So let's go ahead and talk about overfitting. When we talk about overfitting, it's a scenario where the machine learning model tries to learn from the details along with the noise, and the data tries to fit each data point on the curve. You can see that if you plug in your coordinates, you're just going to get the whatever is fitted every point on the data stream. There's no average. There's no 2 points that might have the, y might have two different answers, because if the wind blows a certain way, and your efficiency of your car, maybe you have a headwind, so your car might alter how efficient it is as it goes, and so there's going to be this variance on here, and this says no, you can't have any variance. It's going to be exactly this. It can't be any. You can't be the same speed or the same car and have a slightly different efficiency. So as the model has very less flexibility, it fails to predict new data points, and thus the model rejects every new data point during the prediction. So you'll get like a really high error on here. And so reasons for overfitting. Data used for training is not cleaned and contains noise, garbage values in it. You can spend so much time cleaning your data, and it's so important. It's so important that if you have some kind of something wrong with the data coming in, it needs to be addressed. Whether it's the source of the data, maybe they use in medical different measuring tools, so you now have to adjust for data that came in from hospital A versus hospital B, or even off of machine A and machine B that's testing something, and those numbers are coming in wrong. The model has a high variance. Again, wind is a good example. I was talking about that with the car. You may have 100 tests, but because the wind's blowing, it's all over the place. Size of training data used is not enough, so a small amount of data is going to also cause this problem. You only have a few points and you try to plot everything. The model is too complex. This comes up a lot. We put too many pieces together, and how they interact can't even be tracked, and so you have to go back, break it up, and find out actually what correlates and what doesn't. So, what is underfitting? A scenario where machine learning models can neither learn the relationship between the data points nor predict or classify a new data point. And you can see here we have our efficiency of our car and our line drawn, and it's just going to be way off for both the training and the predicting data. As the model doesn't fully learn the patterns, it accepts every new data point during the prediction. So instead of looking for a general pattern, we just kind of accept everything. Data used for training is not cleaned and contains noise, garbage, and values. Again, underfitting and overfitting, same issue. You got to clean your data. The model has a high bias. We've seen this in all kinds of things, from the most common is the driving cars to facial identification or whatever it is. The model itself, when they build it, might have a bias towards one thing, and this would be an underfitted model, would have that bias because it's averaged it out. So if you have 5 people from India and 10 people from Africa and 20 people from the US, you've created a bias because it's looking at the 20 people, and you only have a small amount of data to work with. Size of training data used is not enough. That goes with the size I was just talking about. So we have a model with a high bias. We have size of training data used is not enough. The model is too simple. Again, this is one straight line through all the data when it has a slight shift to it for other reasons. So what is a good fit? A linear curve that best fits the data is neither overfitting or underfitting models, but is just right. And of course we have the nice examples here where we have overfitting, lines going up and down, every point's trying to be included. Underfitting, the line really is off from where the data is, and then a good fit is got to get rid of that, minimize that error coming through. So this is all exciting, but what does this look like? So we really need to jump in and put a code together and see what this looks like when we're programming. For this demo, we'll bring up our trusty Anaconda and go into Jupyter Notebook for Python. Move myself out of the way here. And so we're going to start off. This is going to be a demo on overfitting and underfitting using Python. And let's start with our imports. Now, if you've been through enough of these tutorials, we don't want to spend a huge amount of time on what we're bringing in and what we're doing. So you should be up on doing this with Python and how to bring in your different modules. We're going to bring in the sklearn, or the sci-ket processing, sklearn.neural network, import MLP regressor. So there's our regressor model right there. That's going to be our linear regression model. And we have our metrics, mean, absolute error. If you remember, we had our, that's how we figure out how well it fits, is how far off that error is based on the mean square error value, MSE. And then, of course, NumPy, because we just like to work with NumPy. It's a great data array. We always import it as MP. That's the most common way of doing it. And then we have sklearn model selection, import validation curve. So we're going to look at a validation curve to see how good our models are. And then we have the data set. We'll use the very famous iris data set, and that's embedded in the sci-ket. So the sklearn data sets have a load iris in there. And then we have the matplot library, because if you're doing any kind of demo or showing this off to your shareholders, we want to have something nice to display it on. And then we have sklearn model selection. We're going to import kfold. And we'll talk about that when we get to it. And then we're going to go ahead and do, just for our NumPy, we're going to do like a random seed for random numbers. And then for our plot style, we'll use the ggplot. That's just some back-end setup. You could even probably leave the plot style out, depending on what version of you're using of, depending on what version you're using of matplot library. And then we'll go ahead and run this. It's not going to do anything that we can visibly see, because it's just loading those modules. And then we also want to load our iris data in here. And the iris data has an iris data and an iris target. We're going to load that as X and Y. And just so you can have an idea what we're talking about, we're going to go ahead and print X. And just the first bit of X, we'll just do the top of X. And we'll also print Y, so you can see what the top of Y looks like. Print Y. And since we're in NumPy, we're going to go ahead and do our own thing. If this was, of course, pandas, we could just do the head of it and see what it looks like. And you can see here we've loaded this up, and in X we have these different measurements that they take of the flower, the iris flowers from this particular data set, and what kind of flower it is. It's going to be a 0, a 1, or a 2 is actually what the target comes out of, even though that doesn't show in here. And so we're going to come in here and we're going to use the kfolds cross validation with 20 folds. And a good catch that this was a model selection. We're going through and we're selecting different parts of the data in here. Here we use kfolds cross validation with 20 folds, k equals 20, to evaluate the generalization efficiency of the model. Within each fold, we will then estimate the training and test error using the training and test sets respectively. So here we have our kf equals kfold. Here's our splits on the top. And then we need to go ahead and have our list training error. We're going to create an array for that. We're going to list our testing error. And for train index and test index in kf.splitx, xtrain and xtest, we're going to go ahead and split up our data, our x values, and the same thing with the y values. So now we have an xtrain and an xtest, a ytrain and a ytest. And then here's our model, our MLP regressor. And that's your linear regressor model in there. And we have used a multi-layer perceptron, MLP. So this is a neural network, multi-layer perceptron. That's what the MLP is for. Regressor means that it is dealing with numbers. We're not categorizing things. And then let's go ahead, kind of went off the screen here. We'll just go ahead and bring that down. It's a class of feed-forward artificial neural networks. And they kind of loosely call it ANN. Don't get caught up in the ANN, NNN, MNN. There's NN is neural network, and then everybody puts their own flavor on it depending on what they're doing. So if you see the NN, you know you're dealing with a neural network. So we go ahead and fit our data. Here's our model.fit. We have X-train and Y-train. And the Y-train data we're going to predict equals model.predict X-train. So here's our prediction of what it's going to be. So we've trained it and we predicted it. We've trained the train data, and then we have our Y-train. And then we have our Y-test. And the Y-test equals a model predict X-test. Now notice what we did here is we're going to use our model to predict what we think Y should be, but this is the training set. So we've trained it with this data, and now we want to see how good our model fits our training data. And then we want to see how well it fits our testing data. So we take our fold training error, mean absolute error, Y-train data predict, and we're going to do our fold testing error, the mean absolute error of Y-test and Y-test data predict. And we do this, and here's our mean absolute error. There's our a little bit different connotation, but that's taking the square value and finding in this case it's using the absolute value. So instead of the square value, we get rid of the minus and pluses by using an absolute value. And we find the average of that. And that works the same way as doing the squared value. And then we take our list training error, and we're going to go ahead and just append it for each one of these runs we go through. So every time we fold the data, think of it like this. We want to go ahead and take a piece of data. That's going to be one piece of the data, and we're going to look at each section. And we want to go through each section to see how well it does and splits it up. This way we have a nice picture when we're looking at it from a distance. I do this a lot when I do when I split my X train and my Y train. I'll take 2/3 of the data and then 1/3 of the data, and then I'll switch it and I'll do 3 different models so I can really see how well it tests out and how that averages out. This is the same thing, but with the K-fold we're doing, and we're doing it across 20 sections. We'll go ahead and run this. And when we run this, it's not too exciting because we're just loading up the data and appending it into our list. And so what we want to take with this is we're going to go ahead and plot it. And this is where we can really see what's going on. This is where it gets exciting. So we take it and we're going to create a couple subplots. That way we have a nice setup down here. We're splitting it up into a couple different graphs. And let's go ahead and run this, and then we'll walk through it a little bit. So our subplot comes in. There's our subplot, and then our PLT plot we're going to do in there. Range 1, we're going to go ahead and do the splits +1, NP array, list training error, ravel it. This is, of course, just a code to how we properly set it up on there so that it sees it correctly. And then we have our X label, which is our number fold. Plot the Y label training error. Plot the title, training error across folds, plot the tight layout, plot the subplot. So we're going to move on to, this is 1, 2, 1, 1, 2, 2. There's our just 1 and 2. It has to do with how it layers it on there for doing multiple plots, because you can do all kinds of cool things with our PyPlot library. And again, we're going to go ahead and do the same thing for the error. And we end up with our training error across folds and our testing error across folds. And so you can see these different folds, how they kind of spike and how they look. And so when we're talking about overfitting or underfitting, we're comparing these two graphs. And if one of them is more off than the other one, if you're looking at these two graphs, you got to say, hey, is this one overfit or underfit? And this is always a good question to ask. I mean, what do we got going here? Is that overfit or is that underfit? And I would say, based on these two graphs and the training data is more sporadic than the testing data. So I would look at this and say, hey, this might need to be fit a little bit better. Maybe we don't have enough data. With the iris, we probably don't. something else is going on here. So it's a little underfit. Maybe a different model would fit better. I would not use a neural network model for this. I would actually use just a basic linear model on this. A lot of different choices. But this gives you an idea. What we're looking at is how chaotic are these two. Is it getting better or is it getting worse? If at some point the training data gets so much better than the testing data, you know you've overfit it. And that's where you start running into the overfitting. This to me looks like it's underfit. So that concludes underfitting and overfitting.
There's no better time to train yourself in the exciting field of machine learning. If you're looking for a course that covers everything from the fundamentals to advanced techniques, for that, accelerate your career in AI and ML with our comprehensive postgraduate program in AI and machine learning. Gain expertise in machine learning, deep learning, NLP, computer vision, and reinforcement learning. You will receive a prestigious certificate, exclusive alumni membership, and Ask Me Anything sessions by IBM with 3 capstone projects and 25 plus industry projects using real datasets from Twitter, Uber, and more. You will gain practical experience. Master classes by Caltech faculty and IBM experts ensure top-notch education. Simplilearn's Job Assist helps you notice by leading companies. This program covers statistics, Python, supervised and unsupervised learning, NLP, neural networks, computer vision, GANs, Keras, TensorFlow, and many more skills. Enroll now and unlock exciting AI and ML opportunities. The course link is mentioned in the description box below.
In this lesson, you are going to understand the concept of text mining. By the end of this lesson, you will be able to explain text mining, execute text processing tasks. So let's go ahead and understand text mining in detail. Let's first understand what text mining is. Text mining is the technique of exploring large amounts of unstructured text data and analyzing it in order to extract patterns from the text data. It is aided by software that can identify concepts, patterns, topics, keywords, and other attributes in the data. It utilizes computational techniques to extract and summarize the high-quality information from unstructured textual resources. Let's understand the flow of text mining. There are 5 techniques used in text mining system. Information extraction or text pre-processing. This is used to examine the unstructured text by searching out the important words and finding the relationships between them. Categorization or text transformation attribute generation. Categorization technique labels the text document under one or more categories. Classification of text data is done based on input-output examples with categorization. Clustering or attribute selection. Clustering method is used to group text documents that have similar content. Clusters are the partitions, and each cluster will have a number of documents with similar content. Clustering makes sure that no document will be omitted from the search, and it derives all the documents that have similar content. Visualization technique. The process of finding relevant information is simplified by visualization technique. This technique uses text flags to represent a group of documents or a single document, and compactness is indicated using colors. Visualization technique helps to display textual information in a more attractive way. Summarization or interpretation or evaluation. Summarization technique will help to reduce the length of the document and summarize the details of the documents. It makes the document easy to read for users and understand the content at the moment. Let's understand the significance of text mining. Document clustering. Document clustering is an important part of text mining. It has many applications in knowledge management and information retrieval. Clustering makes it easy to group similar documents into meaningful groups, such as in newspapers where sections are often grouped as business, sports, politics, and so on. Pattern identification. Text mining is the process of automatically searching large amount of text for text patterns and recognition of features. Features such as telephone numbers and email addresses can be extracted using pattern matches. Product insights. Text mining helps to extract large amounts of text, for example, customer reviews about the products. Mining consumer reviews can reveal insights like most loved feature, most hated feature, improvements required, and reviews of competitors' products. Security monitoring. Text mining helps in monitoring and extracting information from news articles and reports for national security purposes. Text mining makes sure to use all of your available information. It is a more effective and productive knowledge discovery that allows you to make better informed decisions, automate information-intensive processes, gather business-critical insights, and mitigate operational risk. Let's look at the applications of text mining. Speech recognition. Speech recognition is the recognition and translation of spoken language into text and vice versa. Speech often provides valuable information about the topics, subjects, and concepts of multimedia content. Information extraction from speech is less complicated, yet more accurate and precise than multimedia content. This fact motivates content-based speech analysis for multimedia data mining and retrieval, where audio and speech processing is a key enabling technology. Spam filtering. Spam detection is an important method in which textual information contained in an email is extracted and used for discrimination. Text mining is useful in automatic detection of spam emails based on the filtering content. Using text mining, an email service provider such as Gmail or Yahoo Mail checks the content of an email, and if some malicious text is found in the mail, then that email is marked as spam and sent to the spam folder. Sentiment analysis. It is done in order to determine if a given sentence expresses positive, neutral, or negative sentiments. Sentiment analysis is one of the most popular applications of text analytics. The primary aspect of sentiment analysis includes data analysis of the body of the text for understanding the opinion expressed by it and other key factors comprising modality and mood. Usually, the process of sentiment analysis works best on text that has a subjective context than on that with only an objective context. E-commerce personalization. Text mining is used to suggest products that fit into a user's profile. Text mining is increasingly being used by e-commerce retailers to learn more about the consumers, as it is the process of analyzing textual information in order to identify patterns and gain insights. E-commerce retailers can target specific individuals or segments with personalized offers and discounts to boost sales and increase customer loyalty by identifying customer purchase patterns and opinions on particular products. Let's look at Natural Language Toolkit library in detail. Natural Language Toolkit is a set of open-source Python models that are used to apply statistical natural language processing on human language data. Let's see how you can do environment setup of NLTK. Go to Windows Start and launch Python Interpreter from Anaconda prompt and enter the following commands. Enter command Python to check the version of Python installed on your system. Enter import NLTK to link you to the NLTK library available to download. Then enter nltk.download function that will open the NLTK download window. Check the download directory, select all packages, and click on Download. This will download NLTK onto your Python. Once you have downloaded the NLTK, you must check the working and functionality of it. In order to test the setup, enter the following command in Python idle. From nltk.corpus import brown, brown.word parenthesis parenthesis. The brown is an NLTK corpus that shows the systematic difference between different genres available. Words function will give you the list available words in the genre. The given output shows that we have successfully tested the NLTK installed on Python. Let's now understand how you can read a specific module from NLTK corpora. If you want to import an entire module from NLTK corpora, use asterisk symbol with that module name import command. Enter the command from nltk.book_import asterisk. It will load all the items available in NLTK's book module. Now, in order to explore brown corpus, enter the command nltk.corpus import brown. This will import brown corpus on the Python. Enter brown.categories function to load the different genres available. Select a genre and assign that genre to a variable using the following syntax. Variable name is equal to brown.words. Categories is equal to genre name. Now, in order to see the available words inside the selected genre, just enter the defined variable name as a command. Let's understand text extraction and pre-processing in detail. So let's first understand the concept of tokenization. Tokenization is the process of removing sensitive data and placing unique symbols of identification in that place in order to retain all the essential information concerned with the data by its security. It is a process of breaking running streams of text into words and sentences. It works by segregating words using punctuation and spaces. Text extraction and pre-processing n-grams. Now let's look at what n-gram is and how it is helpful in text mining. N-gram is the simplest model that assigns these probabilities to sequences of words or sentences. N-grams are combinations of adjacent words or letters of length n in the source text. So n-gram is very helpful in text mining when it is required to extract patterns from the text. As in the given example, this is a sentence. All of these words are considered individual words and thus represent unigrams. A 2-gram or bigram is a two-word sequence of words like this is a, or a sentence, and a 3-gram or trigram is a three-word sequence of words like this is a, or is a sentence. Let's now understand what stop words are and how you can remove them. Stop words are natural language words that have negligible meaning, such as a, an, and, or, the, and other similar words. These words also will take up space in the database or increase the processing time, so it is better to remove such words by storing a list of stop words. You can find the list of stop words in the NLTK data directory that is stored in 16 different languages. Use the following command to list the stop words of English language defined in NLTK corpus. Importing NLTK will import the NLTK corpus for that instance. Enter from nltk.corpus import. Stop words will import stop words from NLTK corpus. Now set the language as English, so use set function as set under braces stopwords.words. Set genre as English. Stop words are filtered out before processing of natural language data, as they don't reveal much information. So as you can see in the given example, before filtering the sentence, the tokenization of stop word is processed in order to remove these stop words, and the filtering is applied in order to filter the sentence based on some criteria. Text extraction and pre-processing stemming. Stemming is used to reduce a word to stem or base word by removing suffixes such as helps, helping, helped, and helper to the root word help. The stemming process or algorithm is generally called a stemmer. There are various stemming algorithms such as Porter stemmer, Lancaster stemmer, Snowball stemmer, etc. Use any of the stemmers defined under NLTK stem corpus in order to perform stemming as shown in the example. Here we have used Porter stemmer. When you observe the output, you will see that all of the words given have been reduced to their root word or stem. Text extraction and pre-processing lemmatization. Lemmatization is the method of grouping the various inflected types of a word in order that they can be analyzed as one item. It uses vocabulary list or morphological analysis to get the root word. It uses WordNet database that has English words linked together by their semantic relationship. As you can observe, the given example, the different words have been extracted to their relevant morphological word using lemmatization. Text extraction and pre-processing POS tagging. Let's now look at different part-of-speech tags available in the National Language Toolkit library. A POS tag is a special label assigned to each token or word in a text corpus to indicate the part of speech and often also other grammatical categories such as tense, number, either plural or singular, case, etc. POS tags are used in text analysis tools and algorithms and also in corpus searches. So look at the given example. Here, Alice wrote a program is the source text given. The POS tags given are Alice is a noun, wrote is a verb, a is an article, and program is an adjective. Look at the given example to understand how POS tags are defined. So the given sentence or paragraph contains different words that represent different parts of speech. We will first use tokenization and removal of stop words, and then allocate the different POS tags. These are shown with different words in the given sentence. POS tags are useful for lemmatization in building named entity recognition and extracting relationships between words. Text extraction and pre-processing named entity recognition. Now let's understand what named entity recognition is all about. NER seeks to extract a real-world entity from the text and sorts it into predefined categories, such as names of people, organizations, locations, etc. Many real-world questions can be answered with the help of name entity recognition. Were specified products mentioned in complaints or reviews? Does the tweet contain the name of a person? Does the tweet contain the person's address? As you can see in the given example, Google, America, Larry, Page, etc. are the names of a person, place, or an organization. So these are considered named entities and have different tags such as person, organization, GPE or geopolitical entity, etc. NLP process workflow. Now you have an understanding of all NLTK tools. So now let's understand the natural language processing workflow. Step 1, tokenization. It splits text into pieces, tokens, or words and removes punctuation. Step 2, stop word removal. It removes commonly used words such as the, is, are, etc., which are not relevant to the analysis. Step 3, stemming and lemmatization. It reduces words to base form in order to be analyzed as a single item. Step 4, POS tagging. It tags words to be part of speech such as noun, verb, adjective, etc., based on the definition and context. Step 5, information retrieval. It extracts relevant information from the source. Demo 1, Brown Corpus. Problem statement. The Brown University Standard Corpus of Present-Day American English, also known popularly as Brown Corpus, was compiled in the 1960s as a general corpus in the field of corpus linguistics. It contains 500 samples of English language text, totaling roughly 1 million words, compiled from works published in the United States in 1961. We will be working on one of the subset dataset and perform text processing tasks. Let us import the NLTK library and read the CA_10 corpus. Import NLTK. We will have to make sure that there are no slashes in between. Hence, we will use the replace function within pandas for the same. Let's have a look at the data once. Tokenization. After performing sentence tokenization on the data we obtain, similarly, after applying sentence tokenizer, the resulting output shows all individual words, tokens. Stop word removal. let's import the stop word library. From nltk.corpus import stop words. We also need to ensure that the text is in the same case. NLTK has its own list of stop words. We can check the list of stop words using stopwords.words and English inside the parenthesis. Map the lowercase string with our list of word tokens. Let's remove the stop words using the English stop words list in NLTK. We will be using set checking as it is faster in Python than a list. By removing all stop words from the text, we obtain Often we want to remove the punctuations from the documents too. Since Python comes with batteries included, we have string.punctuation. From string, import punctuation. Combining the punctuation with the stop words from NLTK. Removing stop words with punctuation. Stemming and lemmatization. We will be using stemming and lemmatization to reduce words to their root form. For example, walks, walking, walked will be reduced to their root word walk. Importing Porter Stemmer as the stemming library. From nltk.stem, import Porter Stemmer. Printing the stem words. Import the WordNet lemmatizer from nltk.stem. Printing the root words. We also need to evaluate the POS tags for each token. Create a new word list and store the list of word tokens against each of the sentence tokens in Data 2. For I in tokenized, also, we will check if there were any stop words in the recently created word list. We will now tag the word tokens accordingly using the POS tags and print the tagged output. For our final text processing task, we will be applying named entity recognition to classify named entities in text into predefined categories such as the names of persons, organizations, locations, expressions of times, quantities, monetary values, percentages, etc. Now press the tagged sentences under the chunk parser. If we set the parameter binary equals true, then named entities are just tagged as NE. Otherwise, the classifier adds category labels such as person, organization, and GPE. Create a function named as extract entity names along with an empty list named as entity names. We will now extract named entities from a NLTK chunked expression and store them in the empty created above. Again, we will set the entity names list as an empty list and will extract the entity names by iterating over each tree in chunked sentences. Great, we have seen how to explore and examine the corpus using text processing techniques. Let's quickly recap the steps we've covered so far. 1. Import the NLTK library. 2. Perform tokenization. 3. Perform stemming and lemmatization. 4. Remove stop words. 5. Perform named entity recognition. Structuring sentences, syntax. Let's first understand what syntax is. Syntax is the grammatical structure of sentences. In the given example, this can be interpreted as syntax, and it is similar to the ones you use while writing codes. Knowing a language includes the power to construct phrases and sentences out of morphemes and words. The part of the grammar that represents a speaker's knowledge of these structures and their formation is called syntax. Phrase structure rules are rules that determine what goes into a phrase, that is, constituents of a phrase and how the constituents are ordered. Constituent is a word or group of words that operate as a unit and can be used to frame larger grammatical units. The given diagram represents that a noun phrase is determined when a noun is combined with a determiner, and the determiner can be optional. A sentence is determined when a noun phrase is combined with a verb phrase. A verb phrase is determined when a verb is combined optionally with the noun phrase and prepositional phrase. And a prepositional phrase is determined when a preposition is combined with a noun phrase. A tree is a representation of syntactic structure of formulation of sentences or strings. Consider the given sentence. The factory employs 12.8% of Bradford County. What can be the syntax for pairing this statement? Let's understand this. A tree is produced that might help you understand that the subject of the sentence is the factory. The predicate is employs, and the target is 12.8%, which in turn is modified by Bradford County. Syntax parses are often a first step toward deep information extraction or semantic understanding of text. Rendering syntax trees. Download the corresponding .exe file to install the Ghost script rendering engine based on your system configuration in order to render syntax trees in your notebook. Let's understand how you can set up the environment variable. Once you have downloaded and installed the file, go to the folder where it is installed and copy the path of the file. Now go to System Properties, and under Advanced Properties, you will find the Environment Variable button. Click on that to open the pop-up box tab of the environment. Now open the bin folder and add the path to the bin folder in your environment variables. Now you will have to modify the path of the environment variable. Use the given code to test the working of syntax tree after the setup is successfully installed. Structuring sentences, chunking and chunk parsing. The process of extraction of phrases from unstructured text is called chunking. Instead of using just simple tokens which may not represent the actual meaning of the text, it is advisable to use phrases such as Indian team as a single word instead of Indian and team as separate words. The chunking segmentation refers to identifying tokens, and labeling refers to identifying the correct tag. These chunks correspond to mixed patterns in some way. To extract patterns from chunks, we need chunk parsing. The chunk parsing segment refers to identifying strings of tokens, and labeling refers to identifying the correct chunk type. Let's look at the given example. You can see here that yellow is an adjective, dog is a noun, and the is the determiner, which are chunked together into a noun phrase. Similarly, chunk parsing is used to extract patterns and to process such patterns from multiple chunks while using different parsers. Let's take an example and try to understand how chunking is performed in Python. Let's consider the sentence, "The little mouse ate the fresh cheese," assigned to a variable named cent. Using the word tokenize function under NLTK corpora, you can find out the different tags associated with the sentence provided. So as you can see in the output, different tags have been allocated against each of the words from the given sentence using chunking. NP chunk and parser. You will now create grammar from a noun phrase and will mention the tags you want in your chunk phrase within the function. Here you have created a regular expression matching the string. The given regular expression indicates optional determiner followed by optional number of adjective followed by a noun. You will now have to parse the chunk. Therefore, you will create a chunk parser and pass your noun phrase string to it. The parser is now ready. You will use the parse parenthesis within your chunk parser to parse your sentence. The sentence provided is, "The little mouse ate the fresh cheese." This sentence has been parsed and the tokens that match the regular expressions are chunked together into noun phrases, NP. Create a verb phrase chunk using regular expressions. The regular expression has been defined as optional personal pronoun followed by 0 or more verbs with any of its type followed by any type of adverb. You'll now create another chunk parser and pass the verb phrase string to it. Create another sentence and tokenize it. Add POS tags to it. So the new sentence is, "She is walking quickly to the mall," and the POS tag has been allocated from NLTK corpora. Now use the new verb phrase parser to parse the tokens and run the results. You can look at the given tree diagram, which shows a verb parser where a pronoun followed by two verbs and an adverb are chunked together into a verb parse. Structuring sentences, chinking. Chinking is the process of removing a sequence of tokens from a chunk. How does chunking work? The whole chunk is removed when the sequence of tokens spans an entire chunk. If the sequence is at the start or the end of the chunk, the tokens are removed from the start and end, and a smaller chunk is retained. If the sequence of tokens appears in the middle of the chunk, these tokens are removed, leaving two chunks where there was only one before. Consider you create a chinking grammar string containing three things: chunk name, the regular expression sequence of a chunk, the regular expression sequence of your chink. Here in the given code, we have the chunk regular expression as optional personal pronoun, followed by 0 or more occurrences of any type of the verb type followed by 0 or more occurrences of any of the adverb types. The chink regular expression says that it needs to check for the adverb in the extracted chunk and remove it from the chunk. Inside the chinking block with open curly braces and closing curly braces, you have created one or more adverbs. You will now create a parser from nltk.regexp parser and pass the chink grammar to it. Now use the new chink parser to parse the tokens cent3 and run the results. As you can see, the parse tree is generated. While comparing the syntax tree of the chink parser with that of the original chunk, you can see that the token is quickly, adverb, chinked out of the chunk. Let's understand how to use context-free grammar. A context-free grammar is a four-tuple sum NTRS where sum is an alphabet and each character in sum is called a terminal. NT is a set and each element in NT is called a non-terminal. R, the set of rules, is a subset of NT times the set of sum UNT. S, the start symbol, is one of the symbols in NT. A context-free grammar generates a language L capturing constituency and ordering. In CFG, the start symbol is used to derive the string. You can derive the string by repeatedly replacing a non-terminal on the right-hand side of the production until all non-terminals have been replaced by terminal symbols. Let's understand the representation of context-free grammar through an example in context-free grammar. A sentence can be represented as a noun phrase followed by a verb phrase. Noun phrase can be a determiner, nominal. A nominal can be a noun. VP represents the verb phrase. A can be called a determiner. Flight can be called a noun. Consider the string below where you have certain rules. When you look at the given context-free grammar, a sentence should have a noun phrase followed by a verb phrase. A verb phrase is a verb followed by a noun. A verb can either be saw or met. Noun phrases can either be John or Jim, and a noun can either be a dog or a cat. Check the possible list of sentences that can be generated using the rules. Use the join function to create the possible list of sentences. You can check the different rules of grammar for sentence formation using the production function. It will show you the different tags used and the defined context-free grammar for the given sentence. Demo 2, Structuring Sentences. Problem statement. A company wants to perform text analysis for one of its data sets. You are provided with this data set named tweets.csv, which has tweets of 6 U.S. airlines along with their sentiments, positive, negative, and neutral. The tweets are present in the text column and sentiments in airline_sentiment column. We will be retrieving all tags starting with @ in the dataset and save the output in a file called references.txt. Let us first import the pandas library and read the tweets dataset. Extract the features, text, and airline sentiment. We will iterate through the dataset using regx. Find the relevant tweets. Now we will import the itertools module. It returns efficient iterators. The result is stored in a file named references.txt. Let's extract all noun phrases and save them in a file named noun phrases for left caret airline underscore sentiment right caret review.txt. Here, left caret airline underscore sentiment right caret has 3 different values, positive, negative, and neutral, so 3 files will be created. Now we will iterate all the leaf nodes and assign them to noun phrases variable. This means that the functions in itertools operate on iterators to produce more complex iterators. Using the map function, we will get all the noun phrases from the text. Putting it into list. Creating a file name in the name of review.txt. Great, we have now seen how to explore and examine the corpus using text processing techniques.
Christopher Himmel. I am going to talk this evening about neural networks. I want to give an introduction and also talk about the basic structure of neural networks. So let's do it. So this is a basic agenda for what we're going to talk about. We're going to first go through the biological motivation behind artificial neural networks. We're talking about neurons and what they're made of. Then we're going to do a mathematical approximation of exactly what we started with, which was that biological breakdown. And then we're going to show this simple perceptron, which was the first time the neuron was modeled, many decades ago, at least half a century ago, and then we're going to build it up from there. We're going to start with a simple neuron, the perceptron, and then we're going to show how that is actually logistic regression when we start to put multiple points together. It could be just one neuron, but multiple inputs. And we're going to show how when we make a more complex neural network, then we can represent this in mathematics with matrices with some linear regression. And also show one part of the neuron, the activation function. We're going to show all the math behind that. So, and then at the very end, we're going to build a neural network from scratch. Start with a single neuron, then we'll make it a layer of neurons, and then we're going to make it multiple layers, which actually is a deep neural network. So that's what we're going to do tonight. So let's start with the neuron structure. Biological, what does a neuron actually look like? And very shortly, you'll understand why I'm showing you this. But yeah, so there's really 4 major parts to a neuron. Neuron is a cell in the brain, in the nervous system. It's what makes us really smart, is all these neurons. So let's look at the smallest fundamental piece of a neural network of the brain is a neuron. Neuron consists of the cell body, which you can see here. And it basically sends a pulse out. If it gets enough input, it sends a pulse out. So we're going to do that in math shortly. So where does it send a pulse out to? It sends it out through this axon, which this axon is actually where the learning happens. The stronger this axon is, the more of that pulse makes it out of the neuron, out into this area, which then goes through these synapses. And you have to imagine, okay, for a second, another neuron over here. There's other neurons that these synapses are connected to. So they activate the next neuron. And how do they activate it? They activate it through dendrites, which these dendrites are activated from another neuron at this end. You have to imagine more neurons that are sending out their pulse and coming in through, the pulse is going through the axon to the synapse and then into the next neuron through the dendrites. Okay, so that was basically how a neuron looks. Now let's take the same pieces, the cell body, the axon, the synapse, and the dendrite, and let's look at how mathematically we would represent that. So the axon is coming from other neurons, and the axon is we're going to represent that pulse coming from the other neuron as an X. That's the variable that is, how much pulse is coming from the previous neuron. And it's passing through a synapse. Okay, so the synapse is represented by this W, or weight. It says how much of this pulse makes it through to the next neuron. It's the strength of that axon, the previous neuron firing, going through to the next neuron. And how does it get into the next neuron? It gets into the next neuron through dendrites. So if we multiply those two together, so our synapse is controlling how much by multiplication gets through to the dendrite. And this is when you multiply it together, this is showing going into the next neuron, the cell body. And we have multiple of those dendrites coming from different synapses, from different axons, going into the cell body. And in the cell body, it's just adding up all these inputs. Okay, that's what this summation is. It's adding them all up. Miss Bayes, don't worry about it for now. That's a mathematical construct to make sure that if all of your inputs are off, okay, you still have something coming in. This B makes it so that you don't have 0 coming in. And then once you add up all of these and the bias, the B, then it goes through this function, and this is going to be the activation function, which we're going to show all of those. So we're passing this summation through, we're taking the function f of that, and then that's going to be your next output, which will become your x to the next neuron. That's the axon. So here we go. So the output, if we write what this value ends up being, it's a f of whatever's in here, which remember, this is the sum of all of those inputs. F of all of that, that's what goes into the output, which goes to the next neuron, goes to the next axon, I should say. That's an axon. All right, so really what I did, I just showed you a perceptron. Now we're going to show you that math that I just showed you in a little bit different flavor, which is more the flavor of how neurons were developed, decades ago. We have all those inputs, all the X's, and a bias. Okay, we have all the W's. We just showed all the W's. Those are weights. Those are strengths or the synapse. Then we have the summation and the activation in the cell body, and the output being an axon. So it's really the same thing we just did, drawn a little bit differently. Here we have all the inputs. And I'm showing this over and over again so that you get into your head, what this neuron looks like mathematically. And you should be able to recognize how this looks, just like that, the biological part of it. So you have the inputs and the bias, and we have all these weights, okay, multiply by the X's, sum them all together, and then pass through an activation function. And we'll talk more about the activation function shortly. Okay, so that was converting that biological piece to the mathematical one neuron. Now let's write more math about this, a little bit more, and show how, another picture of what our neuron could look like. This is just one neuron, just like we had before. Here it's G instead of F. Okay, we have all these thetas, which are multiplied by the X's, all your inputs. And if we just write it this way, instead of the thetas, we write W's times all the X's. And then take this summation and just pass it through a function, a G. That's our activation function. If you've done any modeling at all, statistical modeling, basic, data science, machine learning, you'll recognize that this is logistic regression. So our, one neuron is exactly the same as our logistic regression equation, passing through. We have all these inputs and we have one output. The output is, again, the activation function. Here is an activation function. Okay, it's a sample one. Happens to be the most popular one, but it's only one, where we apply that activation function to the summation of all of our weighted inputs. Okay, you'll hear that a lot, weighted inputs in neural network talk. Okay. And something else about logistic regression, if you remember, your feature importance is something in linear and logistic regression is all these weights. It says how important is each one of these inputs, how much of them, when you multiply, are getting passed through. And then our logistic regression is actual activation function. Okay, so I just showed you one neuron. Let's make this more complicated. Instead of one neuron, let's have three, A1, A2, and A3. These are not neurons. Okay, if we go back with this picture, these four things are not inputs. Remember, they're just values coming in. They're values coming out of the previous layer, if we have a previous layer. But that's your input to these. And we've got three neurons instead of one. So instead of having just one neuron and then four inputs and then four weights, we now have 4 times 3 or 12 weights. So if we want to write that same function that we wrote before with a matrix, with linear algebra, if we want to write it out, we would write it like this, where see these blue lines are for the blue weights, the green lines are for the green weights, and then the orange are for the orange weights for this third one. So we take those, write it like this with a matrix, write this inputs as a matrix, and then we add that bias term, one bias for each neuron. We would get something like this, when we multiply it out. Anybody that's done any linear algebra, you know, when you multiply matrices together, it ends up looking like this. So you take this right here. This will be 3 values, once you add these together, and pass it through the activation function. You now have the output of the neurons. So this is the way, when you have more than one neuron, it has to be, it's going to be more complicated. The math is getting more complicated, the algebra. So you write it in linear algebra terms, matrice multiplication. And then we say this is our weight, our W. This is our X matrix. This is our bias matrix. And here, through activation, we get our output. And this is how you'd write it as a function. F of Wx plus B equals A. And then sometimes you write this as Y, because Y is an output. But in this case, we wrote it as A. Okay, so that activation function. When we talked about the biological part of this, okay, we said that the neuron turns on if it gets enough input. So what we're showing here is if we have enough input, so that's on the input. Input is along the x-axis, and the output is the y-axis. If we have enough input, then our output goes high, goes all the way on. Our input, if we don't have enough input, if we add up all of our inputs, weighted sum inputs, then we have not enough, and we have a 0 coming on the output. The neuron is not activated. And this is just the way you would write that mathematically. F of x equals 0 for anything where our input, our x is less than 0, and 1 for anything where we have enough input. This is the binary step activation function. And something you need down the road, and in the next lecture, we're going to talk about how we have our neural network learn. We need to take the derivative of this activation function. So this is how the derivative would look like. Derivative is a slope for x not equal 0. We have a slope of 0 for x. When it's at 0, it's a vertical line, which means an infinite slope. So that's why we have a question mark. Don't worry about the derivative tonight. Just be aware that that's the case. All right, so another activation function is this logistic / sigmoid, which is, I showed you that here before, 1 over 1 plus e to the minus x. And that's what it ends up looking like. Your input being negative gives you a small input. And the bigger your input is, the higher, or the closer to 1 it gets. It converges onto 1. And here, right in the middle, right where x equals 0, we have a 0.5, right at half. When we take the derivative, we get this. We have no question mark. We have no vertical line here, so we can take the derivative of this curve. That's why this one's preferable to the step, actually, because of that, because we can take the derivative. Another very popular activation function, where you remember the activation function is what we're passing our weighted input, weighted sum through. Another one is this RLU, rectified linear unit, which means that if we have a negative x, okay, negative input, then we get 0. Our neuron is not activated. If we have a positive output, then we just get whatever that is on the output. Y equals x. F of x equals x for x greater than or equal to 0, or 0 if it's less than 0. And for this, the derivative is 0 for when it's less than 0, and it's actually 1 if it's greater than or equal to 0. Greater than 0. At 0, it's undefined. And that's the problem with this one, is it doesn't have a smooth derivative. Okay, so these different activation functions are just part of how the neuron works. It's what output, it's what turns on or off the neuron. All right, so now we're going to build up our neural network. This is we went through the basis of, okay, where did the neural network come from, to what is the mathematical part of it. Now we're going to start stitching them all together, all those pieces we just built. We're going to start with the basic neuron that we started with, one neuron, okay? And this is called a 4x1 neural network, which means 4 inputs, 1 output. So one neuron with 4 inputs. And we call this a layer, okay, the inputs, even though it's not neurons, it's just a layer of inputs. And then we have our output layer. So this is one layer and one neuron. Everything that we've been showing up to now, it looks like this. So let's make it a little more complicated. Now we're going to add some neurons in the middle. Okay. Originally we had an output and 3 inputs. Now we're going to stick these ones in the middle. Okay. And then have our inputs feed that middle layer. Okay. And our middle layer is going to feed our output. So now we have like this buffer in between. And this is called a 4x3x1 neural network. So that means 4 inputs, 3 in the hidden layer. This middle layer is called the hidden layer because the output can't see it. People can't see it because it's buffered, by the input or the output. So it's hidden. So how many neurons do we have? We still have 4 inputs, but now we have 3 more neurons plus the 1 output neuron. So this is 4 neurons. Basic 4 neuron, 2 layer neural network. And once you go to this level, okay, you've gone from a basic one-layer neural network to deep learning. Okay, that's all deep learning means, is more than one layer. And what this means is you can represent a much more complex model with this, because what we're doing is we're taking an input and coming up with an output. So we're modeling a system. And we can model a more complex system with this. Do we need, how many arrows do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12, just like before, but we have more. Okay. These are not the output. This is the output. So we have 3 more, synapses, weights, whatever you want to call them. We have 3 more arrows. So we have a total of 15 different synapses or axons, dendrites, and the synapse in between. Okay, so now let's look at a wider network. And the application for a wider network, you get much more interesting things out of it. This is also a 2-layer neural network with, these are the inputs. And these are this is the hidden layer, and this is the output layer. So how many neurons do we have? Well, let's talk about inputs first. How many inputs do we have? The way we drew this, okay, with this dot, 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 we have 784 inputs. Why? I'll explain in a minute. How many do we have in the middle? We say 16 down here. There's this dot, 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 so it's not 5. It's 5 plus whatever's here. And what we're saying is 16. That's an arbitrary number. How well this works depends on how many hidden layers. On the output, how many neurons do we have? We have 10. Okay, because we have this dot, 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 10 outputs. So what this is 784 inputs, 16 hidden layers, 10 outputs. Now, what are we going to do with this network? Okay, what if we take a 28 by 28 grid, okay, and draw numbers on it, handwritten numbers. It's a grid, it's like pixels. Everybody understands how to take a picture, that's a representative of, it's represented by pixels. We can basically tell what those handwritten numbers are. And, this will be another lecture, is actually developing this with Python, developing this network and showing how you can do handwritten numbers. And this is, decades ago, 3 decades ago at least, that we were doing this level of handwriting recognition. So the way this works is we say which one of those pixels is lit up, and then we give it a number going in. All the other ones that are not lit up, give them a 0. One of these, 0 through 9, will light up depending on what is on that input, what is on those pixels. And that's how this neural network recognizes handwritten numbers. So this is just a way of looking at the count. And that data set, okay, the handwritten numbers, is a very popular data set, the MNIST data set. Early image recognition, as in a while ago. And so that's how many arrows do we have? 784, by however many you have in the middle, 16. And then 16 by 10 on this layer. So that's how many synapses, axons, dendrites you have. How many neurons do you have? 16 plus 10 is 26. That's it. To recognize handwritten numbers, all you need is 26 neurons in exactly the same form I just presented. That's all you need, and you can do handwritten numbers. This is how the brain works. This is why we're so smart. All we need is 26 neurons, and we have 100 billion of them in our head to recognize handwriting. It's pretty amazing. That's how smart we are. All right, so let's talk about deeper neural networks. That was a very basic deep neural network. Let's go and look at deeper neural networks. So before we had just one hidden layer, okay? Now let's do more hidden layers. Okay, now we have two hidden layers. We have the input, okay? We call that layer, but it's not actual neurons. Then we have 4 neurons in this hidden layer, 4 neurons in this hidden layer, and then 1 in the output. So what's the application of this one? I don't know. Addition could be the application of this one. And we would see that we can actually do that. So this is a very simple, deeper neural network where we just added 1 neuron or 1 layer. But there's also even more than that. We could have, 100 hidden layers. Okay, and that's how convolutional networks have come about. And the neurons are a little different in just that they're different activation. That's all. All the activation we've been doing up to now is the same kind. I showed you before. Same thing as what's in logistic regression, but you do different kinds, like the ReLU. And then you can do what's convolutional neural networks do, which is better image recognition. Not just like handwritten numbers, but like faces. Okay, much more complex pictures, more pixels. There's also recurrent neural networks, okay, which is where instead of just feeding forward all the way through, you have feeding backwards or feeding across. So that's all that is. Autoencoders are where you have the same thing on the input as you do on the output. And you can do some special stuff with that. Okay, so so I just talked about these advanced neural networks, like convolutional neural networks. I'll show that structure in just a second. Recurrent neural networks, I'll show that one as well. And a very special type of recurrent neural networks is the LSTM, long short-term memory, which you can do neural networks with a combination of these. I know this is way beyond what we're talking about here. What I'm doing is just, I'm going to show you extensions of the basic neural networks. So the CNN looks like this, where you have this very complex picture at the beginning, feeding through all of these layers, all the way to the output. And very basic, just neurons throughout all of these. And you have different types of neurons, neural layers, convolution versus ReLU versus pooling. You just one after the other of all of these layers, and we end up with being able to tell whether that's a car, truck, van, or bicycle. Okay, but it's all the very basic structure, the structure I just showed you. Just add more and more and more and more of them. That's all it is. So RNN, recurrent neural network. Here's some I'll stop this in the middle here. Or I guess, oh, that's this one. I can stop this one here. So recurrent neural network, I'll just run this one. Takes the output and then puts it back to the input or puts it to the next one. And what you do with recurrent neural networks is you have a time aspect or an order aspect stored in it. Like this is great with natural language processing, because language has an order to it. You have words made up of symbols, these letters, and also then sentences made up of words in an order. So like you put each word on the input, and then you get the meaning on the output. So that's how neural networks work, how recurrent neural networks. More advanced, these are going to be more lectures that we'll be showing in the future. And then the combination between the two, like if you have your CNN structures at the beginning, and then the long short-term memory structures in the middle, and then on the output you have just like the basic structure that we started with, and the input being a picture or words, and the output being meaning. Feelings is another kind of meaning.
There's no better time to train yourself in the exciting field of machine learning. If you're looking for a course that covers everything from the fundamentals to advanced techniques, for that, accelerate your career in AI and ML with a comprehensive postgraduate program in AI and machine learning. Gain expertise in machine learning, deep learning, NLP, computer vision, and reinforcement learning. You will receive a prestigious certificate, exclusive alumni membership, and Ask Me Anything sessions by IBM, with 3 capstone projects and 25 plus industry projects using real datasets from Twitter, Uber, and more. You will gain practical experience. Master classes by Caltech faculty and IBM experts ensure top-notch education. Simplilearn's Job Assist helps you notice by leading companies. This program covers statistics, Python, supervised and unsupervised learning, NLP, neural networks, computer vision, GANs, Keras, TensorFlow, and many more skills. Enroll now and unlock exciting AI and ML opportunities. The course link is mentioned in the description box below.
Finding a suitable job in the field of machine learning is becoming increasingly difficult. The ideal way to display your machine learning skill is in the form of portfolio of data science and machine learning projects. A solid portfolio of projects will illustrate that you can utilize those machine learning skills in your profile as well. Projects like movie recommendation system, fake news detection, and many more are the best way to improve your early programming skills. You may have the knowledge, but putting it to the use what is keep you competitive. Here are 10 machine learning projects that can increase your portfolio and enable you to acquire a job as a machine learning engineer. At number 10, we have loan approval prediction system. In this machine learning project, we will analyze and make prediction about the loan approval process of any person. This is a classification problem in which we must determine whether or not the loan will be approved. A classification problem is a predictive modeling problem that predict a class label for a given example of input data. Some classification problems include spam email, cancer detection, sentiment analysis, and many more. You can check the project link from the description box below to understand classification problem and how to build a loan prediction system. At number 9, we have fake news detection system. Do you believe in everything you read in social media? Isn't it true that not all news is true? But how will you recognize fake news? ML is the answer. You will be able to tell the difference between real and fake news by practicing this project of detecting fake news. This ML project for detecting fake news is concerned with the fake news and the true news. On our dataset, we create a TF-ID vectorizer with sklearn. The model is then fitted using a passive-aggressive classifier that has been initialized. Finally, the accuracy score and the confusion matrix indicate how well our model performs. The link for the project is in the description box below. At number 8, we have personality prediction system. The idea is based on determining an individual personality using machine learning techniques. A person's personality influences both his personal and professional life. Nowadays, many companies are shortlisting applicants based on their personality, which increases job efficiency because the person is working on what he is good at rather than what he is compelled to do. In our study, we attempted to combine personality prediction system using machine learning techniques such as SVD, Naïve Bayes, and logistic regression to predict a person's personality and talent prediction using phrase frequency method. This model or method allows users to recognize their personality and technical abilities easily. To learn about more this project, check the link in the description box below. At number 7, we have Parkinson disease system. Parkinson disease is a progressive central nervous system element that affects movement and causes tremors and stiffness. It comprises 5 stages and affects more than 1 million worldwide each other. In this machine learning project, we will develop an SVM model using Python modules, sci-ket, NumPy, and pandas. An SVM, we will import the data, extract the features and label and scale the features, split the dataset, design an SVM model, and calculate the model accuracy. And at the end, we will check the Parkinson disease for the individual. To learn about more this project, check the link in the description box below. At number 6, we have text-to-speech converter application. The machine learning domain of audio is undoubtedly cutting edge right now. The majority of the applications available today are the commercial. The community is building several audio-specific open source framework and algorithm. Other text-to-speech APIs are available for this project. We will utilize pyttsx3. pyttsx3 is a Python text-to-speech conversion library. It operates offline unlike other libraries and is compatible with Python 2 and Python 3. Before API, various pre-trained models were accessible in Python, but changing the voice or volume was often difficult. It also needed additional computational power. To learn more about this project, check the link in the description box below. At number 5, we have speech recognition system. Speech recognition, often known as speech to text, is the capacity of a machine or program to recognize and transfer words spoken aloud into readable text. ML speech recognition uses algorithms that model speech in terms of both language and sound to extract the more important parts of the speech, such as words, sentences, and acoustic modeling is used to identify the phonemes and the phonetics on the speech. For this project, we will utilize pyttsx3. pyttsx3 is a Python text-to-speech conversion library. It operates offline unlike other libraries and is compatible with Python 2 and Python 3. To learn more about this project, check the link in the description box below. At number 4, we have sentiment analysis. Sentiment analysis, also known as opinion mining, is a straightforward process of determining the author's feeling about a text. What was the user intention when he or she wrote something? To determine what could be personal information, we employ a variety of natural language processing and text analysis technology. We must detect, extract, and quantify such information from the text to enable classification and data manipulation. In this project, we will use the Amazon customer review dataset for the sentiment analysis. Check the link in the description box below. At number 3, we have image classification using CNN. Deep learning is a booming field currently. Most projects and problem statements use deep learning is an any sort of work. Many of you, like myself, would choose a conventional neural network as a deep learning technique for answering any computer vision problem statement. In this project, we will use CNN to develop an image processing project and learn about its capabilities and why it has become so popular. We will go over each stage of creating our CNN model and our first spectacular project. We will use the CFR10 dataset for image classification in this project. To learn more about this project, check the link in the description box below. At number 2, we have face recognition system. Currently, technology absolutely amazes people with incredible invention that makes life easier and more comfortable. Face recognition has shown to be the least intrusive and fastest form of the biometric verification over time. This project will use OpenCV and face recognition libraries to create a face detection system. OpenCV provides a real-time computer vision tool, library, and hardware. We can create amazing real-time projects using OpenCV. To learn how to create face recognition system for you, check the link in the description box below. And last but not the least, we have movie recommendation system. Almost everyone today uses technology to stream movies and television shows. While figuring out what to stream next can be disheartening. Recommendations are often made based on a viewer history and preferences. This is done through a machine learning and can be a fun and the easy project for the beginners. New programmers can practice by coding in either Python or R. And with the data from the Movie Lens dataset generated by the more than 6,000 users. To learn how to create movie recommendation system for yourself or for your loved ones, check the project in the description box below. We will take you through a hands-off lab demo of how to do image classification using CNN. Before we start, I hope the screen is clearly visible and the audio is fine. If yes, please type in yes. If there are any issues, to let us know in the chat section so that we can resolve them. Let's wait for some more minutes to let other people join. Until then, let me tell you guys that we have regular updates on multiple technologies. If you are a tech geek in a continuous hunt for the latest technological trends, then consider getting subscribed to our YouTube channel and press that bell icon to never miss any update from Simplilearn. Great, I think we can get started. So in today's session, we will discuss what image classification is, and moving ahead, we will discuss what CNN is, and at the end, we will do a hands-off lab demo of image classification using CNN. So before we move on to the programming part, let's discuss what image classification is and proceed further for the same. What is image classification? The process of classifying an entire image is known as image classification. Images are anticipated to have just one class per image. Models for image classification take an image as input and produce a prediction of the class to which the image belongs. So we can utilize image classification models when we are not interested in individual instance of items with position information or their shape. So let's see what is CNN. Machine learning includes convolutional neural networks. also known as convents or CNNs. It is a subset of the several artificial neural network models that are employed for diverse purpose and datasets. A CNN is a particular type of network design for deep learning algorithm that is utilized for tasks like image recognition and pixel data processing and so more. Okay. Although there are different kinds of neural network in deep learning, CNNs are preferred neural architect for identifying and recognizing objects. Therefore, they are really suited for computer vision activities and applications where accurate object recognition is crucial, such as facial and self-driving automobile system. So moving ahead, so dear learners, if you want to upskill your AI and machine learning skills, so give yourself a chance to simply learn professional certificate program in AI and machine learning, which comes with the completion certificate and in-depth knowledge of AI and machine learning. Check this course out details from the description box below. So now let's move to our programming part of how to do image classification using CNN.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
So first we will open a command prompt to write a command to open Jupyter Notebook. So here we will write Jupyter Notebook. Press enter. So this is the landing page of Jupyter Notebook. So here you can select new Python file. So this is how the kernels look like. Okay, Jupyter Notebook kernels look like. So first we will import some major libraries of Python which will help us in like analyzing the data. Okay. So in this file we will classify small images of CIFAR 10 dataset from TensorFlow Keras dataset. There are total 10 classes as shown below. So we will use CNN for the classification purpose. Okay. So here I will write import TensorFlow as TF. Okay. So from TensorFlow dot keras import datasets comma layers models. Okay. So we will import numpy as np, right? And import matplotlib as plt, right? Okay, so here I will write pyplot as plt, right? So TensorFlow, this one, this. So TensorFlow is a free and open source machine learning and artificial intelligence software library. It can be used for a variety of applications, but it focuses on mainly deep neural network training and the inference purpose. Okay, got it? And this NumPy. NumPy is a Python library used for working with arrays. It also has a function for working with the domain of linear algebra and matrices. It is an open source project and you can use it freely. NumPy stands for numerical Python. And this third one, Matplotlib. For Python and its numerical extension NumPy, Matplotlib is a cross-platform data visualization and graphical charting package. As a result, it presents a strong open source substitute for MATLAB. The APIs, application programming interfaces for Matplotlib allow programmers to incorporate graphs into GUI applications. Got it? So let's run this. Let me change image classification using CNN. Okay. So let's load the dataset. Okay, we will load the dataset from the load data function. So here I will write x underscore train comma y underscore train. Okay, and one for test x underscore test comma y underscore test. Okay, then equals to data sets dot we are using cipher 10 cipher 10 far 10 dot load dot underscore data. Okay, so it will load our data. So let's load the data. So data is loaded. Let's see x underscore test dot shape. Okay, yeah. So as you can see, so we have 1000 rows and one more x underscore train dot shape. Let me run this. So here you can see, like we see like training data, like training images are 50,000 and the test images are 10,000. Okay, so this is for testing, this is for training. And so moving ahead, we will see for the y train dot shape. Okay, 1000, and here we will see the array. So y underscore train uh, 5. Okay, let's run this first. Let me give some space. Yeah. So here y underscore train is a 2D array. Like for our classification, having 1D array is a good enough. So what we will do, we will convert this to now 1D array. This is 2D array. We will convert into 1D array. Okay. For that, we'll write here y underscore train equals to y underscore train dot reshape -1 comma. Okay. Then y underscore train and again semicolon 5. Let's run this. Okay, so now this is 1D array. So y underscore test equals to y underscore test dot reshape in -1. Here I will write classes equals to, there are some classes, okay, in the data set, like airplane, comma, automobile, comma, bird, comma, cat, comma, deer, comma, dog, and frog, horse, ship, the truck. Okay, so these are the some classes like airplane, automobile, bird, cat, deer. So it will be help in classifying the images. So let's plot some images to see like what they are, what they exactly are. Okay. So we will, what we will do, we will create one function for that. Let me write here def plot underscore sample. Okay. Then x comma y comma index. Okay, then I will write here plot dot figure, plt dot figure. Then figure size should be comma 2 equals to plt dot show, image show, so I am show x index plt dot x label classes y index. Okay, so let's see some samples of the images. So I will write a plot underscore sample underscore train comma y underscore train. Okay, comma, let's see the fifth image. Okay, then enter. Should be capital. So as you can see, this is a car, so it is showing automobile. Okay, so let's see once more, like plot underscore sample x underscore train comma y underscore test comma, we'll see the 10th one. Okay, it is not quite visible, so we'll go for the 11. Okay, okay, I am why it is showing wrong, because I use here test. I have to use here train instead of test. Then it will show, I think, correct. Yeah, you can see horse, then horse. Then what about 201 image? See, you can see. So we will see once more. 500. You can see frog. Okay, it's not quite visible. Yeah. So you can see here the proper shape. Okay. So what we will do now, we will normalize the images to a number from 0 to 1. Image has 3 channels like RGB colors. So, and each value in the channel can range from 0 to 255. Hence, to normalize in 0 to 1 range, we need to divide it by 255. Okay. So now what we will do, we will normalize the data. So here, what we will do at x underscore train equals to x underscore train divided by 255.0. Okay. And same for test equals to x underscore test divided by 255.0. Okay, to range between 0 to 1. Yeah, we will build simple artificial neural network for image classification first. Okay, so we will write here ANN equals to models dot sequential. Okay, then I will write here layers dot flatten input underscore shape equals to 32 comma 32 comma 3. Okay, then again layers dot dense 3000 comma activation equals to ReLU. Got it? Then again for the 1000, so what I will do, I will copy it and paste it here. Okay, so 1000. So let me add one more layer dot dense, then we'll add 10 comma activation equals to softmax. Okay, here I will, okay, let me give for the better visuals. Yeah, so ann dot compile optimizer, okay, equals to sgd, then comma, I will write here loss equals to sparse categorical cross entropy. Okay, so here I will write comma, then matrix equals to accuracy, and ann dot fit underscore train comma y underscore train comma epochs. Okay, so number I will give epochs equals to 5, right? So it will take time to run. It's running. Here there is some issue. Underscore train epochs equals to 5. What it is saying, end user code, the file program C engine. Okay, so I will copy it and paste it again. Run it again. Okay, now it's working. Okay, so it will take time and then I will get back to you. Okay, then import numpy. You guys already know what numpy is. Np y underscore prediction equals to ann dot predict x underscore test. Okay, then y underscore prediction underscore classes equals to np dot argument max element or element in y underscore prediction. Print classification port comma classification underscore report, then y underscore test comma y underscore prediction underscore classes. Okay, so let me run this. This is capital. Yeah, it will take less time. Now we will create a graph. Okay. Like X text is like we have 1,000 images, so graph will be like messed up. Still, let's see. So I'll write here import cborn as SNS. Okay. Okay, cborn. Yeah. Let me give some space. Here I will write plt dot figure, because size should be 14,7. Okay, then SNS we will create a heat map for this. Then y underscore prediction not equals to true. Then plt dot y label is truth. Okay. Plt dot x label fiction. Then plt dot title should be fusion. Okay, then plt dot show. Let me run this. Okay. See, y prediction has x text. It's still running. Let's wait. So now let's make CNN model, okay, to train our images. So for that, I will write CNN equals to models dot sequential. Okay, right here, go paste here. Yeah. So let me run this. So this is our CNN model from which we will train our images, and CNN like compile, then optimizer equals to Adam. Okay. Okay, comma right here. Then loss equals to sparse categorical. Okay, then cross entropy. Okay, and comma. I will write here matrix equals to accuracy. Run this. Okay, loss. Yeah, same goes for you. Okay, loss. What will I do? I will rewrite this. Okay, now let's check CNN model for the 10 epochs. Okay, Let's see the accuracy is increasing or not. CNN dot underscore train, comma y underscore train, comma box equals to it is started. It will take less time than the previous one. Okay, see, you want this whole code, you can comment down the same. Okay, so after completing this, I will get back to you. So it is almost done, like 27 seconds with a 10 epochs. Till then, let me write CNN dot evaluate x underscore test, comma y underscore test. Okay. So with CNN, the N5 epoch accuracy was around like 70%, and which is a significant improvement over ANN. Okay, ANN we have like just 49. Okay, and CNNs are the best for image classification and gives the superb accuracy. Also, computation is the much less compared to simple ANN, as max pooling reduces the image dimension while still preserving these features. Okay, so let me run this. Take some time. Till then, I will write y underscore prediction equals to CNN dot predict, and x underscore test. Okay. Then I will write here y underscore prediction, then colon 5. Let me run this. So you can see the accuracy and all, the array. Okay. Yeah. So let's classes equals to np dot arg max element or element in y prediction. Okay. Then y underscore classes, then these are the number of classes, then y underscore test is column 5. These are the array, so it's converted into array. Then now let's see the it is predicting right image or wrong image. Okay, by not with the training data. Here we predict from the training data, y training, x train. Okay, now we will predict from the test data. So here I will write plot underscore sample, then x underscore test, comma y underscore test, and you can write the random one. So here I will write 60. Let's see. So you can easily see here this is horse and it is predicting right horse. And let me okay, plot underscore sample, then x underscore test, comma y underscore test, comma 100. Okay, press enter. Okay, X is capital. Yeah, so you can see this is deer. Okay, so our model is predicting the correct image. Okay, then what we like, let's see it is predicting the right class or not. Okay, we made the classes like random classes. Okay, where are these? So let's see it is predicting right or wrong. Okay, for that I have to write classes y underscore classes. It's like which number? 60. Okay, 60. The 60 is not defined because like number of classes. Okay, okay. So there are 1, 2, 3, 4, 5, 6, 7. Okay, 0 to 9. I can choose. So here what I will do, I will take the small one, like I will 5. Okay, this is frog. Okay, this frog, right? So I will take instead of 60 here I will see frog. Okay, y class is not defined. Y underscore classes. Is defined. See, okay, there are 3s. Yeah. So as you can see, frog. This is frog. So our class is defining right. So here I will write it again like 60. It was horse. And let me write here 60. You can see the right prediction. Okay. So this is what how you can do image classification using CNN. First, we will import some major libraries of Python. So here I will write import pandas as PD and import numpy as np. Then import cborn as sns. Okay. Then import sklearn dot model selection import train underscore test underscore split. Before that, I will import matplotlib dot pyplot as plt. Okay, then I will write here from sklearn dot matrix import accuracy score. Then from sklearn dot matrix import classification to report. Then import re, then import string. Okay, then press enter. So it is saying, okay, here I have to write from everything seems good. Loading. Let's see. Okay, till then, NumPy is a Python library used for working with arrays. It also has function for working with the domain of linear algebra and matrices. It is an open source project and you can use it freely. NumPy stands for numerical Python. Pandas. So Panda is a software library written for Python programming language for data manipulation and analysis. In particular, it offers data structure and operation for manipulating numerical tables and time series. Then, Seaborn. An open source Python library based on Matplotlib is called Seaborn. It is utilized for data exploration and data visualization. With data frames and the pandas library, Seaborn functions with ease. Then Matplotlib. For Python and its numerical extension NumPy, Matplotlib is a cross-platform for the data visualization and graphical charting package. As a result, it presents a strong open source suitable for MATLAB. The APIs for Matplotlib allow programmers to incorporate graphs into GUI applications. Then this train test split. We may build our training data and the test data with the aid of sklearn train test split function. This is so because the original dataset often serves as both the training data and the test data. Starting with a single dataset, we divide it into two datasets to obtain the information needed to create a model, like hone and test. Accuracy score. The accuracy score is used to gauge the model's effectiveness by calculating the ratio of total true positive to total true negative across all the model prediction. This RE, regular expression. The functions in the model allow you to determine whether a given text fits a given regular expression or not, which is known as RE. Okay, then string. A collection of letters, words, or other characters is called a string. It is one of the basic data structure that serves as the foundation of manipulating data. The str class is a built-in string class in Python. Because Python strings are immutable, they cannot be modified after they have been formed. Okay, so now let's import the dataset. We will be going to import two datasets, one for the fake news and one for the true news, or you can say not fake news. Okay, so I will write here ef underscore fake equals to pd dot read underscore csv, or what can I say, df fake. Okay, data underscore fake. Okay, then fake dot csv. You can download this dataset from the description box below. Then data dot true equals to pd dot read underscore csv. Sorry, csv. Then fake news. Sorry, true. True dot csv. Okay. Then press enter. So these are the two datasets. You can download these datasets from the description box below. So let's see the board dataset. Okay. Then I will write here data underscore fake dot head. So this is the fake data. Okay. Then data underscore true dot head. And this is the true data. Okay. This is not fake. So if you want to see your top 5 rows of the particular dataset, you can use head. And if you want to see the last 5 rows of the dataset, you can use tail instead of head. Okay. So let me give some space for the better visual. So now we will insert column class as a target feature. Okay. Then I will write here data underscore fake class equals to 0. Then data underscore true and class equals to 1. Okay. Then I will write here data underscore fake dot shape and data underscore true dot shape. Okay, then press enter. So the shape method returns the shape of an array. The shape is a tuple of integers. These numbers represent the length of the corresponding array dimension. In other words, a tuple containing the quantities of entries on each axis is an array shape dimension. So what's the meaning of shape? In the fake world, in this dataset, we have 2, 3, 4, 8, 1 rows and 5 columns. And in this dataset, true, we have 2, 1, 4, 1, 7 rows and 5 columns. Okay, so these are the rows, column for the particular dataset. So now let's move and let's remove the last 10 rows for the manual testing. Okay, then I will write here data underscore fake underscore manual testing equals to data underscore fake dot tail. For the last 10 rows I have to write here 10. Okay, so for I in range 2, 3, 4, 8, 1, sorry 0, comma 2, 3, 4, 7, 0, comma -1. Okay, then df underscore not df data underscore fake dot drop 1. Yeah, instead of 1 I can write here I, comma axis equals to 0, in place equals to true. Then data not here data underscore same I will write for I will copy from here and I will paste it here and I will make the particular changes. So here I can write true, here I can write true. Okay, then I have to change a number 2, 1, 4, 1, 6. Write 2, 1, 4, 0, 6 -1. Same. So press enter. X is equals to 0. Let syntax. Maybe you mean 00 or show of this. Okay, we will put here double equals. And I'm putting this fake dot drop I x is equal to 0. In place. Okay. Here also write equals to equals to. Yeah. So okay, axis is not defined. Now it's working. So let me see now data underscore fake dot shape. Okay, and data dot true and data underscore true dot shape. As you can see, 10 rows are deleted from each dataset. Yeah. So I will write here data underscore fake underscore manual testing and class equals to 0 and data underscore true underscore manual underscore testing class equals to 1. Okay. Just ignore this warning. And let's see data underscore fake underscore manual testing dot head. As you can see, we have this, and then data dot underscore true underscore manual testing dot head. Done. Okay. This is the true data set. So here I will merge data underscore merge equals to pd dot concat. Concat is used for the concatenation. Data underscore fake data underscore true comma axis equals to 0. Then data underscore merge dot head the top 10 rows. Yeah, as you can see, the data is merged here. Okay. First it will come for the fake news and then with the for the true news. And let's merge true and fake data frames. Okay, we did this, and let's merge the column. Then data dot merge dot columns, or let's see the columns. It is not defined, but I did data underscore merge. These are the columns name, title, text, subject, date, class. Okay, now let's remove those columns which are not required for the further process. So here I will write data underscore or equals to data underscore merge prop title we don't need, then subject we don't need, then so 1. So let's check some null values. It's giving error where because of this. That's good. Then data dot is null dot sum center. So no null values. Okay. Then let's do the random shuffling of the data frames. Okay. For that we have to write here data equals to data dot sample then data, okay, data dot head. Okay, now you can see here the random shuffling is done, and 1 for the true data set and 0 for the fake news one. Okay, then let me write here data dot reset underscore index place equals to true. Data dot drop comma axis equals to 1, then comma in place equals to true. Okay, then let me see columns now. Data dot columns. So here we have 2 columns only, rest we have deleted. Okay, so let me see data dot add. Yeah, everything seems good. Let's proceed further and let's create a function to process the text. Okay, for that I will write here what. Okay, you can use any name text, and text equals to text dot lower. Okay, and text equals to re dot for the substring remove these things from the datas. Okay, so for that I'm writing here comma okay, then text equals to re dot substring comma comma text. Okay, then I have to write text equals to re dot substring www dot s plus comma comma text. Okay, then text equals to re dot substring, then dot comma okay, then text equals to re dot substring, then percentage as again percentage for re dot escape function, write here string dot punctuation comma, then text, right? Then text equals to re dot substring and n comma text equals to re dot substring right here and again d then again okay then comma then again text here okay then at the end I have to write here return text. So everything like this these type of special character will be removed from the data set. Okay, let's run this. Let's see. Yeah. So here I will write df. Sorry, not df. Data. Then text equals to data. Okay. Dot apply to the function name word opt. Okay. Press enter. Yeah. So now let's define the dependent and independent variables. Okay, x equals to data text and y equals to data class. Okay, then splitting training and testing data. Okay, sorry. So here I will write x underscore train comma x underscore test then y underscore train comma y underscore test equals to train underscore test underscore split then x comma y comma test underscore size equals to 0.25. Okay, press enter. So now let's convert text to vectors. For that I have to write here z it's x. So here I will write from sklearn dot feature extraction dot text import t vectorizer. Okay, then vectorization equals to tfid vectorizer. Okay, then xv underscore train equals to vectorization vectorization dot fit then transform x underscore train. Okay, then xv underscore test equals to vectorization dot transform x underscore test. Okay, then press enter. So now let's see our first model, logistic regression. So here I will write from sklearn dot linear underscore model. Okay, import logistic regression. Okay. Then lr equals to logistic regression, and after that here lr dot fit, then xv dot not dot xv dot train comma xv underscore test. Okay, press enter. Lr dot xv dot train. Okay, here I have to write y train. Okay, then press enter. Will work. So here I will write prediction underscore linear regression equals to lr dot predict xv underscore test. Okay, let's see the accuracy score. For that I have to write lr dot score, then xv underscore test comma y underscore test. Okay, let's see the accuracy. So here as you can see accuracy is quite good, 98%. Okay, now let's print the classification port y underscore test comma prediction of linear regression. Okay, so this is, you can see precision score, then f1 score, then support value accuracy. Okay, so now we will do this same for the decision tree gradient boosting classifier, random forest classifier. Okay, then we will do model testing, then we will predict the score. Okay, so now for the decision tree classification. So for that I have to import from sklearn dot tree import decision tree classifier. Okay, then at the short form I will write here, I will copy it from here, then okay, then I have to write the same as this, so I will copy it from here and here. Just change linear regression to decision tree classifier. Okay, then I will write here same, go dt equals to dt dot predict xv underscore test. It's v still loading, it will take time. Okay, till then let me write here for the accuracy dt dot score v underscore test comma y. Okay, let's wait. Okay, let's run the accuracy. So as you can see accuracy is good than this linear regression, Okay, logistic regression. Okay, so let me show you the, let me predict trend. Okay, so this is the accuracy score. This is the all the report. Yeah. So now let's move for the gradient boosting classifier. Okay, for that I write from sklearn dot ensemble port gradient boosting classifier. Classifier. I will write here GB equals to, let me copy it from here. Okay, I will give here random underscore state equals to 0. Wait. So I will write here GB dot fit xv underscore train comma y underscore train. Okay, then press enter. Here I will write predict underscore GB equals to GB dot fit, sorry, predict xv dot test, not dot underscore test. Till then it's loading, so I will write here it's for the score. Then I will write GB dot score, then xv underscore test comma y underscore test. Okay, so let's wait, it is running this part. Till then let me write for the printing this. Okay, it's taking time. Still taking time. What if I will run this? It's not coming because of this. Yeah, it's done now. So you can see the accuracy is not good than decision tree, but yeah, it is also good, 99.4 something. Okay, so now let's check for the last one, random forest. First I will do, for the random forest we have to write from sklearn dot ensemble import random forest classifier. Okay, and here I will write rf equals to, right, I will copy it from here. Then random state equals to 0. Then rf dot fit v underscore train comma y underscore train. Okay, then press enter and predict underscore rc or f equals to rf dot predict xv underscore test. Okay, till then I will write here, it's still loading, it will take time. So till then I will write for the score accuracy score xv underscore test comma y underscore test. Okay, then I will write here till then print classification port and y underscore test comma. It will take time, little bit. So it run. The accuracy score is 99. It is also good. So now I will write the code for the model testing. So I will get back to you, but after writing the code. So so I have made two functions, one for the output label and one for the manual testing. Okay. So it will predict the all the from the all models from the repeat. So it will predict the news is fake or not from all the models. Okay, so for that let me write here news was to string put. Okay, then I will write here manual underscore testing. Okay. So here I will, you can add any news from the, you can copy it from the internet or whatever, from wherever you want. So I'm just copying from the internet. Okay, from the Google, the news which is not fake. Okay, I'm adding which is not fake because I already know, I searched on Google. So I'm entering this. So just run it, let's see what is showing. Okay, string input object is not callable. Okay, let me check this first. Okay, I have to give here str only. Yeah, let's check. Okay, I have to add here again the script. Yeah, the manual testing is not defined. Let me see manual testing. Okay, I have to edit something. It is just GB and it is just RF. Still GBC is not defined. Okay, okay. So what I have to do? I have to remove this. Okay, everything seems sorted now. Yeah. So as I said to you, I just copied this news from the internet. I already know the news is not fake, so it is showing not a fake news. Okay, so now what I will do, I will copy one fake news from the internet and let's see it is detecting it or not. Okay, so let me run this and let me add the news for this. So all the models are predicting right it is a fake news, or you can add your own script like this is the fake news. Okay, I hope you guys understand till here. So I hope you guys must have understand how to detect a fake news using machine learning. You can copy any news from the internet and you can check it is fake or not.
There's no better time to train yourself in the exciting field of machine learning. If you're looking for a course that covers everything from the fundamentals to advanced techniques, for that accelerate your career in AI and ML with a comprehensive postgraduate program in AI and machine learning. Gain expertise in machine learning, deep learning, NLP, computer vision, and reinforcement learning. You will receive a prestigious certificate, exclusive alumni membership, and Ask Me Anything sessions by IBM with 3 capstone projects and 25 plus industry projects using real datasets from Twitter, Uber, and more. You will gain practical experience. Masterclasses by Caltech faculty and IBM experts ensure top-notch education. Simplilearn's Job Assist helps you notice by leading companies. This program covers statistics, Python, supervised and unsupervised learning, NLP, neural networks, computer vision, GANs, Keras, TensorFlow, and many more skills. Enroll now and unlock exciting AI and ML opportunities. The course link is mentioned in the description box below.
What is time series forecasting? Making scientific projection based on the data with historical timestamps is known as time series forecasting. It entails creating models through historical study, using them to draw a conclusion and guide strategic decision making in the future. The fact that the future result is wholly unknown at the time of the task and can only be anticipated through analysis and evidence based priors is an essential distinction in forecasting. Give yourself a chance to Simplilearn's professional certificate program in AI and machine learning, which comes with completion certificate and in-depth knowledge of AI and machine learning. Check this course detail from the description box below. So here is one question for you guys. I will give you exactly 1 minute for this. You can comment or you can give your answer in the chat section so I can see if the answers given by you are right or wrong. Okay. So the question is, which type of programming does Python support? I'm repeating again. Which type of programming does Python support? Option A, object-oriented programming. Option B, structured programming. Option C, functional programming. And option D, all of the above. So let us know your answer in the chat section or in the comment section. So I'm starting a timer of 1 minute. Just type your answer in the comment section or in the chat section. Do let me know your answers, please. So I'm starting the timer of 1 minute. Which type of programming does Python support? Object-oriented, structured programming, functional, or all of the above? Do let me know your answers, please. You can comment or you can give your answer in the chat section so I can see if the answers given by you are right or wrong. Which type of programming does Python support? Object-oriented, structured, functional, or all of the above? 30 seconds remaining. Which type of programming does Python support? Object-oriented, structured, functional, or all of the above? Let us know your answers in the chat section or in the comment section below. 10 seconds more. Which type of programming does Python support? 5 seconds more. So the allotted time is over. We will give a reply to those who gave the correct answer. And for those who didn't give the correct answer, we will give you reply with the correct answer. Okay. Now let's move to our programming part. So we will open command prompt to write a command to open Jupyter Notebook. So here I will write Jupyter Notebook. Press OK, Jupyter Notebook. Press enter. Will take time. It's open. So this is the landing page of Jupyter Notebook, and here I will select new Python kernel file. So this is how Jupyter kernel look like. So here what we will do, we will import some major libraries of Python which will help us in analyzing the data. Okay, import numpy as np. Okay, then import pandas as pd. Then import seaborn as sns. The fourth one is from matplotlib import pyplot as plt. Okay, then we will import some model libraries. So here I will write from stats models dot tsa dot api import exponential smoothing and comma, then simple xp smoothing, then one more hold. We will write here import from sklearn dot linear underscore model import linear regression. Okay, then import warnings. Then we will write here warnings dot filter warnings. It should be ignore. Yes, there will be no error. Oh, it's still loading. Yeah. So NumPy. NumPy is a Python library used for working with arrays. It also has a function for working with the domain of linear algebra and matrices. It is an open source project and you can use it freely. NumPy stands for numerical Python. Second is Panda. Pandas is a software library written for the Python programming language for data manipulation and analysis. In particular, it offers data structure and operations for manipulating numerical data and time series. Then Seaborn. An open source Python library based on Matplotlib is called Seaborn. It is utilized for data exploration and data visualization. With data frames and the pandas library, Seaborn function with ease. Matplotlib. For Python and its numerical extension NumPy, Matplotlib is a cross-platform data visualization and graphical charting package. As a result, it presents a strong open source substitute for Matplotlib. The APIs for Matplotlib allow programmers to incorporate graphs into GUI applications. Linear regression. The machine learning method regression built on linear supervised learning. Analysis regression is done. Regression creates a value for the aim prediction using independent variables as inputs. Its main goal is to investigate the relationship between factors and forecasting. Exponential smoothing. The exponential windows function is a general method for smoothing time series data known as exponential smoothing. It contrasts to the ordinary moving average, which weights previous data quality. Exponential function use weights that decrease exponentially with time. And there is one more simple exponential smoothing. The simple exponential smoothing classes use simple exponential smoothing models to give very simple time series analysis. A weight average of the most recent value and the preceding smooth value constitute the predicted value. The contribution of older value degrade exponentially as a result of the smoothing parameter. Okay, so after importing libraries, let's import dataset. For this, I will write here df, or you can write data frame pd dot read underscore csv. Here I will write monthly underscore csv dot csv. Okay, this is my file name. You can download this file from the description box below. And for seeing the data, I will write here df dot head. Okay, then press enter. Yeah. So here PD is for pandas library, read is used for reading the dataset from the machine, and CSV is used for the type of file which you are using, okay, or which you want to read. And if you want to see the top 5 rows of your dataset, you can use head. And if you want to see the last 5 rows of your dataset, you can use tail instead of head. Okay, this one you can write here tail. So moving forward, let's see how many rows and columns are present in our dataset. For that, I have to write df dot shape. Okay, then press enter. Okay, it will give error. Why? Because this. Yeah. So here you can see 847 rows and 2 columns, date and price only. So moving forward, let's do some EDA, exploratory data analysis. Okay, for that, I have to write here print data date range of gold prices available from and here I have to give curly brackets, then df dot location loc, then colon comma date. Okay, D is capital here, so I have to write date. Then from location 0 to again same thing df dot loc date to the length of df minus 1. Oh, everything seems good. Yeah. Then press enter. Okay. We have date range of gold prices available from this 1950 to 2020. Okay, in our data set. Then here I will write date equals to pd dot date range start from /1 / 1950 comma and equals to 8/1 / 2020 comma frequency equals to median. Okay, then here I will write date, then press enter. Yeah. So here you can see date time index. Okay, from starting till end, these dots, and here I will write df month was to date. Df dot drop is date comma axis is 1 comma in place was to true. T should be capital. Okay. Then df equals to df dot set index then month, and df dot head, press enter. So instead of this date, we have adjusted this month, okay, for particular value. So moving forward, let's see the graph, different graphs, okay. df.plot, then figure size should be equals to 20 comma 8, then plot dot title is like gold prices monthly since 1950 and onwards. Okay, title should be this. Then X label should be plt dot X label will be months. Then plt dot Y labels should be price. Then I will write here plt dot grid. Okay, press enter. Okay, title spelling, my bad, title. Okay, then press enter. Oh, Y label it is, sorry. Yeah. Here you can see gold prices monthly since 1950 and onwards. Okay, till from 1950 and from till 2020. Okay, this is the price. Then moving forward, let's see another graph. So I will write here for that round df dot describe comma 3. And here you can see the count variable and the average is 416.557 standard deviation. That minimum price value is this, 20% this, and the maximum value is this. Okay, so so the average gold price in last 70 years is this 416.557. Okay, only 25% of the time the gold price is above 447. The highest gold price ever touched is this one, 1840, 807. So we will do visual analysis. So here I will write AX equals to PLT dot subplots. Okay. Then figure size equals to 25 comma art. Okay. Then SNS dot box plot is X equals to df dot index dot year comma y equals to df dot values colon comma 0 comma ax equals to ax. Okay, then same plt dot title gold price monthly 1950 onwards. Same graph will come but in the different format. Okay, let me remove this. Then plt dot x label label must be year. PLT dot y label price, and PLT dot x ticks will be rotation equals to, okay, I will give rotation 90. PLT dot grid. Can write here instead of grid, I can write here directly show. So grid is this format, this box format. Okay. So press enter. It's loading. Yeah. So here you can see from 1950, every year is here till 2020. So how the gold prices are decreasing and increasing. Okay. Let's see the another graph. I will write here from sets models dot graphics dot TSA plots quote month plot. Okay. Then I will write here figure comma AX equals to, then PLT dot subplots figure size equals to 22 comma 8. Okay. Then month plot df comma y label equals to gold price. Okay, comma, then AX equals to AX, and I will give the title PLT dot title. So I will copy from here. Okay. And PLT dot X label month, and PLT dot Y label be price. PLT dot grid. So here you can see gold prices monthly since 1950, like for every month, like January, February, March, April, so on till December. Okay. We will cover one more graph. Okay. And many more graphs. So we will go with the next graph. For that, I will write here. Let's go, comma, AX equals to PLT dot subplots and figure size equals to 22, comma 8. Then same SNS dot box plot X equals to df dot index dot month name. Okay. Then y equals to df dot values comma 0 comma ax equals to ax. Okay, then plt dot title will put same title, so I can copy from it here. Let's copy from here and paste it here. Okay. And plt dot x label and plt dot y label price and plt dot grid. Okay, plt dot show. This time let's not use grid. Okay. Okay, something pdf's month name. Yes, you can see for every month. This is another type of graph. Okay, box plot graph. So why we are creating so much graphs? Because we are doing EDA, exploratory data analysis. In this, we have to see the multiple different types of graph. Okay, so moving forward, let's see average gold price per year, like trend since 1950. So for that, I have to write here df underscore yearly underscore sum equals to df dot resample sample, then a dot mean df underscore yearly underscore sum dot plot plt dot title, and here I will write average gold price yearly since 1950, or you can write onwards from onwards 1950. So here I will write plt dot x label year and plt dot y label price. Okay, then plt dot grid, this time we'll use grid. So here you can see the average gold price yearly since 1950. Okay, this is the chart till 2020, like sometimes up, sometimes down. Okay, and we will see now like average gold price per quarter, like trends, like since 1950. So here I will write df dot, not dot, df dot quarterly. Okay, underscore sum equals to df dot resample quarter q dot mean. Okay, okay, move this. Then df underscore quarterly underscore sum dot plot. Then the same plt dot title from here. Here I will write average gold price quarterly. quarterly. Okay, since 1950. Then plt dot x label is now here quarter. Plt dot y label is price. Okay. Now plt dot show it this time. Okay. F underscore quarterly. Okay, quarterly. Yeah. So here you can see the price prediction. Okay, let me set to the grid only. It's not visuals are not good. So grid. Yeah. So here you can see the quarterly prices prediction. Okay, average gold price quarterly prediction. So like moving forward, we will see now average gold price per decade, like per 10 years. Okay, so from 1950 only. So here I will write df underscore decade underscore sum equals to df dot resample every 10 year. Okay, 10 year dot mean. We are writing mean because we are like putting out average. Okay, so df underscore decade underscore sum dot plot plt dot title average gold price per decade since 1950. Okay, it's since 1950. Yeah, perfect. So here I will get plt dot x label, then decade is of like every 10 year. Plt dot y label and plt dot grid. Yeah. So here you can see the average gold price per decade, like from 1950 to 1960, like this, straight, then again straight, then up, then sometimes down, then up and down. Okay. Every 10 year, you can see a 1990, 2000, 2010, and 2020. So moving forward, let's do like analysis in coefficient of variation. The coefficient of variation CV is a statistical measure of the relative dispersion of data points in a data series around the mean. And in finance, the coefficient of variation allows investor to determine how much volatility or risk is assumed in comparison of the amount, like amount to the return expected from investors. Okay, the lower the ratio of the standard deviation to mean return, the better risk return trade-off. Okay, let us look now the CV values for each year in gold prices. So CV means coefficient of variation in prices. Okay, so here I will write df underscore 1 equals to df dot group by df dot index dot year dot mean dot name dot columns equals to, I will write price and mean. Okay. Then again, df underscore 1 equals to df underscore 1 dot range. Or what we can do instead of range, we can write merge df dot group by scope df dot index dot eo standard deviation, rename columns equals to price standard deviation, comma left index equals to true, and then comma right index equals to true. Okay, and here df underscore 1 scope equals to df underscore 1 standard deviation slash df underscore 1 into 100 like dot round figure should be like 2 after decimal, how much like numbers you want to see, then df underscore 1 dot head, press enter. Yeah, so here you can see for every year I have mean, standard deviation, and this coefficient of variation. Okay, for every year. So like moving forward, let's see the average gold price per year again. So for that figure underscore figure dot comma ax equals to plt dot subplot figure size 15 comma 10. Okay. Then I will write here df underscore 1 is like cov underscore dot plot plt dot title average gold price yearly since 1950. Okay, then plt dot x label is year, or plt dot y label coefficient of variation, I'm writing cv in percent. Okay, then plt dot show. Get df underscore invalid syntax. Okay, what I cov is capital ect dot plot. Okay, so df underscore 1, df underscore 1. Right, okay, it here. Valid syntax. Okay. So here you can see average gold price since 1950. Okay. This is like percentage, CV in percent. Okay. Like good, you can say the chart. So the CV value reached its highest in 1978, like somewhere here, like 1980, 1978. Okay. Like near to 25%, which could have made the asset as a highly risky. But in 2020, the CV value is closer to 5%, which makes the asset variable via good investment. Okay. So now what we will do time series forecasting. Okay. We will train model, we will build model, different model. We will train and test split to build time series forecasting model. So for that, let me do like this first. Yeah. So here I will write train equals to df dot index dot per year. Okay, equals to 2015. And for the testing, we will write df dot index dot year 2015. Okay, for training we are taking till 2015, for the testing we are taking till 2020 from 2015. Okay, then I will write here how many columns present in train or test. So for that I will write print train dot shape and print test dot shape. Press enter. 792 rows and one column in training for training the model and 55 to test the model. Okay. So now let's see the training data and testing data. So train it's like square brackets. So price dot plot, then figure size equals to 13 comma 5, and font size should be equals to 15. Test size dot plot figure size, let me give same 13 comma 5, and font size should be 15. Okay, then plt dot, let me add grid, plt dot grid, then plt dot legend training data comma test data. Okay, then plt dot show. I will tell you what the legend is. Okay, So here you can see the training data in blue and the testing data. Okay, this is known as the legend, this portion. And yeah, so here you can see month wise, okay, till 2020 and from 1950. Right, these are the prices and this is the chart. So moving forward, let's do model formation now. Okay, we will do two models, linear linear regression and the naive Bayes one. Okay, so first we will go from linear regression. For that, I will write train underscore time equals to I plus 1 for I in range train. Test underscore time equals to I plus length like train one for I in range, then length should be test. Okay, so for length, training time comma length should be tested. Press enter. Okay, this is the training and this for the testing. 792 rows and here 55 rows in testing. So LR underscore LR means linear regression. Let me make it capital. Train equals to make a copy LR underscore test equals to test copy dot copy. Then LR, okay, so LR train time equals to train time. Okay, and LR underscore test time equals to test time. Okay, underscore is there. Yeah. So here I will write LR equals to linear regression dot fit to the model was LR train, and for the time LR LR underscore train price values. Linear regression is not defined. Okay, my bad. L should be capital. Yeah. So now see the graph. So test underscore prediction underscore model 1 equals to LR dot predict LR underscore test time lar underscore test cost equals to test underscore predictions score model 1. Okay, let's create the graph figure size should be to 14,6. plt dot plot train price comma label should be train. Okay, then plot plt dot plot test price label equals to test. plt dot plot then lr train or tests forecast label equals to regression on time. Okay, regression on time then again plt dot legend loc equals to best plt dot grid enter. Okay, here I have to write predict loading. One more error. Price. Just price. Okay, is the price. So here you can see regression on time test data is this green one and this training data and the testing data. Okay, let's find the map now. So for this, we'll write here def map actual comma prediction then return count p dot mean abs actual prediction actual by 100 comma 2. Okay, forgot to give the yeah. So for getting the map, you have to write a map underscore model. Let's go test equals to map test price dot values comma test underscore section underscore model 1. Okay, then print is %3 dot 3f. Then here I put percent ape model 1 underscore test comma percentage. Press enter. Test. Okay. Actual is not defined. Map test. Model 1 test. Map test. Values. The test predictions. Model 1. Okay. Here A is small. So map here you can see 29.760. So you are a bit confused, like what is MAP? MAP is a measure of prediction of accuracy of a forecasting method in statistical model. Okay, is a measure of prediction accuracy of forecasting method in statistical method. Okay. And now results equals to PD dot data frame test MAP in percent MAP underscore model 1 comma index equals to regression on time. Okay, then I will print the results. Okay, D should be capital. Module pandas has no attribute data frame. Okay. Model 1 is not defined. Let's go test. Valid scenario, perhaps you got to forget a comma. Colon. Model 1. Okay. Here you can see the test map, regression on time. So let's do with the name now. We have to perform the same pattern. So what I will do, I will write the code and get back to you. Okay. So I'm done with the code. So here you can see I have same pattern, train and test copy. And this is the name forecast on the test data. So this is the line and this is the training and this orange one is testing. The same we have got map like 19.380. Okay. So, and regression is this, the name model. So what we will do, we will create now final model of ours. Okay. And we will forecast, final forecasting we'll do. For that, I have to write final model equals to exponential smoothing. Okay, df comma trend equals to additive comma seasonal equals to additive comma fit smoothing level equals to 0.4 comma smoothing trend equals to 0.3 comma smoothing seasonal equals to 0.6. Okay, press enter. Exponential. So map go final underscore model is equals to map like df price dot values comma final underscore model dot fitted values okay, then print map comma map underscore final underscore model. Okay, so map is 17.24, which is quite good for the final model. Okay, so getting the prediction for the same number of timestamps at the present time in the test data. So I will write here predictions equals to final underscore model dot forecast steps equals to length dot test center. Now we will compute 95% of confidence interval for the predicted value. So it's a TKF equals to PD dot data frames data frame. Then lower CI prediction 1.96 into NP dot standard deviation of final model dot 1. Okay, and comma right here prediction okay, then upper CI prediction plus 1.96 into dot standard deviation the same final model dot to 1. then prediction underscore df dot head. Okay. So this is lower CI prediction and the upper CI. Okay, how much it will forecast. Or now at the end, at the final state, what we will do, we will plot a graph. Okay, forecast graph along with the confidence band. So for that, x is equals to df dot plot label equals to actual comma figure size 16 comma 9 prediction df dot plot ax equals to this comma label underscore df, it's lower CI what I will do instead of this label equals to forecast comma alpha equals to 0.5. Okay, this dot fill between function underscore df dot index comma prediction underscore df lower underscore ci comma prediction underscore df this ci. Okay, then color equals to m comma alpha equals to 0.15. Okay, then axis dot set underscore x label year month. Okay, axis dot set y label is plt dot legend should be location equals to best. Then plt dot grid plt dot show. Okay, this is plt only. Then press enter. Okay, 16,9 positional argument follows keyword argument. Okay, right, 15. Oh, okay, okay. I have to give you another upper CI. I've read upper CI. So here you can see our final model forecasting. So till 2020 it is showing like normal, and after that till 2030, okay, this will be the forecast as per the data. Okay, so here you can see we have the map is 17.24. Okay, then here I did the prediction for the testing data, and here I created the data frames. These are the data frames, lower CI prediction and upper CI, and then I have created the and then I have created the final graph of the forecasting.
There's no better time to train yourself in the exciting field of machine learning. If you're looking for a course that covers everything from the fundamentals to advanced techniques, for that accelerate your career in AI and ML with a comprehensive postgraduate program in AI and machine learning. Gain expertise in machine learning, deep learning, NLP, computer vision, and reinforcement learning. You will receive a prestigious certificate, exclusive alumni membership, and Ask Me Anything sessions by IBM with 3 capstone projects and 25 plus industry projects using real datasets from Twitter, Uber, and more. You will gain practical experience. Masterclasses by Caltech faculty and IBM experts ensure top-notch education. Simplilearn's Job Assist helps you notice by leading companies. This program covers statistics, Python, supervised and unsupervised learning, NLP, neural networks, computer vision, GANs, Keras, TensorFlow, and many more skills. Enroll now and unlock exciting AI and ML opportunities. The course link is mentioned in the description box below.
Sentiment analysis, sometimes known as opinion mining, is a technique used in natural language processing (NLP) to determine the emotional undertone of a document. This is a common method used by organizations to identify and group ideas regarding a certain good, service, or concept. Text is mined for sentiment and subjective information using data mining, machine learning, and artificial intelligence. Tools for sentiment analysis assist businesses in extracting information from unstructured, unorganized language found in online sources like emails, blog posts, support tickets, web chats, forums, and comments. Algorithms use rule-based, automatic, or hybrid technology to replace manual data processing. While automatic systems use machine learning to learn from their data, rule-based systems execute sentiment analysis using predetermined. Lexicon-based rules combining the two methods result in hybrid sentiment analysis. Sentiment analysis or opinion mining can extract the subject, opinion holder, and polarity or the degree of positivity and negative from the text and identify sentiment. Additionally, other scopes including document, paragraph, sentence, and sub-sentence level can be used for sentiment analysis. After seeing what is sentiment analysis, let's discuss some types of sentiment analysis. So the first one is fine-grained sentiment analysis. By segmenting sentiment, each phrase or clause in a sentence is broken down and examined in relationship to the others. Simply said, you can tell who review a product and what topics a person specifically discussed in their feedback. And the second one is emotion detection. Instead of identifying positivity and negativity, emotion detection recognizes particular emotions. Example could include shock, rage, grief, frustration, and happiness. And the third one is intent-based analysis. In addition to identify opinions in a text, the intent-based analysis also identifies behaviors. For instance, a frustrated online comment about changing a battery can motivate customer care to get in touch to address that particular problem. And the last one is expect-based analysis. Collects the precise component that is being mentioned either favorably or unfavorably. For instance, a client may write in a product review that the battery life is too short. The system will then respond that the battery life is the main complaint and not the product as a whole. So after seeing types of sentiment analysis, let's see some application of sentiment analysis. Organization can employ sentiment analysis technologies for a number of purposes such as determining brand popularity, reputation, and awareness at a particular period or over time. Customer service requests into categories. And the next one is monitoring consumer response to new improvements or products. And the fourth one is identifying the demographics or target market. And the fifth one is determining the effectiveness of a marketing effort. So here is one question for you guys. I will give you 1 minute for this. You can comment or you can give answers in chat section, so I can see if the answers given by you are right or wrong. So the question is text analytics also refers to as text mining? I'm repeating again. Is text analytics also refers to as text mining? The options are true or false. So let us know your answer in comment section below or in chat section. So I'm starting timer of 1 minute. Just type your answer in comment section or in chat section. Do let me know your answers. So I'm starting timer of 1 minute. I kindly ask that everyone take part in this to make this live session exciting. So the question is text analytics also refers to as text mining? 35 seconds are left. Do let me know your answers. I kindly ask that everyone take part in this to make the live session exciting. You want 20 seconds left. You can comment or you can give your answer in chat section so I can see if the answers given by you are right or wrong. So time up, guys. So after the allotted time has passed, those who provided the correct response will receive a response, and those who provided the incorrect response will receive one. Okay. Now let's move to a programming part to perform sentiment analysis using Amazon customer dataset. So first we will open command prompt to write command to open Jupyter notebook. So here we will write Jupyter notebook, press enter. Okay, it's Jupyter notebook. So this is the landing page of Jupyter notebook, and here you can select new Python file. It's loading. So this is how the Jupyter UI looks like. So at first we will import some bunch of major libraries of Python which will help us in mathematical functioning. So the first one is NumPy. So first I will write NumPy, import NumPy as NP. NumPy is a Python library used for working with arrays. It also has functions for working in the domain of linear algebra and matrices. It is an open source project and you can use it freely. NumPy stands for numerical Python. So the next one is Pandas. I will write here import Pandas as PD. So Pandas is a software library written for a Python programming language for data manipulation and analysis. In particular, it offers data structures and operation for manipulating numerical tables and time series. After that, we will import NLTK. So the Natural Language Toolkit NLTK is a Python programming environment for creating application for statistical natural language processing NLP for parsing, classification, stemming, tagging and semantic reasoning. It includes text processing libraries. So after that we will import from NLTK dot sentiment dot wader import sentiment density analyzer. Okay, there is no colon. Yeah. So the lexicon and rule-based sentiment analysis tool Wader. Wader means valence aware dictionary and essential reasoning. Is a customized precisely to sentiments expressed on social media. Wader makes use of variety of a sentiment lexicon is a collection of lexical elements such as words that are often classified as either positive or negative depending on their semantic orientation. Weighted not only informs us of the positivity and negativity scores but also of the sentimentality of each score. So the next one is import RE. Python RE module fully supports regular expression similar to those in Perl. If a regular expression, compilation or use error occurs, the RE modules raises the expression RE. Two key functions that are used to manage regular expression will be covered. So RE means regular expressions. So the next one is from xblob import text blob. Okay. So a Python 2 or 3 package called text blob is used to process textual data. It offers a straightforward API to explore typical natural language processing (NLP) tasks like part of speech tagging, noun phrase extraction, sentiment analysis, classification, translation, and more. So the next one is import words from word cloud. A word cloud, commonly refers to as a tag cloud, is an image of words. Popular words and phrases are highlighted using cloud creators depending on their frequency and importance. They give you immediate, straightforward visual insights that can inspire more through analysis. And the next one is import Seaborn as SNS. Yeah. So, like an open source Python library based on Matplotlib is called Seaborn. It is utilized for data exploration and data visualization, where data frames and the pandas library Seaborn function with ease. So the next one is import matplotlib dot pyplot as plt. Okay, yeah, seems good. For Python and its numerical expression NumPy, Matplotlib is a cross-platform data visualization and graphical charting package. As a result, it presents a strong open source substitute for MATLAB. The APIs for Matplotlib allow programmers to incorporate graphs into GUI applications. And the next one is import cufflinks cufflinks as CF. Perfect. Another Python module called cufflink links Plotly with pandas so that charts can be easily created on data frames. In essence, it functions like a plugin. So next inline matplotlib. Matplotlib. So you can enable inline plotting by using the magic function percentage matplotlib inline, which causes the plots and graphs to appear below the cell where your plotting commands are entered. Similar to a Jupyter notebook, it offers backend interactivity in front ends. So next we will import what you can like. We can import, okay, from plotly dot offline import init underscore notebook underscore mode comma plot. Okay. Init underscore notebook mode true. Okay, it's through, yeah, ef dot go underscore offline. So yeah, in order to display the plot inside the notebook, you need to initiate plotly notebook mode as follows, like this. Keep rest of the script as it is like it and run the notebook cell by pressing, you can shift plus enter. Graph will be displayed offline inside the notebook. So basically it is used for the offline graphing, you can say. Okay. So next we will import from plotly dot subplots. Subplots are important. Import make underscore subplot. Okay, yeah. The non-leaf nodes in this figure schema are represented by a hierarchy of Python classes that was automatically constructed and is found in the plotly.graph objects, which is normally imported as Go. These class instances are referred to as graph object, the plotly defined fundamental classes. Okay. So here we will import some like warnings, you can say, like to get not error. So we will import, let me give a line space, import warning, warnings, yeah, warnings dot filter warning ignore warnings dot warn, and this like will not show, and let me add something, pd dot set option display dot max underscore columns. Okay, import words from word cloud. Okay, there is an error, let me check what's the error. Okay, import this word cloud from word cloud. It's capital and W is also capital. Here W will be capital. Let it put it small only. From word cloud. Okay, my bad. Here word from word cloud, import word cloud. Okay, yeah, seems good. So where were we? Yeah, in warnings. Despite the notification, the software continues to execute. To display warning messages, utilize the warn found in the warning module. The Python built-in class expression is a subclass of the warning module, which is used to display warning messages, import warnings. Okay, for seeing full data, every single columns like, okay, there is error cborn, no module as cborn, so s will be small. Got it? Okay, inline is only like something like that. Inline. Okay, any error now? I guess no error. Okay. Yeah, for seeing full data like every single columns of PD. So here we are using this pd.set option. So we can use for it. So moving forward, let's import dataset. So for importing dataset, we will write here uh, like df equals to pd dot read csv. Okay, here dataset name. Yeah. So you can download dataset from the description box below. So no worries for that. So let me run this. Okay. So like here is PD is for pandas library. Read is used for reading the dataset from the machine, and CSV is used for the type of file which you want to read. So let's see our data. So here I will write df dot head. Yeah. So if you want to see top 5 rows of your data set, you can use head. And if you want to see 5 rows of your data set, you can use tail instead of head, this one. Okay, so this is our data set with only 5 rows. If you want to see full data set, you can like from starting from 0 and ending it 4914 rows. Okay, 4915 rows and 12 columns. Right. So let me give something like this for the better visual. Yeah. Okay. So moving ahead, let's sort this Wilson bound column to ascending order for better analysis. So I am talking about this Wilson lower bound column. This one. For it's not 000 like in all the rows. So let me show you. So here you have to write like df equals to df dot sort values Wilson, spelling should be correct, lower bound. I will make it to ascending order, descending order. So bf dot drop named. Okay. Unnamed colon 0. Okay, in place equals to true, comma axis equals to 1. Okay, so let's see our data. So here you can see the data is sorted in as ascending order. Okay. So the provided row or column is eliminated via the drop function. The drop method eliminates the specified column when the column axis is specified. The drop method eliminates the designated row when the row axis is supplied. Okay. So I hope you guys understand till here. If you have any queries or like any queries regarding any code or there is something question till here, just put as in comments. Our team will shortly provide you the correct solution. Okay. So moving forward, let's make a function for missing values. So, okay. So I will write here like df missing values analysis. Okay, it's def for function. We use def. Yeah, def columns was to col for columns for col in df dot columns if df column is null dot sum is greater than 0 underscore miss equals to df underscore columns underscore is null dot sum what we dot sort underscore values like in ascending equals to true. Okay. Like sum be like this and this. That's fine, I guess. Yeah. So here I will write ratio underscore equals to df na underscore columns underscore dot is null. Same thing that sum divided by f dot shape level 100 dot sort values sending equals to true. Fine. Okay. Sum is okay, and the df part. Let sort values equals to sending equals to true. Fine. So here we will write missing underscore df equals to pd dot concat p dot round ratio underscore comma 2. Yeah, perfect. Here axis will be 1. Okay. Is equals to I will give like total where I will write missing values okay comma ratio thing underscore df equals to pd dot data frame underscore df. Okay, so let me return thing df. Let me create one more function for like check data frame. So df check underscore data frame. Okay, it equals to 5 comma tail equals to 5. So here I will write print shape. Okay, dot center 2 comma again for rows print rows curly braces. Okay, dot format dot format yeah, dot shape 0. So for columns print dot shape print types like of types of data dot center same as like that 82 comma int df dot d types center. Just printing this is like you will see, don't worry, just stay with me, you will see the beautiful result. Okay, print values print missing values analysis analysis like df. Okay, then again duplicated values, like there are many, how many duplicated values are there. So dot same for the center 3 comma again this one print f dot duplicated. Don't worry, I will explain you like line by line. Just stay with me. Let me write the whole code. First, print tiles. Like I'm printing multiple of things. So just be with me. Dot register 82, comma ef dot quantile 2.05, comma 1. Okay. Check data frame. I'm hoping like there will be no error. Yeah. So you can see now like multiple information regarding dataset is printed. So this shape is for like how many rows and columns present in the dataset. Like in types, you can say like every column type like object, int 64, float 64, and many more are like present. So like you can see review text is like object and day difference is int 64 and Wilson lower bound is float 64. Okay. So total missing values. So total missing values are like one from here and one from here. Like one in from reviewer name and other is from reviewer text. And like there is no duplicated values in our dataset. And here you can see. So like after that quantiles. A quantile defines a particular part of the dataset. That is, a quantile determines how many values in the distribution are above or below a certain limit. Special quantiles are the like quartile quarter, and you can say quintile, that the fifth one, and the percentile which is from 100th. Okay, so quantile is for like quarter, or the you can say the fifth one. So why I wrote this 83, 82, and this for this purpose, for making this something look cool. That is why. Okay, and yeah. So moving forward, let's see unique values and in each column. Okay, so I will write def check class data frame unique f equals to pd dot data frame variable variable data frame dot columns comma classes colon data frame I will write like n unique UUE or I in data frame dot columns like n unique for df equals to dot sort values classes comma ascending equals to false. Okay, n unique underscore df equals to n unique ef dot reset index drop equals to true. So return n unique QUE n unique underscore df check underscore class which one df. So let me run this first. Yeah, it's running, you can see here. Okay, there is an error classes. Okay, check class df. Is saying that this is okay. C is capital, C is small. Let me run now. Yeah. So here you can see the every column having unique values are sorted in descending order. Like review tags have like more unique values. So it come first, and then reviewer name, reviewer time, day difference, Wilson lower bound, score average, then goes to overall. Okay. Moving forward, let's do some categorical variable analysis for overall. Yes, so this will be like amazing. Something amazing is going to be happen. So constants equals to, so I'm giving here like some color values. So B34 D22 EB00C. Okay, so you can change, you can like write whatever you want color. Hashtag, oh I didn't write hashtag here. Hashtag 3, come on, 1 F C. Hashtag 0C92 EB. EB 0 C and then D you like 5, right? Okay, so DEF, let's make function. Okay, small DEF categorical variable memory. Okay, DF comma column. Okay, categorical variable summary. Yeah, perfect. So let's make some figures. So make subplots, plots, rows equals to 1 comma calls equals to 2. Let me write from here like subplot titles equals to count plot like one for percentage. Okay. So specs equals to a like type colon y, okay, comma same type colon here domain. Figure dot add and then trace go dot bar, like one bar and one that pie chart. Okay, y equals to df columns column name value values dot to list for x you can like string, yeah, str I for I in, yeah, column name dot value dot counts index, text equals to df column name dot value counts and then bracket dot values dot to list. Okay, so for text font the size should be 14 is enough, I guess. So column underscore name x position. So I'm doing for like making chart, so stay with me to see that amazing chart. Okay, so show legend to dict color equals to constants. So these are the like colors, so I'm giving here value like variable name constants comma line equals to line. hashtag db e6ec, comma to 1. Okay, small. Okay, let me just like go over through everything is correct or not for the column name, value counts index. Yeah, it's fine. Text equals to df column name dot value counts dot values to list. Okay, text font equals to text size, then okay, 14 size is enough. Name equals to column name, and text position equals to auto, and show legend false, and mark dict like color equals to constant. Okay, fine. Line equals to color, and this, yeah, this. Okay, cool. Row equals to 1 comma column equals to 1. Seems good. Like for pie chart, we will make figure dot add. So this is done for the line chart, not line chart, that bar chart, and this I'm doing for the pie chart. Okay, trace go dot pie f columns, column name, value, count, is values equals to df, again that column name, dot value count, counts, and dot values text font equals to text size. I will prefer 18 is enough. Exposition equals to like auto is fine. So legend equals to no need of legend, false. Name equals to column name, value, column name, equals to like text, then colors equals to constants, equals to 1 column equals to 2, like in second. Okay, you will see and you will get to know, don't worry. So figure dot update layout title equals to text column 0.9 0.5 comma x or should be on center. Then y anchor be on top. Let equals to totally a I plot figure. Let me run this. Okay, like okay, call equals to 2. Now let's see the chart of like column overall one. So we will write here categorical, okay, variable summary, and then data frame name df comma overall. Okay, let's run this. Okay, it's loading here. It's loading. Yeah, you can see this is our bar plot and this is our pie chart. So like this is overall, from overall you can say that column. So like percentage bar and that bar plot. So this is how our like pie chart and bar chart looks like. I hope you guys understand till here. If you have any questions or any query regarding any code, okay, like any code, any sort of code, so just put as in comments. Our team will shortly provide you the correct solution. So moving forward, our goal is to rank the comments by the sentiment analysis, so we don't get hung up on the other details. I have sorted this dataset according to certain rules before. So moving forward, we want to clean our data. So let's see the sample data for cleaning. So df dot review text, okay, dot head. Let me run this. So this is our sample data looks like. So let's see like data, full data for this. Okay, let me see for this, I guess. Okay. For like any particular row, you can say I can take. Okay. So I will write review underscore example equals to df dot review text. I will take a random 2031, I guess. Okay, so review underscore example. So this is like at 2031. there is one review text. Okay, so in that the whole data is here, like so my lovely wife bought me a Samsung Galaxy Tab for father, this, like to find the exact model number. This is a long, comment. I got the this. It works like a charm. Okay, so after seeing this data, what we're gonna do is, like, we will clean it from punctuation and numbers using regex. Regex what? A regular expression. Okay, so here I will write review underscore example. Okay, equals to re dot sub, and what I will do is, okay, I will explain. Don't worry. Small a to capital A to Z. Okay, comma, then space, comma, review underscore example at, sorry, yeah, review example. So here we used re for regular expression. Okay, and so all the punctuation and numbers are removed from particular data. So let me check first. Okay, this A to Z, then A to Z. Okay, fine. So, like, all the punctuation and numbers are removed from particular data. I will now convert the text to all lowercase. Our machine learning algorithm recognize words that start with the capital letters as a different word, and we will convert them to lowercase. So thus our machine learning algorithm will not perceive words that start with a capital letter as a different word. So what I will do is, here I will write review sample equals to review, again example dot lower. I will split. Okay, your example. So here you can see, we have converted all the words in the lowercase letter by using lower function. And why they are coming in new lines? Because we are splitting them using split function. Okay, if you see only did lowercase for single row, like we did for the, like, 20, I guess 2031. Okay, yeah. So let's make all rows same in lowercase. So I will write here rt equals to lambda x. Cool. Str dr x for df view text is capital text df view text text. Okay, equals to df view yeah dot lower df dot head. See, all the data is in like lowercase. So I printed just top 10 rows, and like in reviews text column, all the are in the lowercase now. So I hope you guys understand till here. If you have any question or any query regarding any code or question till here, like any code, just put as in comments. Our team will shortly provide you the correct solution. And if you need this full code, you can comment down below. Okay. So now the time is come to do sentiment analysis because all the data is sorted. So what will I write here? Let me do it little bit up. Yeah. So I will write from from Vader sentiment dot Vader sentiment port sentiment intensity analyzer. Okay. F polarity subjectivity. Subjectivity equals to df review text dot apply lambda text pd dot series. Okay, here you write text blob, then again text dot like sentiment let me run for loop for index comma row in df review text dot item items for you sentiment intensity analyzer dot polarity scores row negative score for neutral. I will write score. Okay, for positive if this is something crazy, if negative is greater than positive, then df dot location index comma sentiment equals to negative. Negative. Okay, then else if positive is greater than negative, then in this case df dot log index, comma, sentiment equals to positive P capital. Else ef dot loc index sentiment equals to neutral. S- Okay, so like this is for sentiment analysis, and text blob, this thing like text blob, this blob, okay, it's blob. A text blob will return polarity and subjectivity. Polarity indicates your mood, that is whether it is positive or negative or neutral. It returns a value between 0 and 1. The closer to 1, the more positive, and the closer to 0 is more negative. Okay, let me run this. It will take a little bit time because this okay, it is getting error. Like module panda has no attribute series. Okay, which one? Text box. Text. Yeah, sentiment. Okay, here, what is the thing? S is capital. Let me run now. It is executing. Like wait for a while. Wait. So it will take time to run because of this sentiment intensity analyzer. It take times. Again, sentiment intensity analyzer. Okay, spelling mistake again. Why index? Index is not defined. Okay, sorry again. Index. It will run, I guess, because everything seems good. Negative, positive, and this else. Still loading, so I have to wait like for like 2 minutes more, I guess. Still loading, guys. It take time. Sentiment intensity analyzer. So let me tell you again, sentiment analysis, like this text blob will return polarity and subjectivity. So polarity indicates your mood, that is whether it is positive, it is negative, or it will be neutral. It returns a value between 0 and 1. The closer to 1, the more positive. The closer to 0, more negative. Okay, I guess it's still running. So it will take time. So let me write code for that. 20 interpretation. I repeat. Moving forward, let's identify the 20 interpretation. Now we can include the positive, negative, and neutral status of the comment. Okay. Then df okay, sentiment equals to positive thought leaves Wilson, lower. Ascending equals to false. Okay. Dot head, it's 5. If I will run, it may give error to me because it's still running here, it's still loading. So let let me write code for that unbalanced data problem. So like we will category that data into positive, negative, and neutral. Okay, so categorical variable summary df element. Yeah, it came like this because of this. Wait, I will tell you. Yeah. So here you can see the pie chart distributed in negative, positive, and neutral emotions. Okay. Or you can say ratings. And here you can see the bar chart also.
There's no better time to train yourself in the exciting field of machine learning. If you're looking for a course that covers everything from the fundamentals to advanced techniques, for that accelerate your career in AI and ML with a comprehensive postgraduate program in AI and machine learning. Gain expertise in machine learning, deep learning, NLP, computer vision, and reinforcement learning. You will receive a prestigious certificate, exclusive alumni membership, and Ask Me Anything sessions by IBM with 3 capstone projects and 25 plus industry projects using real datasets from Twitter, Uber, and more. You will gain practical experience. Master classes by Caltech faculty and IBM experts ensure top-notch education. Simplilearn's Job Assist helps you notice by leading companies. This program covers statistics, Python, supervised and unsupervised learning, NLP, neural networks, computer vision, GANs, Keras, TensorFlow, and many more skills. Enroll now and unlock exciting AI and ML opportunities. The course link is mentioned in the description box below.
So, what is Myers-Briggs personality prediction? To better understand personality characteristics in the broader population, the MBTI examination was created. Although there is no such thing as better or worse personality preference, the MBTI examination can aid individuals in understanding their strength, weakness, and potential difference from the others. So there are some types of MBTI indicator. There is no best or better personality type than another. It is not a device made to search for abnormalities and dysfunction. Its sole purpose is to assist you in discovering more about yourself. So there are 4 separate scales make up the actual questionnaire. First is extrovert and introversion. Second is sensing and intuition. Third is thinking and feeling. Fourth is judging and perceiving. So based in these four, there are some types. So there are 16 types: ISTJ, ISTP, ISFJ, ISFP, ISFJ, like these ENFP, ENFJ, ENTP, and ENTJ. So what is meaning of ISTJ? I means introversion, S means sensing, T means thinking, and J means judging, like these. So dear learners, if you want to upskill your AI and machine learning skills, so give yourself a chance to simply learn a professional certificate program in AI and machine learning, which comes with completion certificate and in-depth knowledge of AI and machine learning. Check this course detail from the description box below. So now let's move to a programming part. So first we will open command prompt.
First, we will open command prompt. So here I will write Jupyter. Enter. So this is landing page of Jupyter Notebook. So here I will go new Python file. So this is how the Python kernels look like. So here I will change name be Myers-Briggs personality prediction. Okay. Yeah. So at first we will import some major libraries of Python which will help us analyzing the data. So here I will write plotlib. Import re import numpy as np, import pandas as pd, import matplotlib pyplot as plt, import seaborn sns, then import plotly dot offline as okay, then here import plotly dot graph underscore vgs object as go, here import plotly dot tools as tls, from bs4 import beautiful. Then here I will write from sklearn dot model underscore selection port cross underscore validate. Okay. Then again, let me copy from here till import. Then here I will import stratified. So yes, so here I will import sklearn dot linear model port logistic regression. So from this we'll write here sklearn. Okay, learn dot model underscore selection port learn dot port
extra fees. Okay, so here I will write mode from learn dot decomposition code truncated okay. So here I will write from sklearn dot here underscore section text import okay. Then from sklearn dot pipeline code pipeline from sklearn dot namespace multinomial binomial nb then py dot init underscore book underscore connected is equals to Py is a Python library used for working with arrays. It also has a function for working with domain of linear algebra and matrices. It is open source project and you can use it freely. NumPy stands for numerical Python. So Panda is a software library written for the Pandas programming language for data manipulation and analysis. In particular, it offers data structure and operation for manipulating numerical tables and time series. An open source Python library based on matplotlib is called Seaborn. It is utilized for data exploration and data visualization. With data frames and the pandas library, Seaborn function with ease. Matplotlib. For Python and its numerical extension NumPy, Matplotlib is a cross-platform data visualization and graphical charting project. As a result, it presents a strong open source substitute for MATLAB. The APIs for Matplotlib allows programmers to incorporate graphs into GUI application. Beautiful Soup. Python software called Beautiful Soup is called parse HTML and XML text. For process pages, it generates a parse tree that can be used to extract HTML data for web scraping. Pipeline. The pipeline goal is to put together several phases that can be cross-validated while using different parameters. So moving forward, let's import some different data set. You can download these data set from the description box below. So here I will write train equals to pd dot read underscore csv. And then here pti dot one dot and second one is equals to pd dot read underscore users csv. Okay, then there is one more equals to pd dot read CSV, then forum, messages, so here I will write MBTI equals to I, the key value. So I'm writing a key value. Version, comma, then same, version, then intuitions, comma, capital, comma, one T, then T means thinking, F means feeling, J, J means judging, yeah, still loading, so it's still loading for data set. Three different data set, MBTI, one CSV, users, and forum messages. You can download these data set from the description box below. Okay. Or you can find this link for the drive link. So these are like large data sets, so it will take some time. Importing this data set is done. So let's use shape function to see how many rows columns are present in train data set. So here I will write train dot shape. As you can see, 8675 rows and 2 columns. Okay, so let's move forward. So we to take a class, I repeat. So we take a look to classes. So it look like very unbalanced data set. So here I will write cnt dot rs equals to train type value counts. So here I will have plot dot figure size is to 12 comma 4. So SNS dot bar plot ent rs dot values comma is to 0.8. So plot dot y label and says size label types, different types, then font size 13 lt dot show. Okay, while so here you can, as you can see, different types of personality: INFJ, INFJ, INTP, INTJ, so on. Okay, so these are number of occurrence and the types. So moving forward, let's group user ID and messages. So I will write here better visual. Yeah, so here I will write PS message message dot fill NA PS dot underscore join equals to PS dot group by post write message dot get. Here I will write the call join column at loading. Moving forward, let's check accuracy with different classifiers and models. So first we will check with extra tree classifier. Okay. So for that, we'll write here like etc extra tree classifier equals to trees classifier plan underscore estimators equals to 20 comma max equals to 4 tops equals to minus. So here I will write TF IDF equals to, let me copy it from here, ngram underscore range equals to comma 1 then upwards. SVD equals created components model equals to pipeline TFI by TFI will write here that here I will write k folds here I am doing because of spelling mistakes and it's is to 5 comma shuffle to and here I will write np dot, okay sorry, yeah, np dot random dot read scoring issue accuracy log
Oh, in then here type write scoring jobs equals to -1. It is still loading. Okay. Loading. So now we will print. So here I will write print TV colon 0.4 F. Here I will write plus slash minus colon 0.4 F. Dot b dot mean result position results accuracy copy it all and check accordingly. So now F1 score, for F1 score we will write here F1 same. Okay, then here you have to write np dot mean and result accuracy. Here you will write test F1 underscore micro. Okay, then same here. Test F1 again for the negative loss. Right, log good
Here I will write negative underscore log underscore loss. Underscore log underscore run it. So wait, let me make it. So here you can see the accuracy, and it is not that good with XRT classifier, as the dataset is very unbalanced. F1 score is a better metric than accuracy. So we will check with some alternative models. So let's try if we can find a more accuracy with another model, although we haven't got a lot of data. So here I will write df clean text. Okay. So here I will write text equals to beautiful. So ml. Read dot sub, then write r comma okay, then text equals to re dot sub, then http slash url. Okay, done text. So here I will write train post to train post dot apply coding. Okay, done. So let's check accuracy with first Naïve Bayes. Okay. Oh, I'm done with the code because the code are mostly same. So I just copied it from my documents. Okay, so let me enter. So here you can see the accuracy is far better than this extra tree classifier. Okay, so we will check from one more. Let's check for logistic regression. So let me write the code first, then I will get back to you. I'm done with the code. Let's see the accuracy of logistic regression. So let me press enter. Loading, you can see. Yeah. So accuracy is far good than the both. So is this model overfitting? Could we have a better model with more data? Let's see the learning curve. Okay. So here I will write train underscore sizes comma train underscore scores comma test. So learning underscore curve done. Post train type folds jobs equals to putting equals to here I will write f1 underscore train sizes equals to np dot space 1 comma 1 state to 1 and press enter. Okay, it is k folds. This is dispatcher. So for the learning curve, it is a long code. So let me write it for you. Okay, and it's still loading. I don't know why. So I'm done with the code. So let me run it. Now let's see the curve. So for that, let's set import. No, we don't. Here I will write plot learning curve train posts comma train type train and sizes train underscore scores comma test underscore scores comma y point, point zero figure size should be sorry not 15 15 comma 6. Okay. ELT dot show So here, as you can see, training score, cross validation score, learning graph. So it's look like that with more data, the more model gets better and better. So that is not overfitting. So what we will do, so moving forward, let's see Kaggle user personality. Let's apply our model to whole Kaggle user comments. Let's see what is the most common Kaggle user personality. So for that, I will write here ps underscore join, then comments equals to ps underscore join message dot apply text here I will write model underscore learning dot fit train post train type all equals to model fit join it's loading here. So moving forward, what we will do, let's create a bar graph to see Kaggle user personality. Okay, loading. It will show the warning, something like. So let me write the code for the bar graph. Okay, it's a long code, so I will write first, then I will get back to you. So I wrote the code. So let me run it and see the personality. So here you can see ESFP is the most used personality. So let's see the count, personality count, percentage count. For that, I will write here underscore df percent to friction underscore df count and underscore df, then again count. Okay. Here I will write prediction underscore df description personality apply the x join PTI. Right one. Test. Okay. Then, so here you can see the percentage count for every personality. Okay, with description, extroversion, sensing, feeling, perceiving, ESF. So finally, at the end, we will see the personality distribution using pie chart. Okay, so here I will write labels equals to prediction underscore TF. I will write description. Okay, sizes equals to prediction underscore TF percent. Trace equals to go dot I labels equals to labels comma values equals to sizes. Layout should be layout equals to go dot layout title equals to Kaggle user personalities data equals to trace that o dot the data equals to data divide dot iplot. Okay, let me run it. Let me run it. So here you can see the pie chart. So like most 50% is ESFP. Okay, then 23 is introversion intuition, then so on. Okay, so everything is written here and in every color. So apparently the most common Kaggle user personality is ESFP, this 50.6%. Okay, so extroversion, sensing, feeling, perceiving. But we are getting this conclusion based on users' comment. It is reasonable to think that users who participate more writing comments are more extrovert. Our sample data don't come from the Kaggle users population. It is only based on the comments. OpenCV, Open Source Computer Vision Library, is an open source computer vision and machine learning software library. It is written in C++ but has a binding for various programming languages such as Python, Java, MATLAB. OpenCV was designed with the goal of providing a common infrastructure for computer vision applications and to accelerate the use of machine learning perception in commercial products. OpenCV is widely used in a variety of industries, including robotics, automotive, and healthcare. It's supported by a large community of developers, researchers, and users who contribute to its development and provide support to its users. It is supported by a large community of developers, researchers, and users who contribute to its development and provide support to its users. So now let's see what is object detection. Object detection is a computer vision technology that involves identifying and localizing the object of interest within an image or a video. It is a challenging task as it involves not only recognizing the presence of an object but also detecting its precise location and size within the image or video. Object detection algorithm typically use deep learning techniques such as CNN to analyze the image or video for identifying the objects. These algorithms can also determine the boundaries of the object by drawing a bounding box around them. So after understanding what is object detection, now let's move on to the programming part. So this is a kernel, Python kernel. Here we will change this name. So here I will write object detection demo. Okay. So first we will import some major library like OpenCV. So for that we will write import CV2, and the next one is import matplotlib .pyplot as PLT. So why we are writing PLT? Because we can't write again and again matplotlib.pyplot. Okay, it's a long one, so we can write a short form PLT. So yeah, so let's run this. So what is OpenCV? OpenCV is an open source software library for computer vision and machine learning. The OpenCV full form is Open Source Computer Vision Library. It was created to provide a shared infrastructure for application for computer vision and to speed up the use of machine learning perception in consumer products. OpenCV as a BSD licensed software make it simple for companies to use and change the code. Okay, so there are some predefined packages and libraries that make our life simple, and OpenCV is one of them. Second one is Matplotlib. Matplotlib is a easy to use and an amazing visualize library in Python. It is built on NumPy array and designed to work with broader SciPy stack and consists of several plots like line, bar, scatter, histogram, and many others. Okay, so moving forward, we will import our file. Okay, so here I will write config file equals to, this is our file name, ssd underscore mobilenet v3 large coco 22 14.pb. Okay, so you can find this file on the description box below. Frozen model equals to, I'll explain you every single thing. Inference graph.pb. Okay, so let me run it first. MobileNet. As a name applied, the MobileNet model is designed to use in mobile application, and it's TensorFlow first mobile computer vision model. MobileNet use depth-wise separable convolutions. It significantly reduces the numbers of parameters when compared to the network with regular convolutions with the same depth in the nets. This results in the lightweight of the deep neural network. So MobileNet is a class of CNN that was open source by Google, and therefore this gives us an excellent starting point for training our classifiers that are insanely small and insanely fast. Okay, so what is this large COCO? This is a dataset, COCO dataset. Like with applications such as object detection, segmentation, and captioning, the COCO dataset is widely understood by the state-of-the-art of neural network. Its versatility and the multi-purpose scene variations serve best to train a computer vision model and benchmark its performance. Okay, so what is COCO? The Common Object in Context is one of the most popular large-scale labeled images dataset available for public use. It represents a handful of objects we encounter on a daily basis and contains image annotations in 80 categories. I will show you the categories I have with over 1.5 million object instances. Okay, so modern day AI driven solutions are still not capable of producing absolute accuracy in result, which comes down to the fact that COCO dataset is a major benchmark for CV to train, test, and polish refined models for faster scaling of the annotation pipeline. On the top of that, the COCO dataset is a supplement to transfer learning where the data used for one model serves as a starting point for the another. So what is frozen inference graph? Like freezing is the process to identify and save all the required graphs like weights and many others in a single file that you can usually use. A typical TensorFlow model contains 4 files and this contains a complete graph. Okay, so forward, let's create one model. Here I will write model equals to cv2.dnn model frozen model and then config file. So here I am giving the parameters, two parameters like frozen model and config file. Let's go here. Yeah, we run it first. Okay, there is error. Return error. Okay, so error is cv2.dnn detection model return as result with an exception set. The question comes, what is the meaning of detection model or DNN detection model? So this class represents a high-level API for object detection networks. Detection models allows to set parameters for pre-processing input image. Detection model creates net from file and with trained weights and config, sets its processing input, runs forward pass and return the result detection. Okay, moving forward, let's set the class labels. Okay, class labels. File name also labels.txt. I will put this file on the description box below. You can download from there. Open file name. Pass labels. Strip. So here I created one array of name class labels. So this is the file name. What I'm doing, I'm putting this label file into this class labels. Okay. So here, if I will print class labels, so these are the 80 categories in the COCO dataset. Okay, this person, bicycle, car, motorbike, aeroplane, bus, train, these all are the 80 categories. I will put this file label.txt in the description box below. You can download from there. Okay, fine. So let's print the length of the COCO dataset, or you can see class labels. This is 80. As you can see, I have already told you the length will be 80. So here let's set this some model input size, scaling, mean and all. So I will write here model dot set input size 320 comma 320 model dot set input scale 1.0 slash 127.5. Okay, I will explain you, don't worry. Model dot set input mean 127.5 comma 127.5 comma 127.5. Okay, and then model dot set input swap b will be, what is set input size? Okay, so set input size is a size of new frame, the shape of the new blob less than 0. Okay, so this is the size of the new frame. The second one is set input scale. So set input scale is a scale factor of the value for the frame, or you can say the parameter will be the multiplier of the frame values, or you can say multiplier for the frame values. Okay, so set input mean, so it set the mean value for the frame in which the photo will come, the video will come, or my webcam will come. So it set the mean value for the frame, or the for parameters mean is scalar with the mean values which are subtracted from the channels, you can say. And the last one is set input swap RB. So it set the flag swap RB for the every frame. We don't have to put every time a single frame for a particular image. It will be set the true for the all the images. Okay. So parameters will be swap RB flag, which indicates the swap first and the last channels. So moving forward, we will port one image. Read boy.jpg dot I am show. So this is the size of 320 by 320. Okay, so first thing is you can download the random picture from the Google. I took from Google itself. So now what we will do, we will set the class index, the confidence value, the B box. B box is the boundary box which I will create for that particular person, cycle, motorbike, and the car. Okay, B equals to model get the confidence threshold. Threshold is used for if my model will confirm it's the particular image which is detecting is correct, it will print the name. Okay. So let me print class index is coming 1 2 3 4. Okay, so 1 means person, 2 means bicycle, 3 means car, and 4 means motorbike. This is the class index for particular label. What I will do, I will print the boxes font scale equals to 3 and the font equals to cv2 dot font Hershey plain for class index and the confidence and the boxes and x dot pattern confidence pattern box, the boundary box. Okay, then I will write here cv2 dot rectangle to make the rectangle, set the image and the boxes 5 comma 0 comma 0. This is the color of the box and this will be the thickness. Okay, then I will write cv2 dot put text, image, then class labels. I will write class index -1, because always index start with 0, that's why. And the box is 0 and comma boxes 1 body, okay, font, comma scale, so font scale color equals to, this will be the text color 0, 255, 0, and the thickness, so 3. Let me run it. No error. Okay, now plt dot I am show, then cv2 dot cvt color, then cvt2 dot color, then bgr to brg. That is why we wrote swap rb equals to true, because every time we will convert bgr to brg, sorry, gb, rgb, so we don't have to write again and again. It will convert all the files into rgb. Okay, run it. Okay, as you can see, the motorbike is coming, bicycle is coming, the person is coming, the car will come, the car is coming. Okay, so it's detecting the right for the image. Now we will do this for the video and for the webcam. We are done with this image one, and then now I will write here. Okay, so this is will do for the video. For the video, I will write here cap equals to capture. You can write any name, so cv2 dot video capture. So you can take any random video. I took this pixels George. You can comment down. Share the link. For app dot is open. So here I will write cap equals to cv2 dot video capture 0, and if not cap dot is open, then raise output error, can't open the video. Can't open the video. Here everything will be the same. Font scale equals to 3. Okay, font equals to cv2 dot font Hershey 10. Okay, so here I will write while true comma frame equals to cap dot read. This is for the reading of the file. The same I will write class index comma confidence comma boundary box equals to model dot detect flame and the confidence threshold equals to 0.55. Okay, everything is the same we did before. So here I will print class index. Okay, so here I will write if and of the class index does not equals to 0, and what to perform is here I have to write for class index comma confidence comma boxes in zip class index dot flatten. Flatten is the layers. Okay, confidence dot flatten box, and if class index is greater than equals to 80, then what to do? Then I will copy from here okay, the same thing I have to write here. So here I will write cv2 dot, I am sure this will be the written in the frame object detection by Simplilearn and frame. So if cv2 dot wait key 2 and 0 the ffx equals to ordq. Okay, then here I will write break. Will you break when it gets into 2? The wait key will be 2. Okay, I will tell you what is the wait key. So here I will write cap dot release and cv2 dot destroy all windows. Okay, so now let me run. Let's see error. There will be error. Okay, CV Python programming language modules. Let me run it again. Are the wait keys. Okay, so video is here. The video is here. As you can see bicycle, the person, the bus, car, traffic light, the person. So our object detection for the video is coming right. Okay, person, okay, person, traffic light, bus. This is how you can do for the video. Okay. So now we will do for the webcam live. So this is for the video. So if we want to do for the webcam, okay, so we need to just change one thing only. We have to change, instead of giving the file, we have to write one here. Okay, the rest will be the same. Got it? So I have to just shut down my webcam. So let me shut down the webcam and get back to you. So as you can see, this is a 320 by 320 box. So this is coming right. Okay, so if I will show this, the mobile phone is coming right now. Okay, so this is how you can do the correct object detection.
There's no better time to train yourself in the exciting field of machine learning. If you're looking for a course that covers everything from the fundamentals to advanced techniques, for that, accelerate your career in AI and ML with a comprehensive postgraduate program in AI and machine learning. Gain expertise in machine learning, deep learning, NLP, computer vision, and reinforcement learning. You will receive a prestigious certificate, exclusive alumni membership, and Ask Me Anything sessions by IBM with 3 capstone projects and 25 plus industry projects using real datasets from Twitter, Uber, and more. You will gain practical experience. Master classes by Caltech faculty and IBM experts ensure top-notch education. Simplilearn's Job Assist helps you notice by leading companies. This program covers statistics, Python, supervised and unsupervised learning, NLP, neural networks, computer vision, GANs, Keras, TensorFlow, and many more skills. Enroll now and unlock exciting AI and ML opportunities. The course link is mentioned in the description box below.
Hello everyone, welcome to this session. I'm Mohan from Simplilearn, and today we'll talk about interview questions for machine learning. Now, this video will probably help you when you're attending interviews for machine learning positions, and the attempt here is to probably consolidate 30 most commonly asked questions and to help you in answering these questions. We tried our best to give you the best possible answers, but of course what is more important here is, rather than the theoretical knowledge, you need to kind of add to the answers or supplement your answers with your own experience. So the responses that we put here are a bit more generic in nature, so that if there are some concepts that you are not clear, this video will help you in kind of getting those concepts cleared up as well. But what is more important is that you need to supplement these responses with your own practical experience. Okay, so with that, let's get started. So one of the first questions that you may face is, what are the different types of machine learning? Now, what is the best way to respond to this? There are 3 types of machine learning. If you read any material, you will always be told there are 3 types of machine learning. But what is important is you would probably be better off emphasizing that there are actually 2 main types of machine learning, which is supervised and unsupervised. And then there is a third type, which is reinforcement learning. So supervised learning is where you have some historical data and then you feed that data to your model to learn. Now, you need to be aware of a keyword that they will be looking for, which is labeled data. Right? So if you just say past data or historical data, the impact may not be so much. You need to emphasize on labeled data. So what is labeled data? Basically, let's say if you're trying to train your model for classification, you need to be aware of, for your existing data, which class each of the observations belong to, right? So that is what is labeling. So it is nothing but a fancy name, you must be already aware, but just make it a point to throw in that keyword labeled, so that will have the right impact. Okay, so that is what is supervised learning, when you have existing labeled data which you then use to train your model. That is known as supervised learning. And unsupervised learning is when you don't have this labeled data. So you have data, it is not labeled. So the system has to figure out a way to do some analysis on this. this. Okay, so that is unsupervised learning. And you can then add a few things like what are the ways of performing supervised learning and unsupervised learning, or what are some of the techniques. So supervised learning, we perform or we do regression and classification, and unsupervised learning we do clustering. Okay? And clustering can be of different types. Similarly, regression can be of different types, but you don't have to probably elaborate so much. If they are asking for just the different types, you can just mention these and just at a very high level. But if they want you to elaborate, give examples, then of course, I think there is a different question for that. We will see that later. Then the third, so we have supervised, then we have unsupervised, and then reinforcement. You need to provide a little bit of information around that as well, because it is sometimes a little difficult to come up with a good definition for reinforcement learning. So you may have to a little bit elaborate on how reinforcement learning works. Right? So reinforcement learning works in such a way that it basically has two parts to it. One is the agent and the environment. And the agent basically is working inside of this environment, and it is given a target that it has to achieve. And every time it is moving in the direction of the target, so the agent basically has to take some action. And every time it takes an action which is moving the agent towards the target, right, towards a goal. A target is nothing but a goal. Okay, then it is rewarded, and every time it is going in a direction where it is away from the goal, then it is punished. So that is the way you can a little bit explain. And this is used primarily, or very, very impactful for teaching the system to learn games and so on. Examples of this are basically used in AlphaGo. You can throw that as an example where AlphaGo used reinforcement learning to actually learn to play the game of Go, and finally it defeated the Go world champion. Right? This much of information that would be good enough. Okay. Then there could be a question on overfitting. So the question could be, what is overfitting and how can you avoid it? So what is overfitting? So let's first try to understand the concept, because sometimes overfitting may be a little difficult to understand. Overfitting is a situation where the model has kind of memorized the data. So this is an equivalent of memorizing the data. So we can draw an analogy so that it becomes easy to explain this. Now let's say you're teaching a child about recognizing some fruits or something like that. Okay? And you're teaching this child about recognizing, let's say, 3 fruits: apples, oranges, and pineapples. Okay, so this is a small child, and for the first time you're teaching the child to recognize fruits. Then, so what will happen? So this is very much like that is your training data set. So what you will do is you will take a basket of fruits which consists of apples, oranges, and pineapples. Okay, and you take this basket to this child, and there may be, let's say, hundreds of these fruits. So you take this basket to this child and keep showing each of this fruit, and then first time obviously the child will not know what it is. So you show an apple and you say, hey, this is apple. Then you show maybe an orange and say this is orange, and so on and so forth. And then again you keep repeating that, right? So till that basket is over. This is basically how training works. In machine learning also, that's how training works. So till the basket is completed, maybe 100 fruits, you keep showing this child. And in the process, what has happened, the child has pretty much memorized these. So even before you finish that basket, right, by the time you are halfway through, the child has learnt about recognizing the apple, orange, and pineapple. Now what will happen after halfway through? Initially you remember it made mistakes in recognizing, but halfway through now it has learned. So every time you show a fruit, it will exactly 100% accurately it will identify. It will say, the child will say this is an apple, this is an orange, and if you show a pineapple, it will say this is a pineapple. Right? So that means it has kind of memorized this data. Now let's say you bring another basket of fruits, and it will have a mix of maybe apples, which were already there in the previous set, but it will also have, in addition to apple, it will probably have a banana or maybe another fruit like a jackfruit. right? So this is an equivalent of your test data set, which the child has not seen before. Some parts of it probably has seen, like the apples it has seen, but this banana and jackfruit it has not seen. So then what will happen? In the first round, which is an equivalent of your training data set, towards the end, it has 100% it was telling you what the fruits are, right? Apple was accurately recognized, orange was accurately recognized, and pineapples were accurately recognized, right? So that is like 100% accuracy. But now when you get a fresh set which were not a part of the original one, what will happen? All the apples maybe it will be able to recognize correctly, but all the others like the jackfruit or the banana will not be recognized by the child. Right? So this is an analogy, this is an equivalent of overfitting. So what has happened during the training process, it is able to recognize or reach 100% accuracy, maybe very high accuracy, okay, and we call that as very low loss, right? So that is the technical term. So the loss is pretty much zero and accuracy is pretty much 100%. Whereas when you use testing, there will be a huge error, which means the loss will be pretty high and therefore the accuracy will be also low. Okay, this is known as overfitting. This is basically a process where training is done. Training process it goes very well, almost reaching 100% accuracy, but while testing, it really drops down. Now, how can you avoid it? So that is the extension of this question. There are multiple ways of avoiding overfitting. There are techniques like what you call regularization. That is the most common technique that is used for avoiding overfitting. And within regularization, there can be a few other subtypes like dropout in case of neural networks and a few other examples. But I think if you give example or if you give regularization as the technique, probably that should be sufficient. So there will be some questions where the interviewer will try to test your fundamentals and your knowledge and depth of knowledge and so on and so forth. And then there will be some questions which are more like trick questions that will be more to stump you. Okay, then the next question is around the methodology. So when we are performing machine learning training, we split the data into training and test, right? So this question is around that. So the question is, what is training set and test set in machine learning model, and how is the split done? So the question can be like that. So in machine learning, when we are trying to train the model, so we have a 3-step process. We train the model and then we test the model, and then once we are satisfied with the test, only then we deploy the model. So what happens in the train and test is that you remember the labeled data. So let's say you have 1,000 records with labeling information. Now, one way of doing it is you use all the 1,000 records for training, and then maybe, right, which means that you have exposed all these 1,000 records during the training process, and then you take a small set of the same data and then you say, okay, I will test it with this. Okay, and then you probably, what will happen, you may get some good results. Right? But there is a flaw there. What is the flaw? This is very similar to human beings. It is like you are showing this model the entire data as a part of training. Okay, so obviously it has become familiar with the entire data. So when you're taking a part of that again and you're saying that I want to test it, obviously you will get good results. So that is not a very accurate way of testing. So that is the reason what we do is we have the label data of this 1,000 records or whatever. We set aside, before starting the training process, we set aside a portion of that data and we call that test set, and the remaining we call as training set, and we use only this for training our model. Now, the training process, remember, is not just about passing one round of this data set. So let's say now your training set has 800 records. It is not just one time you pass this 800 records. What you normally do is you actually, as a part of the training, you may pass this data through the model multiple times. So this 1,000 records may go through the model maybe 10, 15, 20 times till the training is perfect, till the accuracy is high, till the errors are minimized. Okay. Now, Now, so which is fine, which means that that is what is known as the model has seen your data and gets familiar with your data. And now when you bring your test data, what will happen is this is like some new data, because that is where the real test is. Now you have trained the model and now you are testing the model with some data which is kind of new. That is like a situation, like a realistic situation, because when the model is deployed, that is what will happen. It will receive some new data, not the data that it has already seen, right? So this is a realistic test. So you put some new data. So this data which you have set aside is for the model, it is new. And if it is able to accurately predict the values, that means your training has worked. Okay, the model got trained properly. But let's say while you're testing this with this test data, you're getting a lot of errors. That means you need to probably either change your model or retrain with more data and things like that. Now, coming back to the question of how do you split this, what should be the ratio? There is no fixed number. Again, this is like individual preferences. Some people split it into 50-50, 50% test and 50% training. Some people prefer to have a larger amount for training and a smaller amount for test. So they can go by either 60-40 or 70-30, or some people even go with some odd numbers like 65-35 or 63.33 and 33, which is like 1/3 and 2/3. So there is no fixed rule that it has to be something, the ratio has to be this. You can go by your individual preferences. All right, then you may have questions around data handling, data manipulation, or what do you call data management or preparation. So these are all some questions around that area. There is again no one answer, one single good answer to this. It really varies from situation to situation, and depending on what exactly is the problem, what kind of data it is, how critical it is, what kind of data is missing, and what is the type of corruption. So there are a whole lot of things. This is a very generic question, and therefore you need to be a little careful about responding to this as well. So probably have to illustrate this again. If you have experience in doing this kind of work in handling data, you can illustrate with examples saying that I was on one project where I received this kind of data. These were the columns where data was not filled, or these were this many rows where the data was missing. That would be, in fact, a perfect way to respond to this question. But if you don't have that, obviously, you have to provide some good answer. I think it really depends on what exactly the situation is. And there are multiple ways of handling the missing data or corrupt data. Now, let's take a few examples. Now, let's say you have data where some values in some of the columns are missing, and you have pretty much half of your data having these missing values in terms of number of rows. Okay, that could be one situation. Another situation could be that you have records or data missing, but when you do some initial calculation, how many records are corrupt or how many rows or observations, as we call it, has this missing data. Let's assume it is very minimal, like 10%. Okay. Now, between these two cases, how do we? So let's assume that this is not a mission critical situation, and in order to fix this 10% of the data, the effort that is required is much higher, and obviously effort means also time and money, right? So it is not so mission critical, and it is okay to, let's say, get rid of these records. So obviously one of the easiest ways of handling the data part or missing data is remove those records or remove those observations from your analysis. So that is the easiest way to do. But then the downside is, as I said, as in the first case, if let's say 50% of your data is like that, because some column or the other is missing. So it is not like in every place, in every row, the same column is missing, but you have in maybe 10% of the records, column 1 is missing, and another 10% column 2 is missing, another 10% column 3 is missing, and so on and so forth. So it adds up to maybe half of your data set. So you cannot completely remove half of your data set, then the whole purpose is lost. Okay, so then how do you handle? Then you need to come up with ways of filling up this data with some meaningful value, right? That is one way of handling. So when we say meaningful value, what is that meaningful value? Let's say for a particular column, you might want to take a mean value for that column and fill wherever the data is missing, fill up with that mean value, so that when you're doing the calculations, your analysis is not completely way off. So you have values which are not missing, first of all, so your system will work. Number two, these values are not so completely out of whack that your whole analysis goes for a toss, right? There may be situations where if the missing values, instead of putting mean, maybe a good idea to fill it up with the minimum value or with a 0. So, or with a maximum value. Again, as I said, there are so many possibilities. So there is no like one correct answer for this. You need to basically talk around this and illustrate with your experience. As I said, that would be the best. Otherwise, this is how you need to handle this question. Okay, so then the next question can be, how can you choose a classifier based on a training set data size? So again, this is one of those questions where you probably do not have like a one size fits all answer. First of all, you may not, let's say, decide your classifier based on the training set size. Maybe not the best way to decide the type of the classifier. And even if you have to, there are probably some thumb rules which we can use. But then again, every time, so in my opinion, the best way to respond to this question is you need to try out few classifiers irrespective of the size of the data, and you need to then decide on your particular situation which of these classifiers are the right ones. This is a very generic issue, so you will never be able to, just by if somebody defines a problem to you and somebody, even if they show the data to you or tell you what is the data or even the size of the data, I don't think there is a way to really say that yes, this is the classifier that will work here. No, that's not the right way. So you need to still, test it out, get the data, try out a couple of classifiers, and then only you will be in a position to decide which classifier to use. You try out multiple classifiers, see which one gives the best accuracy, and only then you can decide. Then you can have a question around confusion matrix. So the question can be, explain confusion matrix. Right? So confusion matrix, I think the best way to explain it is by taking an example and drawing like a small diagram. Otherwise it can really become tricky. So my suggestion is to take a piece of pen and paper and explain it by drawing a small matrix. And confusion matrix is about to find out, this is used especially in classification learning process, and when you get the results, when our model predicts the results, you compare it with the actual value and try to find out what is the accuracy. Okay, so in this case, let's say this is an example of a confusion matrix, and it is a binary matrix. So you have the actual values, which is the labeled data, right? And which is, so you have how many yes and how many no. So you have that information, and you have the predicted values, how many yes and how many no, right? So the total actual values, the total yes is 12 plus 1, 13, and they are shown here. And the actual value no's are 9 plus 3, 12. Okay, so that is what this information here is. So this is about the actual and this is about the predicted. Similarly, the predicted values, there are yes are 12 plus 3, 15 yeses, and no are 1 plus 9, 10 no's. Okay, so this is the way to look at this confusion matrix. Okay, and out of this, what is the meaning conveyed here? So there are 2 or 3 things that needs to be explained outright. The first thing is, for a model to be accurate, the values across the diagonal should be high, like in this case, right? That is one. Number 2, the total sum of these values is equal to the total observations in the test data set. So in this case, for example, you have 12 plus 3, 15 plus 10, 25. So that means we have 25 observations in our test data set. Okay, so these are the 2 things you need to first explain, that the total sum in this matrix, the numbers, is equal to the size of the test data set, and the diagonal values indicate the accuracy. So by looking at it, you can probably have an idea about, is this an accurate model? Is the model being accurate? If they're all spread out equally in all these 4 boxes, that means probably the accuracy is not very good. Okay. Now, how do you calculate the accuracy itself, right? How do you calculate the accuracy itself? So it is a very simple mathematical calculation. You take sum of the diagonals, right? So in this case, it is 9 plus 12, 21, and divide it by the total. So in this case, what will it be? Let me take a pen. So your diagonal values is equal to, if I say D is equal to 12 plus 9, so that is 21, right? And the total data set is equal to, right, we just calculated, it is 25. So what is your accuracy? It is 21 by, your accuracy is equal to 21 by 25. And this turns out to be about 85%. Right, so this is 85%, so that is our accuracy. Okay, so this is the way you need to explain, draw a diagram, give an example, and maybe it may be a good idea to be prepared with an example so that it becomes easy for you. You don't have to calculate those numbers on the fly, right? So a couple of hints are that you take some numbers which add up to 100. That is always a good idea, so you don't have to really do this complex calculations. So the total value will be 100, and then diagonal values you divide. Once you find the diagonal values, that is equal to your percentage. Okay. All right. So the next question can be a related question about false positive and false negative. So what is false positive and what is false negative? Now, once again, the best way to explain this is using a piece of paper and pen. Otherwise, it will be pretty difficult to explain this. So we use the same example of the confusion matrix, and we can explain that. So a confusion matrix looks somewhat like this, and when we just take it looks somewhat like this, and we continue with the previous example where this is the actual value, this is the predicted value, and in the actual value we have 12 plus 1 13 yeses and 3 plus 9 12 no's, and the predicted values, there are 12 plus 3 15 yeses and 1 plus 9 10 no's. Okay, now in this particular case, which is the false positive, what is a false positive? First of all, the second word, which is positive, okay, is referring to the predicted value. So that means the system has predicted it as a positive, but the real value, so this is what the false comes from, but the real value is not positive. Okay, that is the way you should understand this term, false positive or even false negative. So false positive, so positive is what your system has predicted. So where is that system predicted? This is the one. Positive is what? Yes. So you basically consider this row. Okay, now if you consider this row, so this is all positive values. This entire row is positive values. Okay, now the false positive is the one where the actual value is negative. Predicted value is positive, but the actual value is negative. So this is a false positive, right? And here is a true positive. So the predicted value is positive and the actual value is also positive. Okay, I hope this is making sense. Now let's take a look at what is false negative. False negative. So negative is the second term. That means that is the predicted value that we need to look for. So which are the predicted negative values? This row corresponds to predicted negative values. All right. So this row corresponds to predicted negative values. And what they are asking for? False. So this is the row for predicted negative values, and the actual value is this one, right? This is predicted negative and the actual value is also negative. Therefore, this is a true negative. So the false negative is this one. Predicted is negative, but actual is positive, right? So this is the false negative. So this is the way to explain, and this is the way to look at false positive and false negative. Same way, there can be true positive and true negative as well. So again, positive, the second term you will need to use to identify the predicted row, right? So if we say true positive, we need to take for the predicted part. So predicted positive is here. Okay, and then the first term is for the actual. So true positive. So true in case of actual is yes, right? So true positive is this one. Okay, and then in case of actual, the negative. Now we are talking about, let's say, true negative. True negative. Negative is this one, and the true comes from here. So this is true negative. Right? 9 is true negative. The actual value is also negative and the predicted value is also negative. Okay, so that is the way you need to explain this, the terms false positive, false negative, and true positive, true negative. Then you might have a question like, what are the steps involved in the machine learning process, or what are the 3 steps in the process of developing a machine learning model, right? So it is around the methodology that is applied. So basically, the way you can probably answer in your own words, but the way the model development of the machine learning model happens is like this. So first of all, you try to understand the problem and try to figure out whether it is a classification problem or a regression problem. Based on that, you select a few algorithms and then you start the process of training these models. Okay, so you can either do that, or you can, after due diligence, you can probably decide that there is one particular algorithm which is most suitable. Usually it happens through trial and error process, but at some point you will decide that, okay, this is the model we are going to use. Okay, so in that case, we have the model, algorithm, and the model decided, and then you need to do the process of training the model and testing the model. And this is where, if it is supervised learning, you split your data, the labeled data, into training data set and test data set. And you use the training data set to train your model. And then you use the test data set to check the accuracy, whether it is working fine or not. So you test the model before you actually put it into production, right? So once you test the model, you're satisfied it's working fine, then you go to the next level, which is putting it for production. And then in production, obviously new data will come and the inference happens. So the model is readily available, and only thing that happens is new data comes and the model predicts the values, whether it is regression or classification. Now, so this can be an iterative process. So it is not a straightforward process where you do the training, do the testing, and then you move it to production. No. So during the training and test process, there may be a situation where, because of either overfitting or things like that, the test doesn't go through, which means that you need to put that back into the training process. So that can be an iterative process. Not only that, even if the training and test goes through properly and you deploy the model in production, there can be a situation that the data that actually comes, the real data that comes, with that, this model is failing. So in which case you may have to once again go back to the drawing board. Or initially it will be working fine, but over a period of time, maybe due to the change in the nature of the data, once again the accuracy will deteriorate. So that is again a recursive process. So once in a while, you need to keep checking whether the model is working fine or not. And if required, you need to tweak it and modify it and so on and so forth. So net, this is a continuous process of tweaking the model and testing it and making sure it is up to date. Then you might have question around deep learning. So because deep learning is now associated with AI, artificial intelligence, and so on. So it can be as simple as, what is deep learning? So I think the best way to respond to this could be, deep learning is a part of machine learning. And then obviously the question would be, then what is the difference, right? So deep learning, you need to mention there are two key parts that interviewer will be looking for when you are defining deep learning. So first is, of course, deep learning is a subset of machine learning. So machine learning is still the bigger, let's say, scope, and deep learning is one part of it. So then what exactly is the difference? Deep learning is primarily when we are implementing these our algorithms, or when we are using neural networks for doing our training and classification and regression and all that, right? So when we use neural network, then it is considered as deep learning. And the term deep comes from the fact that you can have several layers of neural networks, and these are called deep neural networks, and therefore the term deep, deep learning. The other difference between machine learning and deep learning, which the interviewer may be wanting to hear, is that in case of machine learning, the feature engineering is done manually. What do we mean by feature engineering? Basically, when we are trying to train our model, we have our training data, right? So we have our training labeled data, and this data has several, let's say if it is a regular table, it has several columns. Now each of these columns actually has information about a feature, right? So if we are trying to predict height, weight, and so on and so forth, so these are all features of human beings. Let's say we have census data and we have all this. So those are the features. Now there may be probably 50 or 100, in some cases there may be 100 such features. Now all of them do not contribute to our model, right? So we as a data scientist, we have to decide whether we should take all of them, all the features, or we should throw away some of them. Because again, if we take all of them, number one, of course, your accuracy will probably get affected, but also there is a computational part. So if you have so many features and then you have so much data, it becomes very tricky. So in case of machine learning, we manually take care of identifying the features that do not contribute to the learning process, and thereby we eliminate those features and so on, right? So this is known as feature engineering, and in machine learning we do that manually. Whereas in deep learning, where we use neural networks, networks, the model will automatically determine which features to use and which to not use, and therefore feature engineering is also done automatically. So this is an explanation. These are two key things probably will add value to your response. All right, so the next question is, what is the difference between, or what are the differences between machine learning and deep learning? So here, this is a quick comparison table between machine learning and deep learning. And in machine learning enables machines to take decisions on their own based on past data. So here we are talking primarily of supervised learning. And it needs only a small amount of data for training, and then works well on low-end systems, so you don't need large machines. And most features need to be identified in advance and manually coded. So basically the feature engineering part is done manually, and the problem is divided into parts and solved individually and then combined. So that is about the machine learning part. In deep learning basically enables machines to take decisions with the help of artificial neural networks. So here in deep learning we use neural nets. So that is the key differentiator between machine learning and deep learning. And usually deep learning involves a large amount of data, and therefore the training also requires, usually the training process requires high-end machines because it needs a lot of computing power. And the machine learning features the feature engineering is done automatically. So the neural networks takes care of doing the feature engineering as well. And in case of deep learning, therefore, it is said that the problem is handled end to end. So this is a quick comparison between machine learning and deep learning in case you have that kind of a question. Then you might get a question around the uses of machine learning or some real life applications of machine learning in modern business. The question may be worded in different ways, but the meaning is how exactly is machine learning used, or actually supervised machine learning. It could be a very specific question around supervised machine learning. So this is like give examples of supervised machine learning, use of supervised machine learning in modern business. So that could be the next question. So there are quite a few examples or quite a few use cases, if you will, for supervised machine learning. The very common one is email spam detection. So you want to train your application or your system to detect between spam and non-spam. So this is a very common business application of supervised machine learning. So how does this work? The way it works is that you obviously have historical data of your emails, and they are categorized as spam and not spam. So that is what is the labeled information. And then you feed this information or all these emails as an input to your model, right? And the model will then get trained to detect which of the emails are to detect which is spam and which is not spam. So that is the training process. And this is supervised machine learning because you have labeled data. You already have emails which are tagged as spam or not spam. And then you use that to train your model, right? So this is one example. Now, there are a few industry-specific applications for supervised machine learning. One of the very common ones is in healthcare diagnostics. In healthcare diagnostics, you have these images and you want to train models to detect whether from a particular image, whether it can find out if the person is sick or not, whether a person has cancer or not. Right? So this is a very good example of supervised machine learning. Here, the way it works is that existing images, it could be X-ray images, it could be MRI or any of these images are available and they are tagged saying that, okay, this X-ray image is defective or the person has an illness, or it could be cancer, whichever illness, right? So it is tagged as defective or clear or good image and defective image, something like that. So we come up with a binary, or it could be multi-class as well, saying that this is defective to 10%, this is 25%, and so on. But let's keep it simple. You can give an example of just a binary classification, that would be good enough. So you can say that in healthcare diagnostics, using image, we need to detect whether a person is ill or whether a person is having cancer or not. So here, the way it works is you feed labeled images and you allow the model to learn from that, so that when new image is fed, it will be able to predict whether this person is having that illness or not, having cancer or not, right? So I think this would be a very good example for supervised machine learning in modern business. All right, then we can have a question like, so we've been talking about supervised and unsupervised, and so there can be a question around semi-supervised machine learning. So what is semi-supervised machine learning? Now, semi-supervised learning, as the name suggests, it falls between supervised learning and unsupervised learning, but for all practical purposes it is considered as a part of supervised learning. And the reason this has come into existence is that in supervised learning, you need labeled data. So all your data for training your model has to be labeled. Now, this is a big problem in many industries or under many situations. Getting the labeled data is not that easy because there's a lot of effort in labeling this data. Let's take an example of the diagnostic images. We can just, let's say, take X-ray images. Now, there are actually millions of X-ray images available all over the world. But the problem is they are not labeled. So their images are there, but whether it is defective or whether it is good, that information is not available along with it, right, in a form that it can be used by a machine, which means that somebody has to take a look at these images, and usually it should be like a doctor, and then say that, okay, yes, this image is clean and this image is cancerous and so on and so forth. Now, that is a huge effort by itself. So this is where semi-supervised learning comes into play. So what happens is there is a large amount of data, maybe a part of it is labeled. Then we try some techniques to label the remaining part of the data so that we get completely labeled data, and then we train our model. So I know this is a little long winding explanation, but unfortunately there is no quick and easy definition for semi-supervised machine learning. This is the only way probably to explain this concept. We may have another question as what are unsupervised machine learning techniques, or what are some of the techniques used for performing unsupervised machine learning? So it can be worded in different ways. So how do we answer this question? So unsupervised learning, you can say that there are two types, clustering and association. And clustering is a technique where similar objects are put together. And there are different ways of finding similar objects. So their characteristics can be measured, and if they have, in most of the characteristics, if they are similar, then they can be put together. This is clustering. Then association, I think the best way to explain association is with an example. In case of association, you try to find out how the items are linked to each other. So for example, if somebody bought maybe a laptop, the person has also purchased a mouse. So this is more in an e-commerce scenario, for example. So you can give this as an example. So people who are buying laptops are also buying the mouse. So that means there is an association between laptops and mouse. Or maybe people who are buying bread are also buying butter. So that is a association that can be created. So this is unsupervised learning, one of the techniques. Okay. All right, then we have very fundamental question. What is the difference between supervised and unsupervised machine learning? So machine learning, these are the two main types of machine learning, supervised and unsupervised. And in case of supervised, and again here, probably the keyword that the person may be wanting to hear is labeled data. Now, very often people say, we have historical data, and if we run it, it is supervised, and if we don't have historical data, yes, but you may have historical data, but if it is not labeled, then you cannot use it for supervised learning. So it's very key to understand that we put in that keyword labeled. Okay. So when we have labeled data for training our model, then we can use supervised learning. And if we do not have labeled data, then we use unsupervised learning. And there are different algorithms available to perform both of these types of trainings. So there can be another question, a little bit more theoretical and conceptual in nature. This is about inductive machine learning and deductive machine learning. So the question can be, what is the difference between inductive machine learning and deductive machine learning, or somewhat in that manner, so that the exact phrase or exact question can vary. They can ask for examples and things like that, but that could be the question. So let's first understand what is inductive and deductive training. Inductive training is induced by somebody. and you can illustrate that with a small example. I think that always helps. So whenever you're doing some explanation, try as much as possible, as I said, to give examples from your work experience or give some analogies, and that will also help a lot in explaining as well, and for the interviewer also to understand. So here we'll take an example, or rather we will use an analogy. So inductive training is when we induce some knowledge or the learning process into a person without the person actually experiencing it. Okay, what can be an example? So we can probably tell the person or show a person a video that fire can burn his finger, or fire can cause damage. So what is happening here? This person has never probably seen a fire or never seen anything getting damaged by fire. But just because he has seen this video, he knows that, okay, fire is dangerous, and if fire can cause damage, right? So this is inductive learning. Compared to that, what is deductive learning? So here you draw conclusion, or the person draws conclusion out of experience. So we will stick to the analogy. So compared to the showing a video, let's assume a person is allowed to play with fire, right? And then he figures out that if he puts his finger, it's burning, or if he throws something into the fire, it burns. So he is learning through experience. So this is known as deductive learning. Okay, so you can have applications or models that can be trained using inductive learning or deductive learning. All right, I think probably that explanation will be sufficient. The next question is, are KNN and K-means clustering similar to one another, or are they same? Right, because the letter K is kind of common between them. Okay, so let us take a little while to understand what these two are. One is KNN, another is K-means. KNN stands for K nearest neighbors, and K means, of course, is the clustering mechanism. Now, these two are completely different, except for the letter K being common between them. KNN is completely different. K means clustering is completely different. KNN is a classification process, and therefore it comes under supervised learning, whereas K-means clustering is actually unsupervised. Okay, when you have KNN, when you want to implement KNN, which is basically K nearest neighbors, the value of K is a number. So you can say K is equal to 3. You want to implement KNN with K is equal to 3. So which means that it performs the classification in such a way that, how does it perform the classification? So it will take 3 nearest objects, and that's why it's called nearest neighbor. So basically based on the distance, it will try to find out its nearest objects that are, let's say, 3 of the nearest objects, and then it will check whether the class they belong to which class, right? So if all 3 belong to one particular class, obviously this new object is also classified as that particular class. But it is possible that they may be from 2 or 3 different classes. Okay, so let's say they are from 2 classes, and then if they are from 2 classes, now usually you take a odd number, you assign an odd number to. So if there are 3 of them and 2 of them belong to one class and then 1 belongs to another class, so this new object is assigned to the class to which the 2 of them belong. Now, the value of K is sometimes tricky, whether should you use 3, should you use 5, should you use 7. That can be tricky because the ultimate classification can also vary. So it's possible that if you're taking K as 3, the object is probably in one particular class, but if you take K is equal to 5, maybe the object will belong to a different class, because when you're taking 3 of them, probably 2 of them belong to class 1 and 1 belong to class 2. Whereas when you take 5 of them, it is possible that only 2 of them belong to class 1 and 3 of them belong to class 2. So which means that this object will belong to class 2, right? So you see that? So the class allocation can vary depending on the value of K. Now, K-means, on the other hand, is a clustering process, and it is unsupervised, where what it does is the system will basically identify how close the objects are with respect to some of their features. Okay, but the similarity, of course, is the letter K, and in case of K-means also we specify its value, and it could be 3 or 5 or 7. There is no technical limit as such, but it can be any number of clusters that you can create. Okay, so based on the value that you provide, the system will create that many clusters of similar objects. So there is a similarity to that extent that k is a number in both the cases, but actually these two are completely different processes. We have what is known as Naïve Bayes classifier, and people often get confused thinking that Naïve Bayes is the name of the person who found this classifier or who developed this classifier, which is not 100% true. Bayes is the name of the person, Bayes is the name of the person, but naive is not the name of the person, right? So naive is basically an English word, and that has been added here because of the nature of this particular classifier. Naive Bayes classifier is a probability based classifier, and it makes some assumptions that presence of one feature of a class is not related to the presence of any other feature of maybe other classes, right? So which is not a very strong or not a very accurate assumption, because these features can be related and so on. But even if we go with this assumption, this whole algorithm works very well even with this assumption, and that is the good side of it. But the term comes from there, so that is the explanation that you can give. Then there can be question around reinforcement learning. It can be paraphrased in multiple ways. One could be, can you explain how a system can play a game of chess using reinforcement learning? Or it can be any game. So the best way to explain this is again to talk a little bit about what reinforcement learning is about, and then elaborate on that to explain the process. So first of all, reinforcement learning has an environment and an agent, and the agent is basically performing some actions in order to achieve a certain goal. And these goals can be anything, either if it is related to game, then the goal could be that you have to score very high, score a high value, high number. Or it could be that your number of lives should be as high as possible. Don't lose lives. So these could be some of them. More advanced examples could be for driving. In the automotive industry, self-driving cars, they actually also make use of reinforcement learning to teach the car how to navigate through the roads and so on and so forth. That is also another example. Now, how does it work? So if the system is basically there is an agent and environment, and every time the agent takes a step or performs a task which is taking it towards the goal, the final goal, let's say to maximize the score or to minimize the number of lives and so on, or minimize the deaths, for example, it is rewarded. And every time it takes a step which goes against that goal, right, contrary or in the reverse direction, it is penalized. Okay, so it is like a carrot and stick system. Now, how do you use this to create a game of chess, or to create a system to play a game of chess? Now, the way this works is, and this could probably go back to this AlphaGo example where AlphaGo defeated a human champion. So the way it works is, in reinforcement learning, the system is allowed, for example, if in this case we are talking about chess, so we allow the system to first of all watch playing a game of chess. So it could be with a human being, or it could be the system itself. There are computer games of chess, right? So either this new learning system has to watch that game or watch a human being play the game, because this is reinforcement learning is pretty much all visual. So when you're teaching the system to play a game, the system will not actually go behind the scenes to understand the logic of your software, of this game or anything like that. It is just visually watching the screen and then it learns. Okay, so reinforcement learning to a large extent works on that. So you need to create a mechanism whereby your model will be able to watch somebody playing the game, and then you allow the system also to start playing the game. So it pretty much starts from scratch. Okay, and as it moves forward, it's right at the beginning, the system really knows nothing about the game of chess. Okay, so initially it is a clean slate. It just starts by observing how you're playing. So it will make some random moves and keep losing badly. But then what happens is, over a period of time, so you need to now allow the system, or you need to play with the system, not just 1, 2, 3, 4 or 5 times, but hundreds of times, thousands of times, maybe even hundreds of thousands of times. And that's exactly how AlphaGo has done. It played millions of games between itself and the system, right? So for the game of chess also, you need to do something like that. You need to allow the system to play chess and then learn on its own over a period of repetition. So I think you can probably explain it to this extent, and it should be sufficient. Now, this is another question which is again somewhat similar, but here the size is not coming into picture. So the question is, how will you know which machine learning algorithm to choose for your classification problem? Now, this is not only classification problem, it could be a regression problem. I would like to generalize this question. So if somebody asks you, how will you choose? How will you know which algorithm to use? The simple answer is there is no way you can decide exactly saying that this is the algorithm I'm going to use. In a variety of situations, there are some guidelines. Like for example, you will obviously, depending on the problem, you can say whether it is a classification problem or a regression problem. And then in that sense, you are kind of restricting yourself to, if it is a classification problem, you can only apply a classification algorithm, right? To that extent, you can probably, let's say, limit the number of algorithms. But now within the classification algorithms, you have decision trees, you have SVM, you have logistic regression. Is it possible to outright say, yes, so for this particular problem, since you have explained this, now this is the exact algorithm that you can use? That is not possible. Okay, so we have to try out a bunch of algorithms, see which one gives us the best performance and best accuracy, and then decide to go with that particular algorithm. So in machine learning, a lot of it happens through trial and error. There is no real possibility that anybody can, just by looking at the problem or understanding the problem, tell you that, okay, in this particular situation, this is exactly the algorithm that you should use. Then the questions may be around application of machine learning. And this question is specifically around how Amazon is able to recommend other things to buy. So this is around recommendation engine. How does it work? How does the recommendation engine work? So this is basically the question is all about. So the recommendation engine again works based on various inputs that are provided. Obviously something like Amazon, a website or e-commerce site like Amazon collects a lot of data around the customer behavior, who is purchasing what. And if somebody is buying a particular thing, they're also buying something else. So this kind of association, right? So this is the unsupervised learning we talked about. They use this to associate and link or relate items. And that is one part of it. So they kind of build association between items, saying that somebody buying this is also buying this. That is one part of it. Then they also profile the users, right? Based on their age, their gender, their geographic location. They will do some profiling, and then when somebody is logging in and when somebody is shopping, kind of the mapping of these two things are done. They try to identify, obviously if you have logged in, then they know who you are and your information is available, like for example your age, maybe your gender, and where you're located, what you purchased earlier, right? So all this is taken, and the recommendation engine basically uses all this information and comes up with recommendations for a particular user. So that is how the recommendation engine works. All right, then the question can be something very basic, like when will you go for classification versus regression, right? When do you do classification instead of regression, or when will you use classification instead of regression? Now, yes, so this is basically going back to the understanding of the basics of classification and regression. So classification is used when you have to identify or categorize things into discrete classes. So the best way to respond to this question is to take up some examples and use it. Otherwise, it can become a little tricky. The question may sound very simple, but explaining it can sometimes be very tricky. In case of regression, we use, of course, there will be some keywords that they will be looking for. So just you need to make sure you use those keywords. One is the discrete values, another is the continuous values. So for regression, if we are trying to find some continuous values, you use regression. Whereas if you're trying to find some discrete values, you use classification. And then you need to illustrate. What are some of the examples? So classification is like, let's say there are images and you need to put them into classes like cat, dog, elephant, tiger, something like that. So that is a classification problem. Or it can be, that is a multi-class classification problem. It could be binary classification problem, like for example, whether a customer will buy or he will not buy. that is a classification, binary classification. It can be in the weather forecast area. Now, weather forecast is again combination of regression and classification, because on the one hand, you want to predict whether it's going to rain or not. That's a classification problem. That's a binary classification, right? Whether it's going to rain or not rain. However, you also have to predict what is going to be the temperature tomorrow, right? Now, temperature is a continuous value. You can't answer the temperature in a yes or no kind of a response, right? So what will be the temperature tomorrow? So you need to give a number, which can be like 20 degrees, 30 degrees or whatever. Right? So that is where you use regression. One more example is stock price prediction. So that is where again you will use regression. So these are the various examples. So you need to illustrate with examples and make sure you include those keywords like discrete and continuous. So the next question is more about a little bit of a design related question to understand your concepts and things like that. So it is, how will you design a spam filter? So how do you basically design or develop a spam filter? So I think the main thing here is he is looking at probably understanding your concepts in terms of what is the algorithm you will use, or what is your understanding about difference between classification and regression and things like that, right? And the process, of course, the methodology and the process. So the best way to go about responding to this is we say that, okay, this is a classification problem because we want to find out whether an email is a spam or not spam, so that we can apply the filter accordingly. So first thing is to identify what type of a problem it is. So we have identified that it is a classification. Then the second step may be to find out what kind of algorithm to use. Now, since this is a binary classification problem, logistic regression is a very common algorithm. But however, right, as I said earlier also, we can never say that, okay, for this particular problem, this is exactly the algorithm that we can use. So we can also probably try decision trees or even support vector machines, for example, SVM. So we will kind of list down a few of these algorithms and we will say, okay, we would like to try out these algorithms. And then we go about taking your historical data, which is the labeled data, which are marked. So you will have a bunch of emails, and then you split that into training and test data sets. You use your training data set to train your model or your algorithm that you have used, or rather the model actually. So, and you actually will have three models. Let's say you are trying to test out three algorithms, so you will obviously have three models. So you need to try all three models and test them out as well, see which one gives the best accuracy, and then you decide that you will go with that model. Okay, so training and test will be done, and then you zero in on one particular model, and then you say, okay, this is the model we will use, and then go ahead and implement that or put that in production. So that is the way you design a spam filter. The next question is about random forest. So what is random forest? So this is a very straightforward question. However, the response, you need to be again a little careful. While we all know what is random forest, explaining this can sometimes be tricky. So one thing is, random forest is kind of, in one way, it is an extension of decision trees, because it is basically nothing but you have multiple decision trees, and trees will basically, we will use for doing, if it is classification, mostly it is classification, you will use the trees for classification, and then you use voting for finding the final class. So that is the underlying. But how will you explain this? How will you respond to this? So first thing, obviously, we will say that random forest is one of the algorithms, and the more important thing that you need to, probably the interviewer is waiting to hear, is ensemble learner, right? So this is one type of ensemble learner. What is ensemble learner? Ensemble learner is like a combination of algorithms. So it is a learner which consists of more than one algorithm or more than one maybe models. Okay, so in case of random forest, the algorithm is the same, but instead of using one instance of it, we use multiple instances of it, and we use. So in a way, that is a random forest is an ensemble learner. There are other types of ensemble learners where we have, like, we use different algorithms itself. So you have one maybe logistic regression and a decision tree combined together, and so on and so forth. Or there are other ways, like for example, splitting the data in a certain way and so on. So that's all about ensemble. We will not go into that. But random forest itself, I think the interviewer will be happy to hear this word ensemble learner. And so then you go and explain how the random forest works. So if the random forest is used for classification, then we use what is known as a voting mechanism. So basically, how does it work? Let's say your random forest consists of 100 trees, okay, and each observation you pass through this forest, and each observation, let's say it is a classification problem, binary classification 0 or 1, and you have 100 trees. Now if 90 trees say that it is a 0 and 10 of the trees say it is a 1, you take the majority, you may take a vote, and since 90 of them are saying 0, you classify this as 0. Then you take the next observation and so on. So that is the way random forest works for classification. If it is a regression problem, it's somewhat similar, but only thing is, instead of vote, what we will do is, so in regression, remember what happens, you actually calculate a value, right? So for example, you're using regression to predict the temperature, and you have 100 trees, and each tree obviously will probably predict a different value of the temperature. They may be close to each other, but they may not be exactly the same value. So these 100 trees. So how do you now find the actual value, the output for the entire forest, right? So you have outputs of individual trees which are a part of this forest, but then you need to find the final output of the forest itself. So how do you do that? So in case of regression, you take like an average or the mean of all the 100 trees, right? So this is also a way of reducing the error. So maybe if you have only one tree, and if that one tree makes an error, it is basically 100% wrong or 100% right? But if you have, on the other hand, if you have a bunch of trees, you are basically mitigating that error, reducing that error. Okay, so that is the way random forest works. So the next question is, considering the long list of machine learning algorithms, how will you decide on which one to use? So once again, here there is no way to outright say that this is the algorithm that we will use for a given data set. This is a very good question, but then the response has to be like, again, there will not be a one size fits all. So we need to, first of all, you can probably shorten the list in terms of by saying, okay, whether it is a classification problem or it is a regression problem. To that extent, you can probably shorten the list, because you don't have to use all of them. If it is a classification problem, you only can pick from the classification algorithms, right? So for example, if it is a classification, you cannot use linear regression algorithm there. Or if it is a regression problem, you cannot use SVM, or maybe, no, you can use SVM, but maybe a logistic regression, right? So to that extent, you can probably shorten the list, but still you will not be able to 100% decide on saying that this is the exact algorithm that I'm going to use. So the way to go about is, you choose a few algorithms based on what the problem is. You try out your data, you train some models of these algorithms, check which one gives you the lowest error or the highest accuracy, and based on that, you choose that particular algorithm. Okay. All right. Then there can be questions around bias and variance. So the question can be, what is bias and variance in machine learning? So you just need to give out a definition for each of these. For example, bias in machine learning, it occurs when the predicted values are far away from the actual value. So that is a bias. Okay. And whereas they are all the values are probably, they are far off, but they are very near to each other though. The predicted values are close to each other, right? While they are far off from the actual value, but they are close to each other. You see the difference? So that is bias. And then the other part is your variance. Now variance is when the predicted values are all over the place, right? So if the variance is high, that means it may be close to the target, but it is kind of very scattered. So the predicted values are not close to each other, right? In case of bias, the predicted values are close to each other, but they are not close to the target. But here they may be close to the target, but they may not be close to each other. So they are a little bit more scattered. So that is what in case of a variance. Okay, then the next question is about, again, related to bias and variance. What is the trade-off between bias and variance? Yes, I think this is an interesting question, because these two are heading in different directions. So for example, if you try to minimize the bias, variance will keep going high, and if you try to minimize the variance, bias will keep going high, and there is no way you can minimize both of them. So you need to have a trade-off saying that, okay, this is the level at which I will have my bias and this is the level at which I will have variance. So the trade-off is that pretty much that you decide what is the level you will tolerate for your bias and what is the level you will tolerate for variance, and a combination of these two in such a way that your final results are not way off. And having a trade-off will ensure that the results are consistent, right? So that is basically the output is consistent, and which means that they are close to each other, and they are also accurate. That means they are as close to the target as possible, right? So if either of these is high, then one of them will go off the track. Define precision and recall. Now again, here I think it would be best to draw a diagram and take the confusion matrix, and it is very simple. The definition is like a formula. Your precision is true positive by true positive plus false positive, and your recall is true positive by true positive plus false negative. Okay, so that's, you can just show it in a mathematical way. That's pretty much that can be shown. That's the easiest way to define. So the next question can be about decision tree. What is decision tree pruning and why is it? So basically, decision trees are really simple to implement and understand, but one of the drawbacks of decision trees is that it can become highly complicated as it grows, right? And the rules and the conditions can become very complicated, and this can also lead to overfitting, which is basically that during training you will get 100% accuracy, but when you're doing testing you will get a lot of errors. So that is the reason pruning needs to be done. So the purpose or the reason for doing decision tree pruning is to reduce overfitting or to cut down on overfitting. And what is decision tree pruning? It is basically that you reduce the number of branches, because as you may be aware, a tree consists of the root node, and then there are several internal nodes, and then you have the leaf nodes. Now if there are too many of these internal nodes, that is when you face the problem of overfitting, and pruning is the process of reducing those internal nodes. Alright, so the next question can be, what is logistic regression? So basically, logistic regression is one of the techniques used for performing classification, especially binary classification. Now, there is something special about logistic regression, and there are a couple of things you need to be careful about. First of all, the name is a little confusing. It is called logistic regression, but it is used for classification. So this can be sometimes confusing. So you need to probably clarify that to the interviewer if it's really, if it is required. And they can also ask this like a trick question, right? So that is one part. Second thing is, the term logistic has nothing to do with the usual logistics that we talk about, but it is derived from log. So that the mathematical derivation involves log, and therefore the name logistic regression. So what is logistic regression and how is it used? So logistic regression is used for binary classification, and the output of a logistic regression is either a 0 or a 1, and it varies. So it's basically, it calculates a probability between 0 and 1, and we can set a threshold that can vary. Typically it is 0.5. So any value above 0.5 is considered as 1, and if the probability is below 0.5, it is considered as 0. So that is the way we calculate the probability, or the system calculates the probability, and based on the threshold it sets a value of 0 or 1, which is like a binary classification, 0 or 1. Okay, then we have a question around k nearest neighbor algorithm. So explain k nearest neighbor algorithm. So first of all, what is a k nearest neighbor algorithm? This is a classification algorithm. So that is the first thing we need to mention. And we also need to mention that the k is a number. It is an integer. and this is variable, and we can define what the value of k should be. It can be 2, 3, 5, 7, and usually it is an odd number, so that is something we need to mention. Technically it can be even number also, but then typically it would be odd number, and we will see why that is. Okay, so based on that, we need to classify objects. Okay, we need to classify objects. So again, it will be very helpful to draw a diagram. If you're explaining, I think that will be the best way. So draw some diagram like this, and let's say we have 3 clusters or 3 classes existing, and now you want to find for a new item that has come, you want to find out which class this belongs to, right? So you go about, as the name suggests, you go about finding the nearest neighbors, right? The points which are closest to this, and how many of them you will find, that is what is defined by k. Now let's say our initial value of k was 5. Okay, so you will find the 5 nearest data points. So in this case, as it is illustrated, these are the 5 nearest data points. But then all 5 do not belong to the same class or cluster. So there are one belonging to this cluster 1, the second one belonging to this cluster 2, 3 of them belonging to this third cluster. Okay, so how do you decide? That's exactly the reason we should, as much as possible, try to assign an odd number so that it becomes easier to assign this. So in this case, you see that the majority, actually, if there are multiple classes, then you go with the majority. So since 3 of these items belong to this class, we assign, which is basically the, in this case, the green or the tennis or the third cluster, as I was talking about. Right, so we assign it to this third class. So in this case, it is that's how it is decided. Okay, so k nearest neighbors. So first thing is to identify the number of neighbors that are mentioned as k. So in this case, it is k is equal to 5. So we find the 5 nearest points, and then find out of these 5 which class has the maximum number in that. Okay, and then the new data point is assigned to that class. Okay, so that's pretty much how k nearest neighbors work.
With that, we have reached the end of this session. If you have any questions, please feel free to comment, and we'll have it answered for you as soon as possible. Until next time, thank you for watching. Stay safe, keep learning, and get ahead.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click